Hey, what's going on, guys? Welcome to my JavaScript algorithms and data structures course. Now, this course is different than anything I've done before. Most of my catalog includes very practical project-based courses and tutorials, but I wanted to do something different, and in addition to giving you those practical skills, I wanted to create something that will build your fundamental skills for programming and problem solving. And I also wanted to create something that will help you with those overwhelming tech interviews for those of you that are looking to get a job. Because a lot of what we talk about in this course are used in both entry level and even senior level positions when it comes to the whole interview process. Now, with that said, there's three really important points that I need everyone to know before taking this course. So number one, this is structured as a challenges course. This means that in many of the videos, I'd say most of the videos, there's a clear problem to solve. And I can't stress this enough. You don't have to take on the challenges on your own. You know, I created this course in a way where you can follow along with me. I explain the solution to you. I explain just about every line of code so that you can learn new ways to solve problems, learn about different syntax, different methods, etc. Now, of course, if you feel like you have the knowledge to solve some of the problems on your own, then that's great, and I encourage that. Pause the video, try it yourself, etc. But you don't have to do that. It's absolutely fine if you don't even try any of them on your own and you just use it as a learning course. All right, so I definitely just want to get that out there. The second point that I want to make is, even though this is a JavaScript course, about 95% of the stuff that we're going to do here can be applied to just about any language, from iteration to recursion to all the different data structures like stacks, binary trees, etc. These are just fundamental computer science topics. And JavaScript is just the syntax that I chose because that's my language of choice. I could have even used pseudocode if I wanted to. My point is that even if you're a Python or PHP or C# developer, you could still technically follow along with this course. And then the last point that I want to make is that this is an intermediate course. It's not for absolute beginners. I'm not going to be explaining what a function or what a loop is. I expect you to know that stuff. And if you took my modern JavaScript from the beginning course, then you're at the perfect level for this one. It's also not an extremely advanced course. We do get into things like binary trees and sorting algorithms and recursion, but we're starting out as if you really don't know any of this stuff yet. So don't be overwhelmed. As long as this isn't your very first JavaScript or programming course, then you're going to be fine. And as far as the whole environment goes, what we'll be working with, I've created a sandbox that includes the Jest testing framework, so you'll be able to test all of your solutions. I have complete documentation for every single video, including all solutions and all the explanations. This course took me about 4 months to complete, so I hope you enjoy it, and let's get into it. Okay, so I just want to give you a quick overview of the course sections and what you'll be learning. And like I said, I created a sandbox with full documentation and testing. Now, the sandbox is broken up into 9 parts or 9 different sections. And the first 2 sections are called Basic Challenges 1 and Basic Challenges 2. And these are fairly easy challenges, and for the most part, they include looping and iteration, which are very important in just computer science in general and in fundamentals. So we'll be writing a lot of for loops in this section. And a lot of what we're going to do in these 2 sections are actually challenges that you may be asked to do during a job interview. Challenges such as FizzBuzz, reverse strings, things like that. So if you feel comfortable, you can try these challenges on your own and then watch the solution to see what I came up with. And I just also want to mention that there's so many different solutions that are possible to all of these challenges. Now, like I said, section 1 and 2 we'll be writing a lot of for and while loops, keeping things very low level. And then in section 3, we're going to get more into high order array methods like filter, map, reduce. I think that these are extremely important in JavaScript. If you're following along with another language, then you may want to skip this part because it is very JavaScript centric, but that's up to you. Now, in section 4, we're going to get into something that intimidates a lot of developers, and that's recursion. And this is where we call a function within itself and we break things down into smaller parts until we reach what's called a base case. So we'll learn what recursion is. We'll do about 10 different challenges using recursion, and we'll also compare recursion to iteration and looping. And then in section 5, we're going to start talking about time complexity. And this is a very important topic when it comes to algorithms and data structures. We'll learn about something called big O notation and how to calculate the time complexity of a function, meaning how does the time it takes to run a function increase as the input increases. And we'll also talk a little bit about space complexity, which is how much memory is used as the input increases. All right, then from that point on, we'll mention complexity for some of the other functions and some of the other algorithms and solutions that we go through. And then section 6, we're going to start to get into data structures pretty heavily. We're going to start with 2 data structures that are built into JavaScript, and those are maps and sets. These are both, they're both called hash tables, or they both use hash tables. And we're going to learn what hash tables are, how they work. And after we look at maps and sets, we're going to implement our own hash table data structure using a JavaScript class. Okay, so we'll create the same methods that are in the built-in map data structure, but we'll do it custom with our own custom hash table. And then in section 7, we're going to get into structures like stacks, queues, linked lists. These are all linear data structures. We'll learn what they are, how they work, how to implement them. And then we'll also do a few challenges with those data structures. And there's some other things baked into this section as well, such as the fast and slow pointer technique. We'll also look at both singly and doubly linked lists. And then in section 8, we're going to get a bit more complex because we're going to be dealing with trees. We're going to look at depth first traversals and breadth first traversals. And then we're going to move on to graph data structures, which are similar to trees, so I think they fit together well. And we'll learn how to traverse graphs as well. And then in section 9, we're going to be talking about sorting algorithms such as bubble sort, insertion, merge sort, and so on. And we'll learn how to implement them and compare them to each other. All right, so that's the plan for now. There's some other possible topics that I may add in the future, but I think that this is a great start for just about any level. So I hope you enjoy the course, and I'll see you in the next video. Okay, so before we get into anything else, let's talk about what algorithms and data structures are and talk about some reasons why you should learn this stuff. So an algorithm is basically a set of instructions to complete a task. So if you're writing a function that reverses a string or sorts an array, that's an algorithm. If you're writing a function that traverses a binary tree, that's an algorithm. So you get the idea. And we have about 100 algorithms in this course. Now, a data structure is a way to organize data in a way that makes it easy to work with. So for example, an array is a data structure, and some data structures are built into certain languages. So for instance, if we're looking at JavaScript, we have arrays, objects, we also have maps and sets. If we look at Python, we have lists, tuples, dictionaries. But we can also create our own data structures, and we'll be doing that quite a bit in this course. So for instance, we're going to create a hash table, stacks, queues, linked lists, binary trees, graphs. For the most part, we're going to do this by creating custom JavaScript classes and also adding methods to those classes so we can work with the data. All right, and these two go together hand in hand, because we use data structures to store data, and then we use algorithms to manipulate that data. So for example, we can use a linked list to store a list of names, and then we can use an algorithm to traverse that linked list and print out all the names. That's a very simple example. We can use a binary tree to store a list of numbers, and then use an algorithm to traverse that tree to find the largest number. And the first part of this course is all about algorithms and challenges. And the second part is all about data structures, although we'll still be using algorithms to manipulate the data in those structures. Okay, and we'll have challenges all throughout the course. Now, some general reasons why you should learn this stuff, and this is kind of my own opinion and my own point of view, but I was one of those developers that never really thought much of algorithms and data structures. I'm a very practical developer. I enjoy creating projects, and for a lot of years, I equated algorithms to something like math problems, and I just didn't see the practical use. And I know a lot of developers feel the same way. I'm sure that a lot of you guys feel that way. However, over the past year or so, I've really gotten deeper into computer science in general, and I've realized how important this stuff is and how much it can help you, whether you're developing, low-level software using C++ or something like that, or you're doing front-end UIs with React. It helps you just be a better programmer in general. And I've also realized that it's not as hard as I thought it was. I think a lot of developers are intimidated by this stuff, but I think that's mostly because they haven't really been too exposed to it. They haven't really tried it out. So let's look at a couple reasons why you should learn this stuff. And again, this is kind of my own opinion, but I'd say one of the biggest reasons is to master problem solving. Programming is all about solving problems efficiently and elegantly. And not only this course, but just algorithms and data structures in general are going to improve your problem solving skills and will equip you with techniques to approach challenges with an analytical mindset. And I've learned that you can't just jump in blindly and start coding. You need to have a plan, and you need to think about the problem and how you're going to solve it. And this is something I've gotten better at over the last few years. So this stuff isn't just to pass a tech interview, but it will make you a better developer and help you with problem solving in general. Now, speaking of passing interviews, that is another reason to learn the stuff that's in this course. I personally am not a big fan of a lot of the methods that large companies use during the interview process, especially where they give you some challenge and they don't allow you to prepare for it. They don't allow you to look at any resources. I don't really think that's a great way to judge a developer, but unfortunately, that's the way it is. And if you want to get a job with a large company, then you need to know this stuff. So I've researched a lot of the challenges and questions that companies like Google and Amazon and Microsoft, companies like that, use in their interview process, from entry-level FizzBuzz type questions to more advanced questions about binary trees, sorting algorithms, and recursion. And I've included a lot of them in this course. So that's another reason. Reason number 3, I'd say, is to write more efficient code. And I'm far from the stickler that thinks every line of code that you write needs to be the absolute optimized way to do it. But I do think that it's important to think about how efficient your code is. And this is where things like time complexity and big O notation come in, which we'll talk about in this course. And I think that if you're aware of this stuff, then you'll be more likely to write more efficient code without even really thinking about it. And then number 4, I'd say that you're going to need these skills someday. A lot of people that take my courses are beginners, so it's hard to really see where this stuff fits in when you're just starting out. Where does traversing a tree fit into building a to-do list app? It doesn't really. But you're not always going to be a beginner, and you're not always going to be working on simple apps. You may be working on a very large-scale application that needs to be efficient, and you may be working on a game that needs to be optimized, or a back-end system that needs to be scalable. And this is where that stuff really comes in handy, or this stuff comes in handy. And I also think that that's why a lot of these companies ask these questions during interviews, because they want to know that you have the skills or the possible skills to work on large-scale applications. And then I'd say the last reason is it's just fun. I mean, even without the growth in problem-solving skills and the ability to pass interviews and the ability to write more efficient code, this stuff is just fun. I mean, for a lot of people, not for everyone, obviously. It just feels good to solve a problem, and it feels good to just talk with other developers about this stuff. But, those are my kind of 5 reasons why I think that data structures and algorithms and just problem solving in general are important. Okay, so we're going to be using a set of files that I call a sandbox that has all the challenges, the solutions, the README files, the tests, all that stuff. And I'm going to get into that I believe in the next video or the one after, but I just want to go over the very basic tools that you have to take this course. So obviously you need a code editor or an IDE. I personally would suggest Visual Studio Code, and I suggest it more so in this course than a lot of my other ones just because of the way that we're going to be doing this. We're going to be using a specific extension called Code Runner. You can get by using something else, but again, I would urge you to use Visual Studio Code. Now, you're going to need Node.js because the way that we're running our JavaScript, we're not dealing with the browser at all in this course. So the browser isn't what's going to be running our JavaScript. Node.js is, which is a runtime that will basically just run JavaScript on your computer rather than within the browser environment. So you're going to have to just download it, install it. Very, very simple. If you haven't done it before, just download it, click next, and go through the installer, and you should be all set. There's no extra steps after that. So ChatGPT is a great resource, and I don't think enough people mention this in courses, but if you have a problem in the course and there's something that I say that you don't understand, you can take the exact code, put it in ChatGPT, and ask specific questions, because obviously I'm not right there to ask, but ChatGPT just does a great job. And if you need something else clarified, just keep it open while you're taking the course, and anything you need to have, supplement learning from, then you can use ChatGPT. So you definitely want to get installed on your computer. You want to be using version control. We do have a Git repository with all the code, all the solutions and everything in it, but I would still recommend that you create your own repo and you make commits every so often. And then Jest is the testing utility that we'll be using. You don't have to do anything here. There's nothing you have to download. We're going to be installing it using NPM, which comes with Node.js, but I just wanted to just kind of let you know that we'll be using Jest, and it is a JavaScript testing framework. So as far as extensions, so this is VS Code, and I'm just going to go to my extensions here. There's only a couple that you really need. I would suggest getting some kind of Markdown previewer. I use Markdown Preview Enhanced. Basically what this allows me to do is for the README files, I can just right-click and Markdown Preview Enhanced, and then I have all the formatted code. Everything's nice and neat. The solutions, we have these little drop-downs with the explanations. So I would definitely suggest installing that or something like it. And then Code Runner, and I mentioned this in another video as well, but Code Runner is great because we can go to our JavaScript run files, like let's say this one right here, and instead of having to open the terminal and navigate to this file, I can simply right-click Run Code, and you'll see that it outputs 2 here. Okay, so that's definitely something I would suggest for this course. And aside from that, maybe just Prettier, which is a code formatter. So this will allow you to format your code. If I go to my settings, let's see, if we go to settings and we search for Prettier, there's some options you might want to check out. So as far as, let's see, like, what did I want to show you here? Like quotes. So for instance, I use single quotes, so I have single quote checked, and that will make it automatically single quote. Even if I put double quote in, when I save, it'll get changed to single. I'm using semicolons, so if I forget a semicolon and I save, it will add it. If you don't want to use semicolons, you can uncheck this, and then it will remove any semicolons when you save. Yeah, single quote right here. I use a tab width of 2. So just, it's really preference, but I would suggest using a code formatter, because if I go into this file here, right, and just uncomment this, and I have this if statement way over here, maybe I have this way over here like that, and then I save, it fixes it for me. So you definitely want something like that. Now to have that fix on save option, if you go to settings and you say, what is it? Let me just type in save here. Format on save. So you just want to make sure that that is checked if you want that functionality, which I definitely would suggest. And then all of our files should be pretty much in sync and have the same format. But that's pretty much it. It's simple. As far as jest goes, I'm going to show you how we're going to install that. You can see we have a package.json file that has this jest here. So all we have to do is run npm install, and it will install jest, and then we can run our test files, which every challenge has, as you can see right here. Here's an example of a test file. Okay, so that's it. Let's move on to the next video. Okay, so in this video and probably the next 1 or 2 videos, I just want you to get familiar with the sandbox, which I just called Traversy JS challenges. And the sandbox is just what I call the files and folders that we'll be working in. We'll be writing our code in, we'll be testing our code in, and there's also a lot of information in README files. Basically, this is the entire course in written form. And it's on GitHub, so you can clone it. I'll also include it in the downloads for this particular video. Now, you can view this stuff on GitHub. I have README files, so this is the main README file. It explains all the different files that are in each challenge. Just some other stuff here, how to run your tests, because we do have jest. You're going to run npm install, which will install jest as a dependency, and then you can run your tests, although you do have to replace the dash test with dot test in order for jest to pick it up. And then there's an index of challenges here, or you can just click up here. So basic challenges. So if I click on hello world, that'll show me the markdown file that has the instructions, examples, hints. The solution here is in a little drop down. So you can use GitHub, or what I would suggest, because you're going to have to do this anyway, is download it and open it in VS Code or whatever text editor you're using. So if we look at the hello world here, you'll see the files, and then the README file is where, like I just showed you, the instructions and all that. And you can look at it like this, but I would suggest using a markdown previewer. So for VS Code, you have this you have a lot, but what I use is Markdown Preview Enhanced. That way I can just right click and I can say Markdown Preview Enhanced, and then it will show me the formatted Markdown. And it'll have the function signature, which will have any arguments, the data type that should be returned, some examples with the output that you should get, any constraints, any hints, the solution with an explanation, and then any jest test cases. Okay, so that's the README. Now there's some other files here. Whatever the challenge name is, .js, that's the file you're going to be working in, and you'll see as we move along how this will all work. But as you can see, I just created the function and I exported it. And then in the run file is where you actually run the function, and I would definitely suggest that you install Code Runner if you're using VS Code. So this will allow you to easily run your code, because if you don't install it, what you're going to have to do is come down into the terminal and run node. You're going to have to go to, 01 basic challenges, 01 hello world, all the way to this run file, where if you install Code Runner, you can simply right click and then hit run code, and it will show your output. So you can see it ran it for us instead of us having to type it out. So definitely I would suggest a Markdown Preview extension as well as Code Runner, just to make things easier for you and you can follow along. So in addition to that, I have the solution file, which is just going to be the solution, and it's going to be heavily commented pretty much every line, just so you know. I want you guys to know exactly what's going on. I don't want to just do the challenge and move on. I want you to really understand it. So you'll have the comments, and then you'll also, in the README file, you'll also have the explanation of the solution. And then finally, we have the test file, which is a jest test, and you don't have to know jest. All the tests are already written. If you want to look at them and study the test, you can. I might even do a separate course where we learn test-driven development and we use these tests. But all you have to do is rename it from dash test to dot test. Okay, then you can go to the terminal and go into the root here and run npm test, right? And if I do it now, it's going to tell me there's no tests, right? Let's see, where does it tell me that? No tests found, and that's because every test file is dash test. If I rename this, right, so if I rename it to dot test, and then I run npm test, it shows one test and it failed, obviously, because there's nothing in, it's an empty function, right? So it'll tell us what it expects. So Jest is a really great testing framework. So it tells us what it expected and what we received. All right, so I'll just rename that back for now because we're going to do that in the next video. But yeah, so that's pretty much how the challenges are going to be structured. Now there are other files or other folders that have files that aren't tests, that are just for learning. For instance, if we go to complexity, this is where I explain time complexity and big O notation, the different types of time complexity, and those just have a README file. And I would still suggest using Markdown Preview, just because it's formatted better. Some of these have images, like for instance, if we look at, I believe this has an image. So if we preview this one, yeah, you can see we have some images to explain things, and I'll be using those throughout the course. And let's see, if we look at like these are our data structures, so stacks, queues, and stuff like that. Basically, we'll talk about, what is a stack. Oops, not run code. I wanted to preview. So here I'll explain, how a stack works, and then we'll implement a stack. And this is set up as a challenge. Again, you don't have to do this as a challenge. It's just set up as one. So there are tests that will, this will test to see if our class works as a stack should work. We have the solution. So you can see there's a comment pretty much for every line. But yeah, so that's how everything is set up. So in the next video, we'll go ahead and start on our first ridiculous challenge. It's basically just console logging hello world. But again, it's just to kind of get you into the swing of things. All right, guys, so the first 3 challenges or so are just ridiculously simple, and they're just here to kind of get you into the hang of using these files and knowing where to write your solution and how to test. So the first one is literally just returning a string of hello world. So write a function called hello world that returns a string of hello world with an exclamation. And if we look at the signature, there's no arguments, and it returns a string. Here's an example. If we log the hello world function, then it's going to log that. All right, and not really any hints. You don't need any. So let's go into hello world.js, and let's go ahead and return. And this is where you would pause the video and try it yourself if you're going to take the course that way. I'm sure all of you know how to do this, though. So we're going to return a string of hello world with an exclamation. Okay, so in the run file, it's already being brought in, and it's already being called and put into this variable and then logged. So we can just simply run code with the code runner, and you can see it prints out hello world. So to run our test, we're just going to rename the -test file to .test. Okay, that's the convention. You can see that the icon even changed because it knows that this is a just test. So now we can go into the terminal and just simply run npm test. And now you can see we have one test that was ran and it was passed. All right, so that's pretty much the the order that we'll be doing things for each challenge. We won't always use the run file, but it's there in case we want to console log something. I'm trying to show you something, but that's pretty much how we'll be doing things. All right, so the next one, get some, is also very, very simple. So let's get into that next. Okay, so this is another very, very simple challenge. It says write a function called getSum that takes in 2 numbers and returns the sum of those 2 numbers. So if we look at the signature, it takes in one number, we can call it A, another number, call it B, and then the return is going to be the sum of those numbers. And you have some examples here. So very, very simple. As a hint, you can use the plus operator to add 2 numbers together. I guess that's all I could really think of as far as hints. So let's go into our getSum.js, and we're going to pass in A and B, and we're going to return A plus B. Okay, if we wanted to run the run file, we could do that. So that gives us 11, because you can see we're passing in 1 and 10. Now to test it, that was testing it, but it was manual. To test with Jest, we need to rename this file to .test. And then we can come down into our terminal, npm test, and now we should have 2 passing tests, okay? Because it's going to count all of the other tests in this whole thing as well. Now let's just see what a failing test looks like. So I'll do subtraction instead of adding. So let's go ahead and run that. And now you can see we get 1 failed. And if we come up here, it'll show us where it failed. So basically it's expected to get 12 if we look at the test. So right here, it's passing in 5 and 7, which it expects to be 12, and it received -2 because we subtracted. So that's going to show us a failed test. All right, so let's fix that, put it back to plus, and then run npm test, and now it passes. All right, so very simple. In the next challenge, we're going to basically build a little calculator function. Still very simple, but a little more complicated than this. Okay, so we have something that is a little bit more difficult, but you should all still be able to do this. It's very, very basic. So write a function called calculator that takes in 2 numbers and an operator and returns the result of that calculation. So it'll take in 2 numbers, num1 and num2, as well as an operator as a string, and it will return the result of that calculation. So for example, we can pass in 1, 2, and then the plus symbol as a string, and it should return 3. 10, 5 with minus should return 5. 2, 2 with multiplication should be 4. 10, 5 with division should be 2. Okay, and then the function must throw or log an error if it's an invalid operator. So if it's not one of these 4, then it should say invalid operator. You can either console log or throw an error, however you want to do it. And I put 2 solutions for this. So let's jump into calculator.js. And we're going to pass in, if you want to pause the video here, you can, but I'm going to pass in num1, num2, and operator. And then let's create a variable, I'll call it result, and actually we're not going to set that to anything. And then I'm going to use a switch here. I think that's the best way to do something like this, where there's a lot of different conditions. So we're going to evaluate operator, and let's say in the case that operator is a plus sign, then we're going to set that result to whatever num1 is plus whatever num2 is, and then we want to break. So that's the first case. So then the second case is going to be if it's a subtraction, then we want to set result to num1 minus num2 and break. And I'll just go ahead and copy this. And whoops, I just copied nothing. Okay, so then I'm just going to change this one to multiplication, and that should be num1 multiplied by num2. And then let's change this one to division, and then we want to divide num1 by num2. All right, now if it's not one of these 4, then we want to throw an error. So in that case, that's going to be the default. So for default, let's say throw new error, and we'll pass in, let's say, invalid operator. Okay, and then outside of the switch, we just want to return the result. So let's look at the run file. So it's passing in 1, 2, and a plus symbol. So if we run this code, we get 3. So that our manual test works. So now let's rename calculator test -test to calculator.test. And then we'll run npm test. And now we have 3 passing tests. All right, and no fails, so we know that that works. Now, if you don't want to use a switch, of course, you could use if else. So what I'll do is just comment this out, and we'll say function calculator. We'll pass in num1, num2, and operator. And let's do the same thing. We'll define a result. And if you got something different, if you did it a different way, that's absolutely fine. So let's say if operator, if that is equal to the plus sign, then we'll set the result equal to num1 plus num2. Okay, else if, let's say, else if the operator is equal to minus, then the result is going to be num1, result should equal num1 minus num2. Else if the operator is equal to the asterisk or the multiply, then result num1 times num2. And finally, else if the operator is equal to divide, then result equals num1 divided by num2. Okay, and then we want to make sure that it's one of those operators, so what we'll do is just have an else, meaning if it's something else, then we'll throw new error, and we'll say invalid operator. And then finally, we want to return the result outside of the if. Okay, now if I run the test, that passes as well. All right, so that gets the first three really simple ones out of the way. Now we're going to move to challenges that most of them are going to have to do with iteration and loops. So in the next one, we'll do the count occurrences. Okay, so now we're going to get into more into loops for the next bunch of challenges. And this one's called count occurrences, and it says write a function called count occurrences that takes in a string and a character and returns the number of occurrences of that character in the string. So if we look at the example here, we're passing in hello as the string and then L, lowercase l, as the character, and that should return 2 because there's 2 L's. In this one, we're passing in Z, there's no Z in hello, so we get 0. Now, as far as constraints, lowercase and uppercase characters are considered different characters. So if this were an uppercase L, it would be 0. And you can change the function if you want and make it case insensitive. So as far as hints, these are just little hints that I thought up. I mean, they might help you, they might not. Basic things here, like you can loop through a string, just like you can loop through an array. You can use the ++ operator to increment a variable. You could take another approach and use the split method to split the string into an array of substrings based on the given character. And I'm going to show you two solutions, one using a for loop and one using split. All right, so if you want to pause the video and try this out yourself, go ahead and do that. Remember, it should look like this, and you should be able to pass the test with npm test. So let's jump into count occurrences, and like it says, it needs to take in a string and it needs to take in a character. So let's first create a variable for the count, and of course we're going to set that to 0, and then we're going to loop through the string. So you can loop through a string just like you can an array. So let's say for, and we'll say let I equals 0. So we'll start I at 0. We'll say as long as I is less than the length of the string, so str.length, and we want to increment by 1 through each iteration. And then I want to check the current character. So we can do that. Let's do a console log here of the string and then the index, which will be I, right? Because it's going to keep going until the length of the string. And this is what the run file is good for, is testing stuff like this. So if I go to the run, you can see it's going to call count occurrences with hello world. Notice it does have an uppercase L, so this shouldn't count that ultimately. But right now, if I run this, we should see each letter, each character spelt out. So hello world, right? Because it's going through iteration 1. It's going to give us H because that's the index of 0. Index of 1 is E, index of 2 is L, and so on. And the only reason we have undefined is because we're also console logging the result, right? Which doesn't exist because we didn't return anything from here. All right, so knowing that, let's do an if statement here, and we'll say if the string with the current index, if that is equal to the character, then we want to increment the count, right? So we'll say count plus plus. And then all we have to do is return that count. So let's go outside of the loop here and return the count. So now if I were to run this file, I get 3. Wait a minute. Oh yeah, hello world. I was thinking it was just hello. So it has 3 L's, right? If I were to pass in the uppercase L and run, we get 1. All right, so now let's do the test. So I'm going to rename this to .test. And then we're going to come down to the terminal and run npm test. And it passes, okay? We have no fails. All right, so that's one way of doing it. That's kind of the lower level way of doing it. But now I'm going to show you another way. So I'm going to comment this out. And for this, I'm going to make it an arrow function just to switch things up. So it's still going to be called count occurrences. It's going to take in a string and a character. Then we'll have our arrow function. And what I'm going to do here is use the split method. And what that does is it will split a string into an array. And it will split it at a certain character, at a certain point. So let's do a console log. And I'm sorry if some of you guys just want me to type out the solution and that's it. That's not really how I want to do this. I want you to understand what's going on. So I'm going to be doing little console logs here and there, so just to make sense of it. So what I want to log is the string and then .split. Now this takes in wherever we want to split for the array. So if I just do an empty string, that should split every single letter into an element in the array. So let's save that. And let's go to the run file so we can run it. And now you'll see I have an array where every letter is in here, including the space. So what we can do is instead of splitting with an empty string, we can split on the character that's passed in. So if I do that and we run, so right now what's being passed in is lowercase l. So if I run that, now it gives us this as an array. So HE, that's at the 0 index, an empty string is at the 1, and then this is the 2 index, or the 3rd item, and this is the 3 index, or the 4th item. So the L's, the lowercase L's, are no longer here. We split on those. So what we can do is, let's console log the length of this, the length, and then if I run my code again, we get 4. Because if we look at that array, it has 4 elements, right? 1, 2, 3, 4. So if I take away 1 from that, that should actually give me the number of occurrences. So if I do that, so we're passing in lowercase l, and you'll see we get 3, and there's 3 L's. If I pass in O, and we run this, I get 2, because there's 2 O's. So that's another way of doing it. Now, we want to return this. We don't want. I was just logging it to show you, but let's return, take away this parentheses as well. We want to return that. In fact, we could make this shorter. We could do an implicit return, get rid of the return keyword, get rid of the curly braces, since it's an arrow function, and we should be able to just do that. So that shortens it up quite a bit. Now let's try and test it out. So we'll run npm test, and it passes. Okay, so I mean, these are 2 very different ways of doing it, but they're both correct, and there's many other ways, and you might have even come up with another way. All right, so let's move on to the next challenge. Okay, so the next challenge is called find max number, and here we're going to write a function that takes in an array of numbers and returns the largest number in that array. So if we look at the function signature, it takes in an array of numbers. Whenever you see a data type and then the brackets, that just means it's an array of that data type. And then it should return just a regular number. So for example, if we pass in an array of 1 through 10, it should return 10. Actually, all of these 10 is the max. And then for hints, there's a very, very easy way to do this using a specific built-in method in JavaScript. I'll show you that way, but try not to do it that way. I mean, I wouldn't say it's cheating, but you can do it in a more low-level way. So let's go ahead and try it out. So you can pause the video if you want. Let's go ahead and jump into findMaxNumber.js. And like I said, it's going to take in an array. Now I'm going to show you kind of the cheap way of doing it first, and that is by returning on the math object, there's a max method. And we can actually pass in numbers here and get the max. So all we really have to do is spread across, we can use the spread operator, the array. And that should do it. So if I go to the run file here, you can see 16 is the max, right? So that's what it should return. If I run it, you can see we get 16. So very simple. We can test it out. Let's rename, and we'll say .test, and go to our terminal and run npm test, and that passes. Now I'm going to show you another way just using a for loop. So let's comment that out, and let's say function find max number, pass in an array. Okay, so I'm going to create a variable. I'm going to designate a variable for the max number, and I'm going to initially set it to the first item in the array. So array and then the index of 0. So basically we're going to set that as the max, the first one, and then we're going to loop through, and if something is larger than that, then that will take the place of max, right? It'll replace whatever's in max. So let's say 4. Now, in this case, we actually want to start at the second element because we already set the max to the first element. So we're going to say let I, instead of 0, we're going to say let I equals 1. That'll start at the second item. And then as long as I is less than the array dot length, and we want to increment I by 1, and then we can do a conditional here, right? So let's do a conditional, and let's say if the array index, so whatever that value is, if that value is greater than max, which starts out as the first item in the array, if it's greater, then it's going to replace whatever is in max, right? So we'll say set that to array and whatever index that is. And that's it. Then we just need to return under the for loop, we're going to return whatever that max is. Okay, so now if we run our test, that passes as well. So both of these work, right? But this is a more, I guess, clever low-level solution than just using the math max method. Okay, so this challenge is called title case, and it says write a function called title case that takes in a string and returns the string with the first letter of each word capitalized. So if we look at this example here, you have I'm a little teapot where only the first letter has the uppercase. But what this should return if we pass it in is this, where every first letter is uppercase. Same with this. Every first letter, same with this. These are all caps, but it should still return just the first letter. So as far as constraints, you may assume that each word consists of only letters and spaces. Don't really have any hints other than you can use 2 uppercase on a string, but it'll make the entire string uppercase, not just the first word. But you can use that in your solution. All right, so let's go ahead and jump in to title case JS, and we're going to pass in str as our string, and like I said, if I wanted to return str dot to uppercase and then use the run file, which passes in the quick brown fox all lowercase, you see that gives me, it's just all uppercase now. We don't want that. So what we can do here is, first of all, let's split the string into an array of words. So we use split in the was it the last? I think it was the last challenge or the one before that. We use split, which will take a string and turn it into an array. So let's say words, and then we're going to take string, and I'm going to make it all lowercase at this point. So we can do that with 2 lowercase, just like we can do 2 uppercase. and then I want to split it into an array, and I want each word in each array position or each array element. So I'm going to put a space here because remember there's a space between each word. So if I return words now and I go to my run file, now you can see each word is in an array element. Okay, so let's do a for loop here. So we're going to say for and then let I equals 0, and as long as I is less than the words dot length, and we want to increment by 1, and then we're going to set words in the current index equal to, so basically we're resetting it. This is the actual word. It's going to loop through and give us each word, but each one we want to set it to words I, so the current word, but I only want to make the first letter uppercase. So we know the first letter is in the 0 index of that word. So then we can take 2 uppercase to that. Okay, now this will be just the first word, so I want to add on to it the rest of the words. So we'll say words index, and then I want to basically just slice off or cut off the first letter. So we can use slice, and we want to slice the first one off. Okay, so what we're doing is we're resetting this, the current word in the iteration, to the first letter, uppercase, and then adding on the rest of the letters to the word. Okay, so if we now do, let's just return here words and see what that gives us if we run the file. So now it's still an array, but notice that now the first word is uppercase. So how do we get it from an array back to a string? Well, we use the join method. So what we can do is just say return words dot join, and we're going to join at each word, so we want to join at the space. Okay, or another way of putting it is when we put this back into a string, each element is going to have a space in between it. So now let's save that. Let's go ahead and run this file, and there we go, the quick brown fox. So that works. So if we go to our terminal and we run our test, we should get all passes. So we get 5 passed. Wait a minute, it didn't even run our test because we need to rename this. So that should be .test. Okay, and then let's run this again. And we should have 6 passed, hopefully. Yep, so that passed. And you can see in our test, it passed in Hello World, which should be this, JavaScript programming, OpenAI chatbot. So all of those passed. So in the next video, we're going to do a very popular challenge that you get in a lot of job interviews, and that's to reverse a string. Okay, so through this course, we're going to have certain challenges that are more popular than others when it comes to interview questions. And this one here, reversing a string, is something that's really common in really entry-level positions because it's pretty simple. You're not going to get this question for any senior position. But it is something that's good to know. This, FizzBuzz, there's a few, and I'll mention them throughout the course. And then later on, when we get to like bubble sorts and binary trees, those are really common in higher level positions. All right, and we're going to do a bunch of different reverse strings. When we get to data structures, I'll show you how we can use a stack to reverse a string, how we can use a linked list. This is just a very basic reversal of a string. So it's as easy as it sounds. We just pass in a string, and then it returns it backwards, right? So if we pass in hello, we should get this back. If we pass in world, we should get this back. If we pass in an empty string, we should get just an empty string back. And the input string should only contain lowercase letters and spaces. So hints, you can do this without using any built-in methods and just a for loop. So I am going to show you that way. And I'm also going to show you how we can use methods like split, reverse, and join to solve the problem. All right, so let's jump into reverse string JS, and I'll show you I guess the easier way first using predefined methods. So let's pass in a string, and then I'm going to return from here. On that string, we're just going to use method chaining here. The first one is going to be split, and basically we know what that does. We can split a string into an array. So if I just pass in an empty string, not with a space, because that will put each word into an array item. We want each character. In fact, I can go ahead and just return that and see what that gives us. So if we go to the run file and we run our code, you should see, wait a minute, string split is not a function. Oh, I put split. Okay, so let's run that. All right, so now each character, including the space, is in the array. Now, there isn't a method to reverse a string in JavaScript. Like, you can't say string.reverse, but you can reverse an array, and that's the reason we do this, so that we can add on to this reverse, like that, right? So if I save that and we run the file, now we have an array with, it's just reversed, right? We have H at the end item, we have D at the beginning. So now the last thing to do is to turn that back into a string. And in the last video, I showed you we can do that with join. So if we do that, and then we run the code, we get, that's hello world backwards. So we can run our test now. So npm test. And I keep running the test before renaming the file. Got to do that. I couldn't think of a better way to do it, because if I didn't do it this way, then it would run all your tests all the time and you'd have a bunch of failed tests because you haven't done these yet. So I thought that this was the best way. So npm test, now we should have 7. Oh, it failed. Let's see what's going on here. So it expected that. Wait a minute. I didn't pass anything in join. So we want to join just an empty string, because if we don't do that, then we're going to have these commas. All right, so let's do that. So that's my first failed test. Let's try it again. And there we go. So that one passes. And you could even shorten this. Like, we could do const. We could make it an arrow function. And we could have an implicit return, so we don't even need the return keyword, and then just get rid of that last curly brace. That should work as well. Okay. Now the next solution I'm going to show you is a little more tricky. So I'm going to use a for loop, but I'm going to loop through it backwards and basically add the letters to a string in the reverse order. So let's say function reverse string and pass in str, and we're going to initialize, let's say reversed, and set that to just an empty string to begin with. And then we want to loop through the string backwards. So what we can do is set I with let to the string dot length, but we want to subtract 1. So that'll start at the end, and we want to say as long as I is greater than or equal to 0, then we want to actually decrement, so I minus minus. That'll go through backwards. In fact, we can do a console log here of, let's say, string I, and let's run that to see what it gives us. So you can see that it's going backwards, right? It starts at D. Now all we have to do is add that string I to reversed. So let's say reversed equals string I. Okay, because we're just going through and we're adding each character to that variable that starts off as an empty string. And then we're going to return reversed. So let's try that out. We can run it first. Wait a minute. Why is it just giving me an H? So, so what I did here is I just replaced, it's going through the loop and it's replacing each character with whatever this is. We need to append, not replace. So plus equal will append this to whatever is here instead of replacing it. So now if I run the run code, now I get the backwards string. So now that should pass the test. So let's go to npm test, and that works. Okay, so if you are asked to reverse a string, I would say do it this way. I think that this shows you have more skill than just throwing together some predefined methods. But that's just my opinion. So that's it. Let's move on to the next one, which is palindromes. All right, guys, so we're going to ramp up the difficulty just a little bit, and we're going to do a palindrome challenge. Now, if you don't know what a palindrome is, it's a word, a phrase, number, or any sequence of characters that reads the same backwards or forwards. An example is madam. It's M-A-D-A-M, whether you're reading it forwards or backwards. Another example would be race car. Basically what we want to do is create a function called isPalindrome that takes in a string and will return true if it is a palindrome and false if it's not. And an empty string would be a palindrome because it's the same forwards or backwards. As far as constraints, the function should ignore special characters, spaces, anything non-alphanumeric. So we want to strip anything that's not a letter or a number out of the string that's passed in. And you can solve this in a way that's similar to the reverse string challenge with some added steps, because you want to compare the regular string to the reverse string. Remember, you want to remove any non-alphanumeric characters, and you can do that with regular expressions and the replace method. This is actually the expression. I kind of cheated a little bit and gave you that. Basically, it says anything that is not A to Z, a letter, or a number. All right, now I'm going to show you two ways to do it. One with the regular expression, which is pretty simple. It's only, I think, 2 or 3 lines of code. And then another way without regular expressions, which is much longer. We're actually going to use some helper functions. All right, so we have 2 solutions. So let's jump into it, palindrome.js. And like I said, we'll start with the regular expression version. This is going to take in a string, and we're going to create a variable called formatted str, and this is basically the string with any non-alphanumeric stuff taken out. We also want to make it all lowercase so we can match it. So let's say string.to lowercase, and then we're going to use replace, which will take in 2 things. One is going to be a regular expression to match, and regular expressions are often wrapped in these forward slashes, and we're going to put a set of brackets with a caret. The caret is basically saying anything that's not what I'm going to put after this, which is going to be A to Z and 0 to 9. And we want to check the entire thing, not just one instance. So we're going to put G for global. All right. And then the second thing is what we want to replace anything that's not alphanumeric character with, and that's going to be nothing, just an empty string. So we're essentially deleting anything that is not a number or letter. And we can actually check this out if we return the formatted string and we go to the run file. You can see I have it running it twice here. One is race car, which is a palindrome, and race cars, which is not. So if I run the code here, you can see, actually I wanted to put some spaces and characters in here so you can see that those will actually be stripped out. So if I go ahead and run this again, doesn't have the special characters, doesn't have the spaces. So we can see that that's being formatted. All right, so now the next thing to do is reverse the string, right? So actually I'll leave that there, and let's create reversed str, and for that we'll go ahead and use the split reverse join solution, and we want to do that on the formatted string. So split, we'll split it into an array, okay, basically an array of letters, and then we want to reverse that array, and then we want to join it back into a string. So we just want to pass in an empty string in here. Okay, so now all we have to do is return the formatted string is it equal to the reverse string? Okay, so if it is, then it's a palindrome and it will return true. If it's not, it will return false. So let's try and run this. So we get true, false, because this one is, this one isn't. Now for the jest tests, let's go ahead and rename this to palindrome.test. And then we'll go to our terminal and run npm test. And we have all passing tests. Okay. Now I'm going to show you another way to do this without regular expressions, which is a bit more difficult. There's quite a bit more code we're going to write. So let's comment that out and let's create another function called isPalindrome that takes in string. And I'm going to have some helpers that go with this. It's just cleaner instead of just, putting it all in here. So we need to remove, special characters and spaces without being able to do this. So let's create a function called remove. We'll call it remove alphanumeric. Okay, and then that's going to take in a string. And then we need a way to check if a character is alphanumeric. So let's create another function called isAlphanumeric. Not number, numeric. And that's going to take in just a character, not a string. Okay, and then of course we need to reverse the string to check it. So we'll have a function called reverse string as well. That'll take in a string. Okay, so we have our helper functions. Let's start off with the isAlphanumeric. And the way we're going to do this is check the Unicode character for whatever is passed in here. And I have from this website, vertex42.com, and this is all over the place. You can find charts like this, but there's a number for each character. So we're going to be dealing with lowercase letters because we're going to make them lowercase with two lowercase. And we can basically check to see if the Unicode character is from 97, which is the lowercase a, to 122, which is the lowercase z. And then we can also check to see if it's includes a 0 to 9 number, which is going to be, 48 to 57. Now, the way we can get those numbers is with a method called charCodeAt. So let's go into this function right here, isAlphanumeric, and let's create a variable called code. And we're going to set it to the character that's passed in, and then we're going to use the charCodeAt method. And that takes in an index, which is going to be 0 because it's a single character. And then what we can do is just return. I'm going to put this in parentheses. So we're going to return if the code is greater than or equal to 48, because again, if I show you this chart, 48 is 0. Okay, we want to say if it's 48 and it's greater than or equal to 57, which is 9. So let's say and code is greater than or equal to, what was it, 57? Yeah, so we want to see if it's, less than. We want to make sure it's in this range. So greater than or equal to 48 or less than or equal to 57. So that takes care of the numbers. We want to say or, and I'm just going to put a comment here that this is, let's say, numbers 0 to 9. So if the character is a 0 to 9. And then or, open up another set of parentheses, and now we want to check for lowercase letters. So we want to say if it's greater than or equal to 97, which is lowercase a, and code is less than or equal to 122, which is the lowercase z. So here we'll say these are lowercase a to z, and that will return true or false. So let's go into isPalindrome now, and let's return, and we'll just say isAlphanumeric, and I'll just pass something in here. Let's put the letter A. So now we can save that and go to the run file and run the code, and we get true. And it's going to run twice just because we're calling it here twice, and we're not doing anything with what's being passed in. We're just checking to see if A is alphanumeric, and it is. So let's put a 1 in here, and then we'll run this again, and again we get true. Now if I put, let's say, the @ symbol in here, and I run that, then we get false. So we can see that that's working. So that's all set. Now let's go to the remove alphanumeric, because we want to remove them from the string. So we'll start with just saying formatted string, and we'll set that to an empty string. And then basically we want to loop through this string right here. So let's do a for loop. And in the for loop, let's set I to 0, and then we're going to say as long as I is less than the string dot length, and we want to increment by 1. And then inside the loop, let's create a variable called char, and we're going to set that to string and then whatever the index is. So basically we're just getting the character, we're looping through and getting each character, and then we want to check to see if that character is alphanumeric. So we'll say if is alphanumeric, and then pass in here the character. Okay, so if that's true, then we're going to take formatted string and we're going to append to it. So plus equals that character. Okay, and then we'll go outside of the for loop and we're going to return the formatted string. All right, so now let's go into the is palindrome, and we're going to say const formatted string, and we're going to set that to remove remove alphanumeric. Oh, I'm sorry, this should be remove non-alphanumeric. Okay, because we're removing anything that's not. So let's say remove non-alphanumeric. Okay, and then what we'll pass in here is the string, but we're going to make it lowercase, because remember we're checking for all lowercase. So this will be 2 lowercase. All right, so that should give us the formatted string. In fact, we can test that out now, just like we did with the other solution. So let's see, we'll go ahead and run this. Actually, let's put some symbols in here and some spaces, and that should not show up. Okay, so did the same thing that in this solution this line did. Okay, now there's a lot more to this, but we didn't use regular expressions. So now we just need the reverse string. So let's say const reversed. Actually, wait a minute. No, the function is called reverse string. So we'll call this reversed str and set that to reversed string, and then pass in the, actually we want to pass in the formatted string. Okay, now we don't have that function yet, so let's come down here. We can do this any way we want. So since we use split reverse join in the first solution, let's do the reverse for loop here, just like we did in the last video. So let's say let reverse or reversed and set that to an empty string, and then we want to loop through the string that's passed in backwards. So in our for loop, let's say let I equals the string dot length -1, and then we can say as long as I is greater than or equal to 0, and we want to decrease, we want to decrement, so I minus minus. And then what we can do is take that reversed variable, which is an empty string to start with, and we're going to append, so plus equal, the character for each, going backwards, each character. So string and then I for the index. All right, and then we want to go outside of the for loop and just return reversed. So now what we can do up here is just the same thing we did here, just return if the formatted string is equal to the reverse string. So let's try that out, and I'm going to leave these characters in here because these should get stripped out and this should be true. So I'm going to run and we get true and then false. Okay, so the first one's true, second one's false. And as far as stripping out the characters, I mean, you could not do that, but I wanted to make it a little more challenging. So let's run a test. So I'm going to go to palindrome.test. I already have it renamed. And then let's go to our terminal and npm test. And that passes as well. Okay, so both of our solutions here are passing. Obviously, this solution is a lot longer than this one because here we use regular expressions, but it's good to know how to do it both ways. Okay, so this challenge is pretty simple. I think that most of you guys should be able to do it on your own. It's called count vowels. Basically, you want to take in a string and return the number of vowels in that string. So some examples: the word hello has 2 vowels, Y0, Mississippi has 4. So as far as constraints, it shouldn't matter if the input string is uppercase or lowercase. So you probably want to just make everything uppercase or lowercase that's passed in and then check for the vowels. All right, so you can go ahead and pause the video and try it, and let's get into it. So count vowels JS, I'm going to open that up, and obviously that's going to take in a string, and then we're going to format the string as lowercase. So let's say format str, and we'll set that to whatever the string is, dot to lowercase. And then I'm going to initialize a variable for the count. So obviously, oops, what am I doing? Count, and we're going to set that to 0. And then we're going to loop through the string. So let's say for, and we'll say let I equals 0. And then as long as I is less than the formatted string, I call that formatted string. Yeah, let's do that, formatted. Okay, so if that is less than the formatted string dot length, and then we just want to increment that I variable. All right, now let's get the character. So we'll say char, and we can set that to the formatted string and then the current index. That'll give us the value, which will be the character. And then we want to check to see if that character is a vowel. So let's do an if statement here, and we're going to say if char is equal to lowercase a, or, and then we'll just copy that down a few times. So if it's A, or if it's E, I, O, or U, and if that's true, then we just want to increment the count. So count plus plus, all right? And then after the for loop, we can just simply return the count. So pretty simple. So let's run the test. I'm going to rename this to .test, and you can see it's going to pass in some strings here. So let's run npm test, and I believe we should have 9 passed tests. And there we go. All right, so very, very simple. Hopefully you guys got it. And I'm not going to say that for most challenges, but this one is pretty easy. So let's move on to the next one, which is called remove duplicates. Okay guys, so we're going to start to work with arrays a little more, and in this challenge we're going to create a function called remove duplicates that takes in an array and returns a new array with any duplicates removed. So for example, if we pass in an array of just 1 through 10 with no duplicates, we'll get 1 through 10 back. If we passed in this with all ones, we'd have just an array with a single one because the rest of these are all duplicates. And it can be for any, as the constraint says, any data type. So here we have what true is repeated, hello, and then 2 and 3. So those should be stripped out, and we just have an array with no duplicates. All right, as far as hints, you can do this with a traditional for loop, but if you're familiar with the set object or the set data structure in JavaScript, you can use that as well because sets have to be unique. Now I'm going to get into maps and sets later on, as you can see right here, along with hash tables. So if you don't know about sets, that's absolutely fine. We're going to learn about them later. All right, so let's jump into remove duplicates.js, which is going to take in an array. And what I'm going to do here is just create an array called unique array and set that to an empty array. And basically, this is going to store the unique values. Okay, now I'm going to loop through an array, and usually I'd use for each. I'd use a high order array method, but I'm trying to stick to just for and while loops, really, just for the first two, the basic challenges. In section 3, we get into high order array methods, but I'm going to stick to just really low level loops here. So we're going to do a for just to go through this array, and we can say let I equal 0, and as long as I is less than the array dot length, and then increment. And then in the loop here, we're going to check. Now, there's a couple ways we could do this. We could use another for loop inside of it, but what I'm going to do is use the includes method on the array, which will return true if what you pass in is included and false if it's not. Now, I want to check if it's not included, so I'm going to say if not, and then unique array dot includes, and then pass into that whatever the current value is in that current iteration. And if it's not unique, then I'm going to push it on to the unique array. So we can do push, and let's pass in here array I, and then we can simply return the unique array. So pretty simple. Now, if we go to our run file, you can see that we're passing in an array. It has some duplicates. You have 5, hello, true. So let's try and run it here. And you can see what we get back is an array with no duplicates. So this should pass the test. So let's rename this here to .test. And then in our terminal, whoops, I didn't mean to do that. So in our terminal, we're going to run a tests, and we should get, I believe, 10 passed tests. All right, now the second way to do it, or a second way to do it, is by using a set. So a set is a data structure. It's a built-in data structure with JavaScript, and it can't contain duplicates. So let's create our function, remove duplicates, passes in an array, and what I'm going to do here is just return a new set, and you can pass in an array and basically turn that into a set. So let's just do that for now and then run this file and see what we get. So we get a set, as you can see here, with 10 items, and there's no duplicates. Just by default, I didn't have to remove them. They're just removed automatically because a set can't have duplicates. So all we have to do now is return that as an array. So I can just wrap this in the array constructor and then the from method. So that will just turn an array-like structure into an actual array. So now if I save that, we should pass our test. In fact, let me just, let's run this first just to show you. I'll also console.log the array. And then we'll run this file, and you can see the array does contain the duplicates, but the set does not, or the array with the set does not. So that should pass. So let's go to our terminal and npm test, and we should still have 10 passed tests. All right. Now you could, if you didn't want to use any methods at all, you could use another for loop in here instead of using includes. But it's up to you. It's all preference. Okay, so that's it for basic challenges 1. Now we're going to move on to basic challenges 2, which is going to be a lot of the same type of challenges using loops and so on, but a little more challenging. All right, guys, so when it comes to job interviews, this is another really common interview question or challenge for entry-level positions, and it's FizzBuzz. And there's a lot of different iterations of it, but essentially what you have to do is loop from 1 to something, and a lot of cases it's 100, and print out each number. However, if the number is divisible by 3, you print out the word fizz instead of the number. If the number is divisible by 5, you print out the word buzz. And if the number is divisible by both 3 and 5, then you print out FizzBuzz. Okay, now in this challenge, we're going to write a function called fizzbuzzArray that takes in a number and returns an array. And that array should contain all the numbers from 1 to whatever number is passed in. Okay. However, if the number is divisible by 3, fizz, 5, buzz, and 3 and 5, then fizzbuzz. So if we look at some examples here, so if we pass in 5, it should loop from 1 to 5 and then output the array with the numbers 1, 2, since 3 is obviously divisible by 3, then fizz, 4, and then 5 would be buzz. Here we pass in 15, so it should be an array from 1 to 15. So I changed it up a little bit by making it an array and also setting a limit on where it goes to rather than just looping from 1 to 100. All right, so the number passed in will always be greater than 0. The number passed in will always be an integer. And then hints, so instead of console logging each number, you will need to push each number onto an array, because a lot of times, you know, the very simple base version of this, you'll console log the numbers rather than putting them into an array. All right, so let's open up fizzbuzzArray.js, and if you're going to try it out, you can pause the video. Okay, so this is going to take in a number, and it's going to go up to that number. And since we're dealing with an array, let's go ahead and initialize an empty array. Then we're going to have our loop, and we want to loop from 1 to whatever the number is, so we're going to say let I equals 1 instead of 0. Okay, then we want to say as long as the current number is less than or equal to whatever the number passed in, and then we want to increment I. Now, we want to check here, we could use the modulus operator to find the remainder. So basically what I'm going to do here is say if I, and then use the modulus, which is the %, 3, if that is equal to 0, then we know it's divisible by 3. Now, I'm going to check for fizzbuzz first, which is if it's divisible by 3 and 5. So let's say and I modulus 5 is equal to 0. Then we want to take our array and we want to push onto it, and we're going to push on the string of fizzbuzz. Okay, and then we'll have an else if, and now we're going to check to see if it's just divisible by 3. So we'll say I and then modulus 3 equals 0. Then we want to push on the word fizz. Okay, and then we'll do an else if, and if I modulus 5 equals 0, then we want to push on to the array the string of buzz, and then we can have else, and we just want to take our array and push onto it whatever I is, whatever the number is, and then we can return the array. So let's say return array, save that, and we can try the run file first. So you can see I passed in 15 here. Let's say run code, and we get an array with 1, 2, fizz, 4, buzz, oh, wait a minute, 2, 4, 5, 6 would be fizz, 7, 8, 9, fizz. So the first fizz buzz should be 15, and that's what we're going up to. If I change it to 30, then we should see 2 fizz buzz. So one here at 15, and then one at the end for 30. All right, so this should pass. So I'll go to my test here and rename that to .test. And then let's go to our terminal and run npm test, and it passes. Okay, now you can shorten this up a little bit, and instead of doing this with the and, you can actually just see if it's divisible by 15. So if we say I modulus 15, then we know it's also divisible by 3 and 5. So if I do that and then run the test, that still passes. Okay, so fizzbuzz is definitely something that you should be very familiar with. If you're trying to apply for an entry-level job, it's really likely that you'll get asked this question or some version of it. Okay, so we have another challenge that has to do with arrays. It's called array intersection, and it's going to be a function that takes in two arrays and returns an array containing the intersection of the two input arrays. So basically the common elements that appear in both arrays. So if we look at this example here, we're passing in two arrays, 1, 2, 3, 4, 5, and 1, 3, 5, 7, 9. So when we run this, it should return an array with 1, 3, 5 because 1, 3, 5 exist in both of these arrays. Okay, this one here, all ones, all twos, that's going to return just an empty array because there's no common elements. Here, the common elements are all of them, 1, 2, 3, 4, 5. They're just in a different order, so it should return that. So fairly simple, and this is similar to the duplicates one that we did in the last section. So constraints, the input arrays can contain any number of elements. The input arrays can contain any positive integer. So you could use a loop, a for loop, to iterate through the first array and check if each element is in the second array using the includes method. So similar to what we did in the duplicates challenge. And we also can use a set if we want, and use the has method. And again, if you don't know about sets, that's fine. We're going to get into them later on. So let's jump into the work file here. So array intersection.js, and it's going to get passed in two arrays. So I'll call this array 1 and this array 2. And then I'm going to create an empty array here called intersection array. And that's just going to be empty for the moment. Now we're going to loop through the first array. So in our for loop, let's initialize I at 0, and then let's say as long as I is less than array1 dot length, and then inside the loop we're going to have a conditional, and we're going to check to see if the current value, which we get with array1 I, is in array2. So we can say if array2 dot includes, and then we can wrap that. Okay, and we want to also make sure it's not already in the intersection array. So we're going to say and if not, intersection array dot includes, and then pass in array 1 and I. Okay, so if that's true, then we're going to push the value into the intersection array. So let's say intersection array dot push, and pass in here array, or array 1 I. Okay, and then we should just return the intersection array, and that should do it. So let's go to run, and here you can see we have 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. So 3, 4, and 5 are the common elements, so that's what we should get. So let's run this code. We get an array with 3, 4, 5. All right, so now we'll run our jest test. So let's rename this to .test, and in our terminal we're going to run npm test. And we have all passing tests. All right, so that one's pretty simple, and it's similar to what we did in the duplicates one. Now I'm going to show you another way to do it with a set. So let's comment this out, and let's say function array intersection, array 1, array 2, and I'm going to create a set, or yeah, we're going to create a set called set1. So new set, and then I'm going to pass in array 1. Now remember, a set is going to be always going to be unique values. Now I'm going to declare, just like we did above, the intersection array as just an empty array. Okay, and then I'm going to loop through. I'm actually going to use a for of loop this time. So I'm going to say let num of array 2. So that's just a different way to loop through an array. And I'm going to say if set1 dot has, because this has method will check to see if something is in that set. So I'm going to say if it has excuse me, num, then we're going to push it on to the intersection array. So we're going to push on the num. And then after the for loop here, we're going to return the intersection array. And now let's go ahead and run the test. And you can see that that passes. So just to reiterate, we create a set with array 1. We initialize an empty array. We loop through array 2 this time. And we see if set 1, which is array 1, has the num, or whatever iteration it is of array 2. So we're checking all of array 2 and seeing if it matches. If it does, then we're going to push it onto the intersection array, and then we're going to return that intersection array. Okay, so that's it. Let's move on to the next challenge. So in this challenge, we're going to create a function called display likes, and it's going to take in an array of names, and those names are going to represent people that liked the post. So if we pass in no names, so an empty array, it should say, just return a string that says no one likes this. If one person likes it, so if we have one name passed in, it'll say name likes this. If 2 people, it will say name 1 and name 2 like this. 3, it will say name 1, name 2, and name 3. And anything more than 3, then it's going to say name 1, name 2, and then X others, so however many other people liked it. So if we look at some examples here, this one would be no one likes this. This would be Peter likes this with 1 name, 2 names, 3 names, and then anything above 3. So here we have Alex, Jacob, Mark, and Max. So it would say Alex and Jacob, or Alex, Jacob, and 2 others like this. This one has 5, so it would say Alex, Jacob, and 3 others like this. All right, constraints, the input array will only contain strings, and that's pretty much it. I don't really have any hints. So if you want to try it out, go ahead and pause the video. I'm going to jump into display likes.js. And as I said, it's going to take in an array of names, which I'll call names. And then I'm going to get the length of the array. So let's set length to names.length. And then we're going to have a conditional here that checks the length. Let's say if the length is equal to 0, then we're going to return from this no one likes this. Okay, and it should be the exact case here, so all lowercase, because that's how the jest test is written. So next we'll check, let's say else if, and in this case we're going to say if the length is equal to 1, then we're going to return, and I'm going to use a template literal here, and we can take the names array and then get the first name with the 0 index. Okay, and then we'll say likes this. So whatever the name is, and then likes this. Else if, so else if the length, and you could use a switch for this as well. So if the length is equal to 2, then let's return another template literal, and I'm going to say names, so the array names 0, and names 1 like this. Okay, and then let's do another else if. So here we're going to say if the length is equal to 3, then we're going to take all 3 names. So I'm just going to copy this just to save myself a little typing. So it'll be name 0, comma, and then we'll do names 1, and then this one will be names 2. Now if it's more than 3, so we'll just put an else here, then we're going to return the first 2, right? So let's say names with a 0 index, and then comma, whoops, comma should be after that. So names 0, and then names with the 1 index, and we want to say and however many, whatever, X others like this. So we'll say and And the way that we can get the others is by taking the length of the array and then taking 2 away from that because we included the 2 here. If you wanted, you could say, if you could put 3 here, say, you know, whatever, Brad, John, and Jeff, and length minus 3 like this. But since we only have 2 here, then it's going to be length minus 2. And then we're going to say others like this. So if we look at the run file, we're passing in, what, 5 names? So it should say Alex, Jacob, and 3 others like this. So let's run it. And there we go, Alex, Jacob, and 3 others like this. Now let's run the jest test. I'm going to rename this to .test, and let's run npm test. And there we go, so it passed. All right, so let's move on to the next challenge. All right, guys, so now we're going to find the missing number. That's the challenge. So we're going to take in an array of unique numbers from 1 to n inclusive where one number is missing, and it should return that missing number. So for instance, if we pass in an array like this, 1, 2, 3, 4, 6, 7, 8, 9, 10, obviously 5 is missing. That's what we want this to return. And we don't have to put them in order. As you can see here, 9 is missing, and then here 7 is missing. So those should be returned. And if it's an empty array that's passed in, then it should return 1 because that's the missing number. Now, I don't want to give too much away in the hints, but it's going to help you out by adding all of these numbers together and getting that value, and then also adding 1 to n. N being the length of the array plus 1 because you're missing one number. I don't want to give too much away though, so that's a pretty big hint. And then this is a formula, I think this is called the Gauss formula, that you can use to add all of them together, n being, again, the length of the array plus 1. So let's jump into find missing number JS, and I'm going to pass in an array, and we want to return 1 if it's an empty array. So let's check that first. We'll say if the array dot length is equal to 0, then we're going to return 1. And I just did it shorthand without the parentheses. All right, now I'm going to create a variable called n. And like I said, n is going to be the length of the array plus 1 to make up for the one that we're missing. Get rid of that L. Okay, now we're going to have a variable called expected sum, and that's where I want to use that formula, this right here. So I'm going to grab that and put that there. Now, just to kind of show you how this works, I'm going to open up, where's my calculator? I'm going to open up a calculator, and I'm going to show you that, let's say I want to do 1 to 10. So to add those, we could do 1 plus 2 plus 3 plus 4, 5, 6, 7, 8, 9, and 10, which gives me 55. Now I can get that same result using this formula. Let's say, again, n is going to be 10. So 10 multiplied by 10 plus 1, which is 11, and then divided by 2, which also gives me 55. Okay, so there's many ways you can do it. We could use a for loop and get that sum, or we could use something like reduce, but we're going to get into high order array methods in the next section. So that should give us our expected sum. Now to get the actual sum, that's going to be the numbers in the array. Like, let's open the run file. So all of these added together, which is going to be a different value than the actual sum because we're missing a number there. So to get the actual sum, there's a few ways we could do this as well. I think we're going to stick with a for loop though. I'll show you how to do it with reduce as well, but let's do a for loop first. So we'll say I, or let I equals 0, and then we're going to say as long as I is less than the length of the array. And inside the loop, we can just simply take actual sum, which I didn't define. I'm going to do that here. So let actual sum, and we'll just set that to 0, and then we're going to add or append onto that whatever that array value is. Okay, so it's going to go through, it's going to loop through whatever is passed in, this for instance, and just add them all together, give us the actual sum. And then all we have to do is return the difference of those. So the difference of expected sum and actual sum, and that should give us the missing number. So let's save that and let's go to the run file, and we get 9. And as you can see, it's missing 9. So if I, let's say, take away 7 and put 9 in there and then run, now we get 7. So it looks like it's working. We can run our test. Let's rename that to .test and then npm test. And you can see that passes. All right, so that's one way to do it. If you wanted to use reduce instead of a for loop, we could do that. Let's comment this out, because I like to show you guys, different ways to do this. So we could do const actual sum and set that to the array and then call the reduce method. And I'm going to talk more about these methods in the next section. I know a lot of you guys know these, but I'm sure some people aren't that familiar with them. But this takes in a function, right? So the function is going to take in sum as the accumulator, basically the number that we want to keep adding, and then the number for that iteration, because this basically loops through the array. And it has a second parameter of what you want this accumulator to start with, and of course we want that to start at 0, and we want to go through and add each number, and it'll accumulate to the sum. So for the function body, we simply just want to take the sum and add to whatever the number is in that iteration. Hopefully that makes sense. So let's save that. Let's go ahead and run the test, and that works as well. So in the last challenge, we found the missing number. In this one, we're going to find the missing letter. So the way that it works is very similar, but the approach and the solution is pretty different. So for instance, if we pass in an array of A, B, C, D, F, it's going to return E. If we pass in O, Q, R, S, we'll return P. T, U, V, W, X, Z will return Y. And the input array will only contain letters in one case. And if there's no letters in the array, we'll return an empty string. As far as hints, I'm going to give you two different solutions. One solution has to do with using the alphabet, putting the alphabet in a string, and using the index of method to get the index of a letter in that string. Another approach would be to use the char code at method to get the Unicode value of a letter. And we used this back in one of the other challenges. Which one was it? I think it was the palindrome. Yeah, I believe it was the palindrome challenge. So let's go ahead and jump into find missing letter. If you're going to do this on your own, you can go ahead and pause it. So I'm going to pass in the array of letters. And what I'm going to do here is create a variable called alphabet. And instead of typing it all out, I'm just going to grab the string, and it's going to be lowercase and uppercase, because again, this can be an array of either lowercase or uppercase letters. Now here we're going to define the start index, and that's going to be, let's say, alphabet, and then we're going to use index of, and then we want the first item in that array, so that's going to be array and then the 0 index. And then I'm going to loop through the array. Let's say as long as, what am I doing? I is less than array length, I++. So before I do anything, I'm just going to console log here alphabet, and even though that's a string, I can still pass in an index, and what I want to pass in is that start index. Now if I open the run file and I run, that start index is always A, right? Because we set it here, so that's always going to be A. However, if I add to that the I variable through each iteration, it's going to change. It's going to basically go down the line. So if I save that and I run this, now we get A, B, C, D, E. Okay, so it's just going down the line for as many times as what's in the array. So now I just want to compare and see if the current letter in the array is not the same as the current letter in the alphabet string. If it's not, then that's what we want to return. So let's get rid of the console log and replace it with an if statement, and we'll say if the array at the current index is not equal to that alphabet with the start index plus I, then we're going to return that alphabet with the start index plus I. And then underneath the for loop, so if it basically goes through and there's no letters missing, then we just want to return an empty string. So now if I were to run this, you can see we get D. So A, B, C, F, G. If I replace F with D, and then I run this, we should get E. A, B, C, D. Wait a minute. I mean, that's still right, but I wanted this to be F. Okay, so that gives us E still. All right, so that should work for our test as well, so let's try that. All right, so it passes the test. So that's one way of doing it. Now I'm going to show you another way that involves that char code at and getting the Unicode value. So let's say function find missing letter. It's going to take in an array. And I'm going to create a variable called start. And let's set that to the array at the 0 index. And we want to get the char code at the 0 index. And just to show you what that is, we can return start, and if I run the code, we get 97, which is the character code for the letter A, which is the first one passed in. So now I'm going to loop through the array. So as long as I is less than array dot length, and what I'll do is get the code for whatever letter is in the current iteration. So I can do that. Let's put in a variable called current, and I'll just set that to whatever array item we're on, and then char code at 0. And I can do a console log of that just to... The reason I do these console logs is so you can see what's going on at each line of code. What am I getting from this? So if I run that, I get 97, 98, 99, 100, 102. So that's the code for these. So obviously there's a issue here. It goes from 100 to 102. So how can we check for that? Well, we can basically just say if the difference between the current character code and the start character code is greater than 1, then we can return that missing letter. So let's put a conditional here, and I'm going to say if the current code is, or current code minus start is greater than 1, then we can return. And what we want to do is convert the character code back to the letter, because obviously we want to return the letter. So on the string constructor, there's a method called from char code, which will do the opposite. It'll take the code and turn it into the letter. So I want to pass in here whatever the start is plus 1. Now, before I end the for loop, I do want to update the start code, because this starts at 0. So we want to update that by saying start equals current. And then after the for loop, basically if there's no letters missing, then we just want to return an empty string. Okay, so let's try that. We'll run this, and we get E. So A, B, C, D, F. So we're missing E. And if we run our test, that passes as well. All right, so two very, very different solutions, but we get the same result. Okay, so in this challenge, we're going to have a function called are_all_characters_unique that's going to take in a string and it's going to return true or false depending on whether all the characters are unique. Okay, so if we look at the examples here, so A, B, C, D, E, F, G, that's going to be true because these are all unique characters. And uppercase and lowercase are going to be, they count as separate characters. So even if we have A, B, C, D, E, F, G, and then uppercase A, it's still true. They're still unique. So this one, the word programming, is going to return false because there's multiple characters. You have two M's in here, you have two G's, and so on. An empty string is going to return true, and just one character will return true because it's still unique even though there's one. All right, so as far as hints, you can use a for loop to iterate through the string and check if the current character is in the set or object. So I'm actually going to show you two ways of doing it. One way is using an object to keep track of the characters in the string, and the other way is using a set. So let's go into the JavaScript file. Now, if you want to pause the video, you can. And I'm going to start off using the object to keep track. They're both going to be very similar, just one uses an object, one uses a set. So let's pass in the string. Then we're going to create an object called char count. So that's going to just be an empty object, but what we're going to do is loop through the string that's passed in, and let's say we pass in ABC. What this is going to end up looking like is going to be A, true, B, true, and C, true, because they're all unique. If we pass in another C, then it's going to hit that and it's going to return false from the function. Okay, so let's put that back to an empty object, and then let's loop through this. So let I equal 0, and as long as I is less than the string length. And first thing I'm going to do in the loop is get the current character. So I'll put it in a variable called char, and we can get that with the string at the current index. Okay, so if I console log that, char, and then we run. Now this run file actually runs it 3 times. I'm going to just comment out these just so it's not, confusing. And we're just passing in A, B, C, D, E, F, G, which is, they're all unique. But right now, if I run, we're just going to see A, B, C, D, E, F, G, because we're just logging each character. So what I want to do is check to see if the character is already in the object. Actually, before I do that, let's just add, let's say, char count, and then char, which would be, either A, B, C, D, depending on what iteration we're on. We'll set that to true. And then what I'll do is just console log char count, just so you can see what that object looks like. So now if I run this again, you can see we have in the first iteration A true, then A and B true, A, B, C true, all the way up to, A, B, C, D, E, F, G. So what we'll do is, before we set that, I just want to check to see, we're going to check to see if the char count char, then we're going to return false. So basically, if it shows up again, then we're going to return false, because that means that there's, they're not all unique. So, and also we want to return true, obviously, if there's no characters repeated. So after the entire loop, if everything is okay, then we'll return true. So now let's come back here and let's run this, and we get true, because all of these are unique. Now, if I pass in another lowercase a, and then I run it, now we get false. And I can log that object again. So right here, let's say console log char count, just to see what that looks like. So we get A, B, so the whole thing, they're all true until we get to the lowercase a. In fact, I'll put it closer to the beginning here. So let's say A, B, and then A. Then it won't show all these because it'll return false as soon as it hits it. So let's run. And now we just get A true, B true, and then it goes to false because it hits A again. All right, so hopefully that makes sense. I'm just going to get rid of that console log. Now we can also do this with a set, and it's very similar. So what I'll do is just copy the whole function, comment that out, and instead of initializing an object, we can initialize a new set. And then down here, same thing, we're just going to loop through, we're going to get the current character, and we can just check the set now. Instead of checking for the object, we can say if the char set, let's call this char set instead of count. So if the char set, and sets have a method called has, where you can check to see if something is in there, in the set. So I want to check for char. So if it has it, then we want to return false, else then get rid of this here and say char set dot add, that will add to a set, char. And same thing, we just want to return true. So this will check to see if it's already there, if it's not unique. If it's not unique, it'll return false. If it makes it through and everything is unique, then it'll return true. So let's try that one. And we get false for this. If I take out that lowercase a, now we get true. And we can try our test out. And that passes. All right, so I mean, you can use an object, you can use a set. There's a lot of other ways to do this as well. But that's it. Let's move on to the next challenge. All right, so in case you haven't noticed, I have been putting challenges together that are fairly similar. So in the last challenge, we checked to see if all characters are unique. In this one, we're going to find the first non-repeating character. So the way we go about it will be similar. We'll have either an object, or we could use a map data structure to keep track of the count for each character. So the way it'll work is we'll pass in something like this. You can see we have AA, so that's considered repeating. Then we have B, and then CC. So B would be the first non-repeating character. This one here, AABBCC, that will return null because they're all repeating characters. And then this one here, ABCDEF, would return A because A is the first non-repeating character. They're all non-repeating, but A is the first one. So the input string will contain lowercase letters and spaces. Hence, you can use an object or a map to keep track of the times each character appears in the string. You can iterate through the string and check if the current character has only appeared once. So I'm going to give you a solution using an object and a solution using a map. And again, I know we haven't really gone over maps or sets. That's something I want to talk about in this, where is it? Right here, section 6. We'll talk about hash tables, maps, and sets and do more with them. So let's jump into our JavaScript file. Let's pass in our string. And just like in the last challenge, I'm going to create a char count object. And whoops, that should be lowercase c. And basically what this is going to do, what we want to do in the loop that we're going to create, is go through the string. Let's say we pass in the string programming. So it'll look at the P and it will add a 1. Okay, because it's there one time. It'll go through, it'll find the R, it'll add a 1. It'll find the O, add a 1, G, add a 1. When it gets to the second R, it's going to increment the R here. That's why you don't see a second R. All right, when it gets to the second G, it'll increment that and so on. If there were 3 R's, then this would get, would increment again. So that's ultimately what we want to do, and that's how we can check to see what's the first non-repeating, because we just need to look for the first one. In this case, it would be the first character, P. All right, so that's kind of the gist of how this is going to work. So let's do a for. I'm actually going to use a for of, which is a little more concise. So we'll do const, call this char. You can call this whatever you want. It just represents each character in the string. We want to say of str. And then we want to set, let's say, char count and then char. And we want to set that equal to, let's open up some parentheses and say char count char or 0, and then outside of the parentheses +1. And that's going to do what I just showed you. It's going to add 1 if it's not there, and it's going to increment it if it is there. In fact, we can take a look at that. If we console log char count, and we go to our run file, and I'm just going to comment out the second result for now. So we're passing in programming. If we run that, you'll see on the first iteration it adds 1 for the P. Second, it adds 1 for the R, 1 for the O, 1 for the G. And then when it gets to the second R, it increments R that's already there. Okay, it doesn't put in a second R. Same thing with the M or G, anything that's repeated. Now, what we want to do is we want to find the first one, but if I do that within this for loop, it's not going to work, and I'm going to show you why. So if I say if the char count char, so if the current character is equal to 1, then we want to return that character. And then outside of the for loop, we want to return null because we want to return null if there's no repeating characters. Now, this isn't going to work. It's going to work for the word programming, and I'll show you why. So if I run this, we get P, which is the first non-repeating. But if we try the second one here, which you can see this A is repeated, B is repeated, C is not. So that would be the first non-repeating. But if we run this code, I didn't save it. If we run this code, we get A, which is wrong because A repeats, B repeats, it should be C. But the reason for that is because the first pass through, A is 1. It doesn't get incremented until it hits the second one. But in our if statement, we're going through each iteration. So as soon as it hits that 1, it's returning it, which is not what we want. So what we're going to do is cut this if out, and we're going to have another for loop. So let's say for const char of str, and then in this loop, we're going to go ahead and do that because it's going to go through and create the object first here, adding the 1, 2, 3, however many characters. Then after that, we're going to loop through the completed object, and then it will get the first one. So let's save that, and now let's run this code again, and now we get C, which is correct. Okay, so let's run the test. I'm going to rename that, and then we can run that down here, and it passes. Okay, so we could also use a map for this, and the solution will be very similar. So I'm just going to copy this, comment it out, because it's very similar to this. So I'm just going to use this code to start with, but instead of an object, we'll create a new map. All right, and then we're still going to loop through with a for of, but instead of doing this, we're going to take our char count, which is now a map, and we're going to use the set method. So we're going to set char, and then we're going to use that expression, char count, and we're going to get the character with get, so char, and after the first parentheses, we're going to say or 0, and then outside of that, we'll say +1. So this is doing the same thing as this, except we're using a map. Now, down here where we loop through, instead of using char count char, we can use the get method since it's a map. So we can say .get char, and if that's equal to 1, then we're going to return it. So that should work as well. So if we run our test again using the map version, that works. Now, if this confuses you and you don't know anything about maps, don't worry about it, because again, we're going to really get into them more later. Okay, so that's it. Let's move on to the next challenge. Okay, so in this challenge, we're going to write a function called dice game simulation that simulates a dice game, and it takes in one argument of the number of simulations, which is basically going to be the number of rolls. Now, the game rules are if a 7 or 11 are rolled, the player wins, and they'll get a result of win. If a 2 or 3 or 12 are rolled, they get a result of lose, and anything else, they get a result of roll again. Now, the function should return an array of objects where each object represents a simulation result, and each object should contain a dice 1, whatever, 1 through 6, dice 2, whatever's landed for that, 1 through 6, the sum of the two dice values, and then the result, which will be either win, lose, or roll again. Okay, so function signature, we just have the number of simulations that's passed in as a number, and it returns an array. And then an example would be we call it with 3 simulations, we would get back an array. This should actually have some brackets because it would be an array of objects with dice 1, dice 2, sum, and then result. You can see this one is 11, so they won, 2 they lost, and 6 they would roll again. So for hints, you can use the math.random function to simulate rolling a die. It returns a number between 0 inclusive and 1 exclusive, but we can, of course, manipulate that to be a random number between 1 and 6. All right, so let's get into it. If you want to pause the video, you can. Now, the function itself is going to take in a number of simulations, so we'll call that num simulations, and we need to simulate a single roll of the dice. So what I'm going to do is up above it, we'll create a function called roll dice. You could put the function in the other function as well if you wanted to encapsulate it, but I'm just going to put it outside, and we'll say return. On the math object, we want floor, which will round down whatever we put inside here, and what I'm going to put in here is math.random, which will give us 0, a number between 0 and 1, a decimal. So I want to multiply that by 6, and I want to add 1 to it so that we don't get 0. We get 1 instead of 0 through 6, 0 through 5. We get 1 to 6. Okay, so that will roll the dice. Now, in the dice game simulation function, I'm going to first just create an array called results. It'll start off as just an empty array. Then we're going to loop through the specified number of simulations. So let's say 4, and we want to define I, set that to 0, and as long as I is less than the num simulations, then what we want to do is first get the dice 1, so we'll call this dice 1, and set that to roll dice. Okay, and then we're going to const dice 2, set that to roll dice. Oops. So that will give us 2 numbers between 1 and 6. Now we want our sum, so const sum. We're going to set that to dice 1 plus dice 2. Now we need to check, actually let's initialize a result variable, a string. So we'll say result equals just a string, and then let's check for a win. So we'll say if the sum is equal to 7, or if the sum is equal to 11, then the result, return result, is going to equal the string of win. Okay, and then let's check for a loss. So else if, remember, a loss is going to be 2, 3, or 12. So let's say sum equals 2, or sum equals 3, or sum equals 12. So in that case, then we're going to take result, and we're going to set that to lose. Now, if it's not a win or a loss, so in else, then the result is going to be roll again. So that takes care of that. Now we want to push the object onto the results array. So let's go underneath that if statement and take our results array, and we're going to push onto it an object with the dice 1, dice 2, sum, and result. And I'm using the variable name is going to be the same as the key, so I only have to do this. I don't have to say, you know, dice 1 is dice 1. Same thing. So that will push it on. Now, after the for loop, we just simply want to return the results. Okay, so let's try it out. We're going to go to the run, and you can see I have 10 simulations, so let's run that. And we get back an array with objects. The first one is 3 for the dice 1, 4 for dice 2, sum of 7, that's a win. 11, that's a win. 10, roll again. 6, roll again. Win, win. So we didn't get any losses. Let's try it again. We'll run again, and still no losses. Let's run again. Pretty good at this. There we go. So this one, excuse me, this one, dice 1 was 1, dice 2 was 2, sum was 3, that's a loss. Now we just want to test it, so let's go to our file here and rename to test.js, and we'll go to our terminal. Let's run npm test, and it passes. Okay, so that's our dice game challenge. Let's move on to the next one. All right, guys, so now we're going to create a function called format phone number that does just that. So if we look at the signature here, it's going to take in an array of numbers, and it's going to return a string, and that string is going to be a formatted phone number. Now, for the constraints, the input array will always have 10 numbers, so it's going to be formatted as a United States phone number. The numbers can be any integer between 0 through 9. So if we put something like this, where we just have, you know, 1, 2, 3, 4 up to 0, it would be 1, 2, 3 in parentheses, so the area code, and then it would be 5, 4, 6, and then 7, 8, 9, 0 with a space and a dash. So it should be formatted exactly like that. So for hints, you can use the array.join method to concatenate the numbers in the array. You can use the array.slice method to get a subset of the array. Okay, so those are two methods that you might find useful. So let's get into it. If you want to pause the video now, you can. So I'm going to go ahead and pass in numbers here. I'm going to give you 3 different solutions that are pretty similar, but just different ways of doing it. So let's pass in numbers, and that's going to be an array of numbers. And then I want to get the first 3 numbers and join them together. So let's say const, we'll call this area code because that's what it is, the first 3 numbers. And we're going to take the numbers array, and then I'm going to say slice, and I want to get from the 0 index, and I want to go 3 from that. And then I want that to be a string that we join together, so we're going to say join and pass in an empty string. Okay, now we can check that out by just returning the area code. We'll go into the run file here, and let's run that, and we get 1, 2, 3, right? Because we're passing this in. So it's a string of 1, 2, 3. So the next thing we need is the, I guess what we call the prefix, the next 3 numbers. So let's say const prefix, and let's set that to numbers dot slice. And so slice is just basically slicing the elements out of the array. So we want from the 3 index, right? Because that's the 4th number in the array is the 3 index. And then we want to go to 6. All right, so that'll be the next 3 numbers, and we're going to join those. Pass in here an empty string like that. We can return prefix. If we go to the run file here, then we see 4, 5, 6. All right, and then for the rest of the numbers, let's say const, we'll say line number. And again, we're going to use slice. And we can just pass a 6 in here. What that'll do is get the index of 6 and then get the rest of them from there. And we know the rest is the last 4 numbers. So we're going to join. Okay. And if we want to check that out, we can say return line number. And we check it out. And we get 7890. All right. So we have the different parts of the phone number. Now we can just return the formatted number. So I'll use a template literal here, and we'll put in the area code, and then actually let's put the area code in parentheses and then a space, and then we'll have the prefix. Okay, so we get the prefix and then a dash, and then we have the line number. So now if I come over here and we say run code, there we go. So now it's formatted as a phone number. Now another way we could do it, let's comment that out. Okay, so function format phone number, and that's going to take in an array of numbers. Okay, so here I'm going to say const, and we'll call this formatted, and I'm going to take all the numbers, so the entire array, and turn it into a string by using join. Okay, so instead of doing it piece by piece, I'm turning the whole thing into a string. If I return formatted and we run this, you see now we just get the whole thing as a string. Now I'm just going to go, actually we'll return from here a template string, and in here same thing, I'm going to use parentheses and then the formatted. So formatted, and then I'm going to use substring because I want part of that formatted string, and I want 0, 3. Okay, so that should give me the area code. Then I'll put a space, and then I'm going to do formatted, formatted again, and substring again. And in substring now, we're going to do 3 to 6, and then after that, we'll do a dash, and then we should be able to get, oops, what did I do here? Well, that should be right. Formatted dot substring, and we should be able to just pass in 6, and it should get from 6 on, so it should give us the rest. All right, so let's try that out. We'll run the code, and there we go. So we get the same result. So here we were kind of slicing them up into individual strings and then putting them together, where here we created one big string and then we use substring to get the different parts of that afterwards. Now we could make this shorter with an arrow function and an implicit return and still do it kind of like what we did here. So let's do that. So very similar to the first function, but just in a shorter format. So let's say format phone number as an arrow function. So it's going to take in numbers. All right, and I'm going to do an implicit return of a template string. So basically in here, let's take the numbers and then slice. We want 0 to 3, and then we're going to chain on to that the join, pass in just an empty string. Okay, now after this, let's see, we want parentheses around this actually. So at the beginning of the template literal, let's put our parentheses because this is for the area code. And then at the end, after this curly brace, we have our parentheses. Then I'm going to put a space, and then we'll do the second part. So we want our numbers. We're going to slice, and we're going to slice 3 to 6, and then we're going to join. So that gives us a second part. And then after that curly brace, we're going to do a dash, and then we should be able to just do numbers dot slice 6, so that will get the rest, and then just join it. like that. Okay, so this is very similar to what we did here, except here we're actually doing the slicing and all that inside of the template literal rather than doing it outside and then putting them all together in the template literal. So let's try that. Okay, so that works. I prefer this way. I think this is more readable. This is shorter, but I think that this is better for me at least. I mean, everyone has preference. In many cases, I do like shorter arrow functions with implicit returns and chaining, but when it's this long, I'd rather just type it out so that it's more clear what we're looking at. All right, so let's run the test. We're going to rename this to .test, and this should pass no problem. So let's run. And there we go. So we have 18 pass tests. If you want to go and test each one of these individually, you can, but they're going to pass. Okay, for this challenge, we're going to do something that you've probably done before. We're going to create a validate email function. So we're going to write a function called validate email that takes in a string and returns whether the string is a valid email address. For the purposes of this challenge, a valid email address is defined as a string that contains an @ symbol and a period. Now, for the examples here, you can see we pass in john@gmail.com. That's going to be true. If I just do john@gmail, that's going to be false. Now, if you know regular expressions, this is a great place to use them. I'm going to give you two solutions, one that uses regular expressions and one that doesn't. So regular expressions can shorten your code a lot. They're very, very helpful, but they are also very annoying, at least in my opinion. And for me, it's very difficult for me to remember them. So I constantly have to look them up. So we're going to do a solution with regular expressions first. And I'm actually going to use ChatGPT to give me a regular expression for an email. Normally, or not normally, but back in the day before ChatGPT, I would have went on Stack Overflow to find regular expressions. So let's start off here. You can pause the video if you want and try it yourself, but we're going to pass in email or a proposed email, and then const, let's say email regex, and that's the regular expression is going to go in between two forward slashes. So now what I'm going to do is go to ChatGPT, and I'm going to say, give me a regex for an email address for my JavaScript code. And there we go. It's as easy as that. So, and it even gives us a function here, but I'm just going to grab the code itself. Actually, I'll just copy this whole thing. Okay, and then we'll just place that in here. It's the same variable name I was going to use anyway. And then all we have to do is use the test method. So we can say return email regex and then .test. What that will do is it'll test whatever we pass in against that regular expression, and it'll give us true or false. So that's really all we have to do for this function. If I go to the run, and let's go ahead and run this code here, we get true and false. So this is true, that's a valid email, this is not. And you can mess around with it if you want. If you want to run the tests, let's rename that to .test. Come over here and run it. And there we go. So our test passed. Now what I want to do is show you how to do this without using a regular expression. So I'm going to comment that function out. We'll create another validate email. I probably should call that string or something because it might not be an email, might not be valid. But let's go ahead and check. So what I'm going to do first is check to see if the email contains an @ symbol. So we can say if email.index of, and then we'll pass in the @ symbol here. So I'm going to say if that is equal to -1, then we're going to return false. All right, now what this is doing is looking at whatever we pass in here, email, and if it doesn't have whatever we have in here, in this case an @ symbol, what index does is it returns a -1. So if it's not in there, then this is going to be -1. If it is, then it's going to be true. So if there's no @ symbol, then obviously it's not a valid email, so we're just going to go ahead and return false. Now what I'm going to do is split the email into the local part, which would be like Brad, and then the domain, which would be, gmail.com or whatever. So let's do, well, first off, let's say email.split. So remember, this will split into an array, and it'll split on whatever I put in here, and I want it to split it on the @. And let's go ahead and, you know what, let's just return this so you can see what this gives us. So now if I run the run file, and I just want to run it once, so let's just comment those out. So this is what it gives me. It gives me Brad, an array with Brad as the first element, and then gmail.com as the second, because it broke it on the @ symbol. If I do the other one here, this should return false already, just because, remember I said if it doesn't have an @ symbol. So if I run that, then we get false. But I'm going to do my testing on this email. All right, so we know that it does that. Now we can actually use destructuring here on an array. So I'm going to say const, and then in brackets, since it's an array, and I can basically call the first, the Brad something, which I'm going to call local part, and then the gmail.com I'm going to call domain. Now I'm just going to run a few checks. So we're going to say if the local part dot length is equal to 0, so if there's no local part, or if the domain dot length is less than 3. And then remember, the domain includes whatever dot whatever, so gmail.com. So that should definitely be more than 3 characters. So domain dot length less than 3, then we're going to return false. Okay, and then the last thing I want to check is the domain extension. So if we say const domain extension, and what I mean by that is the .com, .net, .io, whatever it might be. So we can get that. We can say domain.split and split the domain on the dot. Okay, so we can return that and see what that gives us. If I run that, we get Gmail and com inside of an array. So domain extension 0 would be the Gmail, domain extension 1 would be com. So if you want to just test the extension for something, then you could use domain extension and 1 as the index. So what I'm going to do here is just check, and let's say if the domain extension itself, if that array length is less than 2, then we're going to return false, because you should at least have 2. You can have more than 2 because you might have like a subdomain, but we want to check that. Or if the domain extension with the 1 index, which is the right here, the .com or net, whatever it might be, we want to make sure that that's not less than 2. So if that is less than 2, because most are 3, but there are some with 2. You have .io, you have .it, and .me. So it can be 2, but if it's anything under that, then we want to return false. Okay, and then underneath all the checks, we're going to return true, because that means that none of this stopped it, meaning it passed. So we want to return true. So now let's go ahead and run this again. So we get true. If we uncomment result 2, then we get true for the first and false for this, for the second. And if we run our test, that passes. So you can use the regular expression, which obviously makes the function a lot shorter, or you can do it like this and just kind of custom test for everything. All right, so that's it. Let's get into the next section, which is going to be all challenges that have to do with high order array methods. All right, guys, so most of the challenges that we've done so far, we've used loops, specifically for loops. And loops are one of the biggest fundamentals in not just JavaScript, but in computer science in general. So it's important that you know how to use them. Now, for the next batch of challenges, I want to utilize some of the high order array methods in JavaScript, such as map and filter. And these methods are very useful. They can help you write cleaner, shorter code. Using loops like a for loop is usually more efficient, but the difference is really negligible unless you're dealing with very, very large data sets. In everyday code, I think, in my opinion, it's better to write clean, shorter code that's easy to read and understand. So I like utilizing these methods. Now, most of you probably know what high order array methods are and probably know how to use them. So you can skip this video if you want. This is really for the newer people that don't really have them quite drilled down yet. All right, so let's jump into this file. It's called simpleexamples.js. There's also a done version, and we're just going to deal with this very simple array of 1 through 5, and we're going to start with map. So map will transform array elements with a provided function, and it creates a new array. Okay, so that's important to understand. It's not like for each where it just iterates through an array. It actually returns something. So let's say that we want to take this array right here and we want to double each number. We want to return an array that has each number doubled. So map is a good solution to do something like that. So we're going to create a variable called doubled numbers, because remember, map returns an array. So we're going to set that to the array name and then .map. And in that .map, we're going to pass in a function. And this function takes in, at the very least, it takes in one argument of whatever you want to call each element in the array. In this case, I'm going to call it num. And then I can do whatever I want with that. So if I wanted to just return num, I don't know why you would do this, but let's console log double numbers, and then we'll run this file, and we get the same thing back, right? So I'm just calling map on this array, and I'm returning each number. So this function runs on each of these. Now, to return the doubled number, I would simply return num and then multiply that by 2. So now if I run the code, I get 2, 4, 6, 8, 10. So now it's doubling it. So you can do anything you want with each number in the array. Now, there's some other things you can pass into here, such as the index. Okay, so I'm going to go ahead and just do a console log of the index, and we'll run this again, and you'll see it starts at 0, 1, 2, 3, 4. So it gives you the index of each element in the array in case you need that for something. You can also get the entire array, so that would be the third thing we pass in. So if I console log array and I run the code, you can see that it gives me the initial array of 1, 2, 3, 4, 5. So those are the three things you can pass in, but in most cases, you're probably just going to pass in the num. Now, I do want to mention with callback functions like this, if you only have one thing you're passing in, such as we are here, you don't even need to use parentheses. This is perfectly valid. If you're going to have two things, like if I wanted the index, I can't do that. Then I would need parentheses around it. But if I save, it's going to add the parentheses just because of my settings in my editor and prettier and so on. All right, and you can make this shorter too. So you can, since it's an arrow function, we can do an implicit return. So we can get rid of the ending curly brace. We can get rid of the return and the beginning curly brace, and that should work just fine. So next we have filter, which will also create a new array, but it will be with elements that satisfy a specific condition. So let's say we want to return an array with only the even numbers in this array. So what we would do is let's create a variable called even numbers, and we're going to set that to the numbers array, and then we're going to call filter on that. And just like map, it takes in a function, and I'm going to pass in num, so we get to do what we want with each number. And in this case, what I want to return is a condition. So I'm going to say if num and then modulus 2 is equal to 0, meaning if it's an even number, then what it's going to do is it's only going to return the elements in the array that match this condition. Okay, so let's try that out. Let's do a console log of even numbers. I'm just going to comment out this other console log, and then we'll run the file, and you can see we get 2 and 4. Okay, it didn't change this initial array. That's important to know. And again, I know most of you know this, but just for the people that don't, just want to show you, if I were to console log the original numbers array and run it, it doesn't affect that. It creates a brand new array and puts it in here. It just uses that beginning array and then manipulates it. And this could be anything. It could be, let's say, if you want to return any number that is greater than 2. So if I do that and I run, then it gives me an array with 3, 4, and 5. Okay, so it takes this array and it creates a new one from that array that matches this condition. So the next one we're going to look at is reduce. So what reduce does is it accumulates array elements into a single value using a provided function. So reduce is really great for things like if you have a shopping cart and you want to add all your products or your tax and all that stuff together, you can do that really easily with reduce. So what I'm going to do is get the sum of all the numbers. So we'll say sum equals and then numbers dot reduce. And reduce is going to take in two things. It's going to take in what's called the accumulator, which I'll call the total. You can call it anything. And that's going to be the number that we keep adding to. All right, so the total, we want it to start at 0, and that's actually the second parameter that we pass in, or the second argument that we pass in is where we want the total or the accumulator to start. And then the second thing that reduce takes in is going to be the number, or whatever we want to call this. It just represents each element in the array, so each of these. Okay, now what I want to return from this, so let's say return, I want to take the total and add the num to it. So it's going to loop through the array and it's going to add each num to the total, and the total is going to start at 0 because that's what I put here. So let's go ahead and console log now the sum, and we'll go ahead and run that. We get 15. So 15 is what we get if we add 1 plus 2 plus 3 plus 4 plus 5. Now I could change where I want the accumulator to start. Maybe you already had some tax or something that you start with, like, I don't know, $15. So if I do that and then I run the code, I'm going to get 30. Because it's starting at 15 and then going through and adding the rest. But you're usually going to set that to 0 for most things. Now, for each is very simple. For each is kind of just it's a shorter way of looping through an array than using a for loop or a while loop. So let's just loop through the array above. I'm going to say numbers dot for each, and again, it's going to take in function, and we'll call each one num. You can call it whatever, but we'll call it num, and then I'm just going to console log the num. All right, so it just loops. It doesn't, actually let me comment this out. Yeah, we'll comment that out, and then we'll run. You can see it just logs 1, 2, 3, 4, 5. So it doesn't return anything. It's just it's basically a shorthand for a for loop. Instead of doing, for I equals 0, I is less than array.length, I plus plus, and then in the for loop doing something like this to get your array element. Here you can just use num, so it's much cleaner. So next we're going to look at find, which will return the first array element that satisfies a specific condition. So let's say we want to find a certain number. Let's call this found number. And we're going to set that to numbers.find, pass in our function, and we'll call this num. And here I'm going to say number greater than 2, just like I did with filter. But you'll see the difference here. If I do a console log now of found number, I'm just going to comment this console log out. So if I run this code now, I get 3. It doesn't give me an array of elements that match this condition. It gives me the first element, okay, which is a number. It gives me the first element that matches it. So if you want to find one specific thing, that's find is good for that. Okay, and I'm just going to shorten these up a little bit. So for this one, I can do that, but I'm just going to comment it out. For this one here, get rid of that. We can get rid of the curly brace here like that. And then for filter, get rid of all that and the curly brace. Okay, now I have 2 other ones I want to show you here. There's more, but I just want to show you these ones. So sum will check if at least one array element satisfies a condition. So let's call this has even number. And this will actually return a Boolean. So let's say has even, what am I doing? Has even number equals numbers dot sum. And we'll pass in a function here, and we'll call this num. And let's say, we just want to see if there's at least one even number. So we can put a condition here. We can say num, and then the modulus, and then 2 is equal to 0. So that's the expression that will tell us if something's even. So now let's console log has even number. We'll go ahead and comment this one out, and let's see what we get. So we get true. Okay, now if I change this to let's say num greater than 5. So if I run that, I get false because it's only 1 through 5. There's nothing in the array that's greater than 5. So you can see that these are all useful in their own way. Now the last one I have here is every, which is similar to sum, except it checks if all array elements satisfy a condition rather than sum. So let's say const all nums greater than 0. Okay, and we're going to set that to numbers dot every, pass in our function, pass in num, and let's say for our expression we'll say num greater than 0. Okay, and then we'll console log all nums greater than 0. Let's run it, and we get true. It's still logging this. This is the false that we see, but that's logging true. Now if I were to come up here into the array and add -1 and then run this, now I get false because there's now a number less than 0. All right, so hopefully this helps some of you guys out if you're not that familiar with these methods, and in the next 10 or so challenges we're going to be using these to solve them. Okay, so we're going to start off with something that's fairly easy. If you guys already know filter, map, and reduce, we are going to use all 3 of those in this challenge. It's pretty easy for those of you that know it. If you don't, I still would suggest trying it after watching the last video and seeing how map, filter, and reduce work. So basically we're gonna sum the square of even numbers. Okay, so the way that this is going to work is we'll pass in an array of numbers. We're going to get the even numbers first, so in this case it would be 2 and 4, and then we're going to square them, so 2 squared and 4 squared, and we're going to add all the numbers together. So as far as hints, we can use, and this is kind of giving away a lot, you can use filter to even the numbers from the array, so basically filter out odd numbers. Then you can use map to square each even number. And you can chain on map to filter, reduce to map, and so on. Reduce, you can use that to sum everything up in the array, all the squared even numbers. All right, and if you pass in an empty array, then you should get 0. So I would suggest that everyone pause the video and try it out. If you don't get it, that's fine. But let's jump into the JavaScript file here, and we're going to pass in numbers as the array. And let's create a variable. We'll call it even squares, and we'll set that to numbers. Now I'm going to chain on these 3 methods. So we're going to start with filter, because the first thing we want to do is filter out the odd numbers. So filter takes in a function. We'll call each number num, and then we'll say we want to return if the number is even. So we'll say number and then modulus 2 equals 0. So that'll give us only even numbers. And down here we're going to return the even squares array. Okay, remember, filter is going to give us an array back, but only with the even numbers. So if we open the run file, let's see, yeah, we'll pass in 1 through, let's add a couple more here, so 7, 8, we'll do that, and then run the code, and we should get, yep, an array of 2, 4, 6, 8. So we've got that part down. Now we want to chain on to this, so I'm just going to move filter to the next line here, and then underneath filter we're going to put map, because this is where we're going to square each number in the array. Now when you filter, when you chain on methods like this, this num now is only going to be the array with even numbers, because we changed that array here. We manipulated it into this, so that's what we're going to get here. Okay, we're not going to get the original array here because we already filtered it. So let's add our function, and the way we're going to do this is just you take the num and square it by using *2. So we can check it up to this point. What did I? Oh, we want to get rid of that semicolon. So if we check it now, let's go to the run and see what we get, and we get 4, which is 2 squared, 16, 36, 64. So that's the second part. That's 2 of 3. Now we want to add them all together. So what we can do is now get rid of that semicolon and then chain on reduce. And for reduce, remember it takes in an accumulator, so we'll call that sum. And then for each number, we'll call it squared, because it's a squared number. And then what we want to do is take the sum, and we want to add the square, and we want to start off with that sum being 0. So that's the second parameter that's passed in to reduce. And that should do it. So we'll save, and let's come back over here and run, and we get 120. Okay, and let's test it out. So we're going to rename the test here to .test. And you can see it's going to test it for these, test it with negative numbers, test an empty array. So let's go to our terminal and run npm test. And we should see that pass. Yep, there we go. Okay, so again, if you didn't get it, that's absolutely fine. But hopefully this kind of clears it up for you. We just basically, we do it in steps. So in this challenge, we're going to calculate the total sales of some products. So basically, we're going to have a function that takes in a products array that's going to look like this. It has a name, a price, and a quantity. And what it's going to return is the total price with including the tax rate, because the function will also take in a tax rate. So if we look at some examples here, you can see we have this array being passed in. We have for price 0.5, 0.3, 0.6. So 50 cents, 30, 60 cents. Quantity, that's another thing you have to take in account for. So obviously the price here is going to be this times this. And then the tax rate we're passing in is 8, which is 8%. So basically you need to add all these together, including the quantity, or taking the quantity into account, and then add the 8% tax. And in this case, it would be 21.6. Okay, this one here, so 2.5, 1.2, but also taking in account the quantity, we have a 5% tax rate. That's going to be 42. So this is kind of a tough one, I would say. So for constraints, the input array will contain at least one product object. The price and quantity values will be positive numbers. The tax rate will be a positive number less than 100. And we're going to round to 2 decimal places. For hints, you can calculate the total sales amount before applying the tax and then add the tax amount to it. All right, so let's go ahead and open the JavaScript file, and we know that the function is going to take in a products array of objects and then also a tax rate, which will be a number from 1 to 100. And then the first thing I'm going to do here is calculate the total sales amount using the product price and the quantity, and I'm going to use reduce for that. So let's say const total sales, and this is what reduce is really good for, is this type of stuff. If you're building like an e-commerce platform, you're probably going to use reduce quite a bit when it comes to the cart and all that stuff. So let's take the products array and let's call reduce, and reduce is going to take in the function and the accumulator, we'll call that sum, and then we have each product. Okay, and we want that to start at 0, so of course we want to add in 0 as the second argument here. Now I'm going to take the sum and we want to add to that. Now this is different than what we did before, because it's not just an array of numbers, they're objects. So we have to make sure that we choose the right values, the right, like if we have, let's look at the run file. So we want to make sure we choose the price, and we also want to multiply that by the quantity. So we'll say sum plus the product, which is the object, and then the dot price, which will give us the price. And then we want to multiply the product dot quantity. Okay, so that should give us the total sales. Now that doesn't count the tax, so that's what we want to do next. So let's go under the reduce here. I'll go ahead and save that. We'll go under the total sales. Actually, let's return total sales just to see what that gives us. So we're passing these objects in, and we get 20. Now we can make sure that's right. I'm just going to use a calculator here because I'm not that great with math. So we have 0.5. and we have 10 of them, right? So we're going to multiply that by 10, which gives us 5. And then we have 0.3 times 20, which gives us 6. Okay, so that's 11. And then we have 0.6 times 15, which is 9, and 11 plus 9 is 20. All right. So we know that we're getting the right amount. Now we have to factor in the tax. So the first thing we'll do here is calculate the tax amount using the total sales amount and the tax rate. So let's say const tax, or let's call this tax amount, and that's going to be the total sales multiplied by the tax rate and then divided by 100. So that'll give us the tax amount. Now, let's say const total sales with tax, and we're simply going to take total sales and we're going to add the tax amount to that. That'll give us the total sales with tax. So what I want to return here is the total sales with tax, but I'm going to wrap it in parse float to parse it as a float. And I also want to add on to it, let's say total sales with tax. I'm going to add on to it .toFixed because I want 2 decimal places. So we'll pass in 2 here, okay, if it has a decimal. So let's save that. Let's run this again, and we get 21.6. All right, and we can run our test. Come down here, npm test. and it passes. All right, so that is our calculate total sales. Let's move on to the next challenge. All right, guys, so this is an interesting one. This is called highest scoring word, and basically we're gonna pass a string of words into the function and return the word that scores the highest. And what I mean by that is each letter is going to have a score associated with it, and it's going to be in the order of the alphabet. So A will be 1, B will be 2, C will be 3, and so on. So if we come down here to the examples, you can see we're passing in a few words here, and the highest scoring would be taxi. And I would say the reason for that is because it has an X in it, and that scores very high because that's closer to the end of the alphabet. You know, Z would be 26 points, for example. A is just 1. And as far as constraints, the input string should only contain lowercase letters and spaces. It cannot include numbers, special characters, or punctuation. So as far as hints, you can use the split method to separate the words. You can use the map method to calculate the score for each word. And I would also throw in there that you can use the char code at method to get the Unicode character or the Unicode number for that. And remember, lowercase a starts at, I think it's 97. So you could subtract 96 from whatever that character code is and get the position. I know I'm kind of giving a lot away here, but I'd like you guys to be able to do this. And then you can use reduce to find the higher scoring word. Okay, so let's jump into our JavaScript file, and we're going to pass in a string here. So that'll be our string of words. And the first thing I'm going to do is split it into an array. So let's say words, set that to string, and we want to split that on the space because then it'll have each word as an array element. Now I want to get the scores, so I'm going to set that to the words array, and I want to map through that. So I'm going to pass in my function here and say for each word. And then what I want to do in here is just first initialize a score variable. Whoops. I want to initialize score to 0. And then I'm going to loop through. I'll use a for of loop here. So I'm going to say for const letter of word. Okay, so now we're looping through each letter of the word. And I'm going to take score, and I'm going to append or add on to that letter dot and then the character code. So remember, char code at the 0 index, and remember lowercase a is 97, lowercase b is 98, and so on. So if we take away 96 from that, that should give us the position, right? Or that should give us the score. So let's go outside of the for loop. Let's return the score. And for now, let's return scores just to see what that gives us. So I'm going to go to the run file now. We're passing in hello, my name is Xavier. And I'm going to run the code here. And now we get an array of the scores for each word. So hello is 20, my is 38, I would say, because it has the Y. It's kind of like Scrabble almost, where Scrabble has the, you know, the rarer letters are worth more, and the rare letters seem to be at the end of the alphabet. So name is 33, is 28, and Xavier is 79. Now ultimately what we want to return from this function is the highest scoring word, which we know is Xavier in this case. So let's get rid of the return scores, and I'm just going to create a couple variables. One is going to be, let's say, highest score, and we're going to set that to 0, and then I'm also going to set a variable of highest index, and we're also going to set that to 0, and then I'm going to do another loop here. So let's say for, and this is just going to be a regular for loop, so we'll set I to 0, and we want to say if I is less than scores dot length, because remember scores is that array that I just showed you. So we want to loop through that, and we're going to say if the scores and then I, so that's going to be the value of the score. If it's greater than the highest score, then we're going to set that highest score to whatever is in that value, value in that iteration. So that would be scores I. Okay, and then we're going to set the highest index equal to whatever the index is. Now all we have to do is return, we'll take the words array, and we have the highest index, so we can just pass that in there. So that should give us the word. So let's try that. I'm going to run this file again, and we get Xavier. If I take Xavier out and we run, the next one would be my. All right, but we'll put that back, and let's run our test. I'm going to show you another way of doing it as well. It's pretty similar, but a little different. So let's run a test, terminal, npm test, and it passes. So now let's go back into the main file here, and what I'm going to do is copy what we have here and then comment it out. So we are going to split it into an array just like we did before, and this is going to be a little shorter than this. Instead of, let's see, inside the map, instead of using a for loop, I'm going to use reduce. So we can actually get rid of all this right now, the return, the for loop, and the score variable. And what I'm going to do is turn this word into an array, because we're mapping through the words, right? We have an array of words, but then the word I want to turn into an array of letters. So we can do that with array.from, and we're going to pass into that word. In fact, let me just show you what that gives us. So if I return that from scores, and then I'm just going to get rid of the rest of this function for now, and then let's say return scores, and then if we run the run file here, now you can see that we have arrays of each character, of each letter. All right, now what I want to do with that is use reduce. So after this array.from word, let's say .reduce, and we're going to pass into reduce the accumulator, which is going to be the score, and then the letter. All right, and then what I want to return from here is going to be the score plus the letter dot char code at. So we're doing the same thing that we did in the last solution. So char code at 0, and of course we want to take away 96 from that, and that will give us the position, and we just want to add 0 as the starting value for the score. Okay, so this is just a shorter version of what we did here. So now underneath scores, we're going to have our highest score, and we can just basically get the max value of whatever's in the scores array. So we can do that with math.max, and then we're going to just spread across the scores in that array. And then to get the highest index, we're going to set that to scores dot and then index of, and we have the highest score, so we'll pass that in there. Then all we have to do is return, once again, words, and we have the highest index. Okay, so let's try that out. We'll try it in our run file first. We should get Xavier, and now if we run our test with that version of the solution, that passes as well. Now just to kind of reiterate what we did here, so we split the words into, or the string into an array of words. Then we created a variable and we mapped through the words, and created an array of letters for each word. And then we added on reduce, and here we have a score, which is our accumulator, and through each iteration, it's going to add on this, which is the letter character code, which starts at lowercase a as 97. So of course we want to take away 96. That would make lowercase a 1, and then lowercase b 2, and so on. So we're just adding them all together. Then here we're just getting the max of those scores. Then we're creating the index using the max of those scores. And then we're just returning the words array with the highest index. Okay, so hopefully that makes sense. So that's it. Let's move on to the next challenge. So this challenge is called valid anagrams. Now, an anagram is a word or a phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So basically, if we look at this example here, listen and silent are their anagrams. Okay, listen is an anagram of silent because it has the same, it's using the same characters and the same frequency of characters. Okay, hello world, obviously that's not, so that's going to return false. Astronomer and moon starter, those are anagrams because they are using the same characters and the same frequency of characters. So we just want to return true or false if it's an anagram. So hence, we want to split the string into an array of characters and then reduce each array into an object of character frequencies for the strings. And we've kind of done this before in a past challenge where we have an object and each key is a letter and then the value is the number of times it appears in that string. And then we just want to compare the frequencies. Okay, so let's go into valid anagrams.js, and if you want to try this on your own, you can pause the video. So we're going to pass in string 1 and string 2. That's what we want to compare. And the first thing I'm going to do is split the strings into an array of characters and then reduce the array into an object of frequencies. So we can do that with reduce. So let's say const, and there's two strings, so this one's going to be for the first string. I'll call it frequency count 1, and we'll set that to str1, and then split that. We want to split it into, each character will be an element in the array, so we just pass in double quotes. Don't put a space, because that'll split on each word. We want each character, because it should only be one word. And then from there, we're going to reduce. Now, for this reduce, we're going to pass in the accumulator. I'll just call it ACC. It's actually going to be the object, and then the character. Okay, so from there, let's pass in the second argument, which is where we want the accumulator to start. Now, this doesn't have to be a number. I think that confuses a lot of people. So this, we're actually going to set it to an empty object. Okay, and after I do this, I'll show you exactly what this gives us. And in the function body here, we're going to take the accumulator, which is an object, and then the character, and we want to set it to a 1 if it's the first time we're seeing it, because reduce is going to loop through that array of characters. If it's the first time we're seeing it, then we want to mark it as a 1. If it's already there, then we want to increment the one that's already there. So to do that, let's open up some parentheses and say accumulator and then the char. So we want to do that, or 0 and then plus 1. So this expression will do exactly what I just said. It'll put a 1 if it's not there. It'll increment the one that's already there if it is. And then we're going to return from that the accumulator object. Now, I want to show you what this gives us. So let's return frequency count 1, and let's go into our run file here. And you can see what I'm passing in here is app and then PPA. So that is an anagram. So let's run the code, and you can see we get A, 1, because A appears once, and then P, 2, because there's two P's. And I forget exactly what challenge we did this in, but we already did this exact thing. Now we want to do the same for the second string, so we could actually just copy that, and let's set this to frequency count 2, because the one we just looked at, this object down here, only pertains to this one. So now we want to do the second string. So this will be string 2. We're going to split into an array. And then this stuff here, this can all stay the same. Now what we want to do is compare the two objects of character frequencies by checking the frequency of each character in the first object and seeing if it's equal to the frequency in the second object. All right, now what we're going to return here, we're going to say object.keys. Now what this does, this object.keys, is it'll extract the keys, which are the characters, and we want to do that on frequency count 1. Okay, so that will get us the keys, and then I'm going to use .every, which will loop through the keys or the characters. So this will take in a function, and we'll say for each character, and then here we want to make sure that frequency count 1 character is equal to frequency count 2 character. Okay, and they all, every will return true or false, and with every they all have to match, right? If you use some, it's similar, but it just one has to match, but in this case they all do. So that should do it. We're going to save that, and let's go ahead and run this, and we get false. Let's see, what did, oh, forgot my second bracket here. It's over here. Okay, let's try that again, run code. That, yep, there we go. So now that's true. All right, so hopefully that's clear. We're getting the keys, and remember the keys are the, right here, as you can see this object that I printed out, the keys are the characters. So we're looping through those, and we're making sure that the character is equal to the character in frequency count 2. Okay, that means it's an anagram. So let's run our test. Go down here, run our test. Okay, and those all pass. So we have like listen, same thing that I had in the documentation. So yeah, that's valid anagrams. Okay, so this is kind of a fun challenge. It's a hashtag generator. We're going to create a function called generate hashtag that takes in a string as input, and we're going to return the hashtag generated string according to the rules below. So if the generated hashtag string is longer than 140 characters, or the input is an empty string, then the function should return false. So here's some examples. If we passed in JavaScript is awesome, and it doesn't matter the casing, we need to make it so that each word starts with an uppercase. So here, J, I, and A are going to start with an uppercase. Okay. If we passed in hello world with all lowercase, then we would get this back, hash, and then hello with an uppercase H, world with an uppercase W. And then if we pass in more than 140 characters, then it's going to return false. If we pass in an empty string, it's also going to return false. Okay, and that's pretty much what we have here as the constraints. And then hints, you can use the string manipulation methods trim, split. You can split it into an array. You can use join to put it back into a string. You can use the string method char at to get the character at a specific index. You can use string methods to capitalize the first letter of each word. Now, I'm going to give you two solutions, one that uses map and one that uses reduce. Okay, so if you want to try this on your own, you can pause the video and go ahead and do that. So let's go ahead and pass in our string. And first thing I'm going to do here is just run a check to see if the string contains only white space or if it's an empty string. So on the string that's passed in, we can use trim, and that will just trim any extra white space. And we'll say if that is equal to just an empty string, then we want to return false. Okay, next thing I'm going to do is split the string into an array of words. So let's say const words and set that to str, and we're going to trim that, so trim any white space, and then dot split. Now here we could do this, just put a space, and that will split it on the space and separate it, into an array of words. However, we can make this a little safer and put a regular expression in here. So we could do 2 forward slashes, and then in here do a \s plus, and what that's going to do, what this does is it represents one or more white space characters, including spaces, tabs, new line characters, and this allows us to split the string not just on spaces, but on any kind of white space, and it will provide more accurate word separation. So you don't have to do this, but again, it's a little more accurate than passing in just a space. I know some people really don't like regular expressions, but again, they can be really helpful. So that'll give us an array of words. In fact, let's just return that just to make sure. So if we go to the run file, we're passing in hello world, and we get an array of hello world. All right, so that's what we want so far. Now let's return a new array where the first letter of each word is capitalized, and we're going to use map for that. And if you want to pause the video and try that out, you should be able to do that by now. Use map and take the array and return an array where each word is uppercase. So let's call this capitalized, we'll say capitalized words, and set that to, let's take our words array and let's map through that. Let's pass in a function. Okay, actually we don't even need curly braces here. So we're going to pass word into this, and then we'll say word dot char at. So this will get a specific character, and we want to get at the 0 index because we want the first letter, right? Because this is going to give us the word, and then I'm getting the first letter of the word, and I want to uppercase that, so I'm going to use 2 uppercase. Okay, now I want to add on the rest of the word, so I'm going to concatenate word dot slice and put in the 1 index, because that will start at the 1 index, or the second character, and give us the rest of the word, which will be lowercase. Okay, so, and we can check that out if we just return capitalize words, and we run this file. We should now get hello world, but the H and the W should be capitalized. Okay, now let's go under where we define capitalized words, and let's join the words together into a string and prefix it with the hashtag. So I'm going to say const hashtag, and we'll set that to a hashtag. Whoops, that's not a hashtag. And then we're going to concatenate onto that capitalized words, but that's an array, so we want to join and turn it back into a string. And again, we can actually, let's just, instead of just returning hashtag, we want it to be false if the hashtag is more than 140 characters. So what we'll do is we'll return, let's say hashtag dot length, and we're going to use a ternary operator here. We'll say if it's greater than 140, then we want to return false, else then we want to return the hashtag. Okay, so that should do it. Let's go ahead and run this, and we get hashed hello world with the 2 with the H and the W uppercase. And we can run our test. Okay, go ahead and run that, and it passes. All right, now I'm going to give you another solution, so let's comment that one out. And let's say function generate hashtag, pass in a string, and we're going to create a variable of hashtag. So this version is going to be a little more concise. So we're going to set that to str. We're going to split into an array of words. We could use the regular expression in here, but just to switch it up, I'll just use a space. And then we're going to use reduce here to basically add the words together and add the letters together. So in reduce, now we've been passing in arrow functions, but again, just to switch it up, I'll use a regular function here. But if you do this, you need to remember to use the return keyword, or not even just a regular function. If you have curly braces, you need to make sure you return. Because up here, we had an implicit return when we used map because we used an arrow function with no curly braces. So in here, we're going to pass in the accumulator, which is going to be the tag, right? And then pass in each word. And then we're going to return from the reduce the tag plus, actually, let's go down here and put in as the second argument tag, not tag, I'm going to put in the actual hash. Okay, because that's where we want the string to start, right? Now, a lot of times we're using numbers here. Again, you can use reduce for much more than just adding up the amounts in an array. So we can start it at, we're using a string now, and we're starting it at with the hash, with the number sign. And then through each iteration, we want to take the tag, which starts off as the number sign, and we want to then concatenate onto it, let's say word, and we want the first, so char at, we want the first letter in that word, and we want to uppercase it, so to uppercase. All right, then we want to concatenate onto that the rest of the word, so I'll use word, and you could use slice here, but you can also use substring. Okay, I'm just trying to change things up and show you different options, and we're going to pass in a 1 because we want it to start at the 1 index because we want to get the rest of the word. All right, now if I return hashtag and we go to our run file, we get the correct hashtag, but we didn't implement the rules where if it's empty or if it's over 140, that it should return false. So we're going to do that here. Let's say return hashtag, and then we're going to test the length. We're going to say if that length is equal to 1 or the hashtag dot length is greater than 140, then we're going to return false, else we're going to return the hashtag. So if I run this again, we should get the same thing. And if we run the test passes. And I believe the test has, yeah, it has over 140 characters. So it's testing for all that stuff. It's also testing for white space as well. All right, so that's that. Let's move on to the next one. In this challenge, we're going to create a function that will validate IP addresses, IP version 4 addresses. So it will return true if it's valid and false if it's not. An IP version 4 address should consist of 4 octets with values between 0 and 255 inclusive. So if we look at the examples here, 1.2.3.4, that would be true. Something like this would be true. So basically just numbers separated, 4 numbers separated by dots. So 1.2.3 would be false, 5 would be false. This would be false because 456 is over 255. So they have to be, it has to be 0 to 255. And you're not going to have numbers starting with 0 either, like this. So that's what we'll be doing. As far as hints go, you can use the split method to break the string into parts based on the dot character. And you can use every to check if all octets are within the range of 0 to 255. So this is a fairly easy one if you've been following along and you've done past challenges. There's really not much new here. So I would advise you to try it yourself, but of course you don't have to. So let's pass our input in, and let's say const, and we'll call this octets and set that to our input, and we're going to split it into an array based on the dot, or separated by the dot. And just to check that out, we can say return octets, and then we'll go to the run file. So here I'm passing in a valid IP address and an invalid. It doesn't really matter right now. We're just going to check out the array, so you can see that these are now broken up into an array. So now we have to do a couple checks. Let's first make sure that the input string contains exactly 4 octets, and if it doesn't, then return false. So let's say if octets dot length, if that is not equal to 4, then let's return false. Okay, and then otherwise we want to return true if every octet is a number between 0 and 5. So let's do this. Let's say return octets, and I'm going to use every. Okay, and remember, every means that they all have to be true. It's not like some where just one has to be true. So every, pass in octet, and then what we're going to return from this, let's open up some curly braces here, and I want to just create a variable called num, and let's just run this through parse int, which will parse it as an integer, and pass in our octet, and then let's return num. Now I do remember we want to return true if it's between 0 and 55. So I'm going to say return num if it's greater than or equal to 0, and if num is less than or equal to 255, and let's say if octet is equal to num dot to string. Okay, so that should do it. Let's save it. Let's go ahead and run this, and we should see true and false. Yep, so this one is true, that one's false. Let's go ahead and run the test. So we're going to rename that, and let's run it, and it passes. Okay, so pretty simple solution. Again, we're splitting it into an array. Make sure it's 4 length, and then we want to check and make sure that every octet is between 0 and 255. All right, so that's it. Let's move on to the next challenge. Welcome to your next challenge. So this one is called car mileage analysis. So you're given an array of car objects, and each object contains information about the car's make, model, year, and mileage. Your goal is to perform some analysis on the car mileage data using high-order array methods. So implement a function called analyze car mileage, which takes in an array of car objects and performs the following tasks. So you want to calculate the average mileage of all the cars. You want to find the car with the highest mileage, find the car with the lowest mileage, and calculate the total mileage of all cars combined. Okay, so the total, the average, and then the highest and lowest. So the function should return an object containing the calculated values as properties. So here's an object that you can use to test your function. So basically we can pass this in, and then each car object will have the following properties: make, model, year, and mileage. So in our example here, we're passing in this array of objects, passing it into our function, and what we should get back is an object with the average mileage of all the cars, the highest mileage car, which will include all the values, the make, model, etc., the lowest mileage car, and the total mileage of all the cars. Okay, so constraints: the input array cars will contain at most 100 car objects. Each car object's mileage property will be a positive integer, and result should be rounded to 2 decimal places. Okay, so hints: you can use reduce for most of these calculations. So not much of a hint, but yeah, we'll be using reduce quite a bit. So that's it. Let's go ahead and get started. If you want to pause the video now, you can. So we're going to pass in a param of cars. That's going to be the cars object. And the first thing I want to do is get the total mileage. So we'll put that into a variable, and we can get that really easily by using reduce on the cars object and pass in a function. We're going to call the accumulator sum, and then we have each one as a car. And we'll start the sum at 0. And in the function body, all we have to do is take that sum and add on the car, not just the car, because that's an object. We want the car mileage. All right, so hopefully you guys understand how reduce works now. It's going to loop through the cars here, right? And we have a sum that starts at 0. It's going to look at the first one through the first iteration, and it's going to add to the sum of 0 whatever the car mileage is, okay, which at that point will be this. Then it'll go through the second iteration, and it's going to add this car's mileage. Third, it'll add this, and then it ends up with the total sum. So reduce is one of those methods that it confuses a lot of people, including myself. I had trouble understanding it as well, especially when we're not just dealing with numbers. This is pretty straightforward. But it'll become more clear as you use it more. So that gives us the total mileage. If we want to see that, we can return total mileage. And if we run this file here, you can see the total mileage is this right here, 143,300. All right, now to get the average mileage is really easy. So let's say average mileage, and all we have to do is take the total mileage and divide it by the length of the cars array. Okay, so cars.length. And we can return the average mileage, run the file here, and we get 28,660. So total and average. Now we want to get the highest mileage car in the array, and we can use reduce for that. So let's say cars reduce, and then our function that we pass in, the accumulator, I'm going to call it highest, and then we have each car. And the starter value for highest is going to be the first car in the array. So let's say cars at the 0 index. So this is kind of what I was just talking about, where your accumulator is not just a number. In this case, it's an object, right? Now, what we want to do is compare each iteration. We want to compare the current car's mileage to whatever is in highest. And we're going to start with the first car right here, which has this mileage. Then when we go through, we want to compare the next one to the current highest, which would be this one. So this is more than the first one, so this would then take that place of highest, and it would keep doing that through. So let's do that. We're going to say, actually let's open up some parentheses here, and we'll say where the current car dot mileage is greater, if it's greater than the highest dot mileage, then we want that car to take the place of the current highest. Else, then we want to just keep the current highest. I keep forgetting an H in highest. Okay, so hopefully that makes sense. So we can do this pretty much the same thing with lowest. So let's copy that, and we'll just change this, and this to lowest. And we just want to change this from greater than to less than, because we want to check to make sure that the current car mileage, we want to see if it's lower than the lowest. If it is, then we want to replace lowest with that car. If it's not, we're going to keep whatever is already in lowest, starting at the first car. Now all we need to do is return all this stuff. So down here, let's return, remember we want to return an object, and you want to format it just like here. So first the average mileage, then the highest, the lowest, and then the total. Okay, so let's say average mileage. We're going to set that. I'm just going to parse as a float. So we'll run this through parse float, and we'll say average mileage, and I want it to have 2 decimal places. So let's say 2 fixed and then we'll pass in 2 here. All right, now the next thing we want is the highest mileage car, so we can just put that in, and then lowest mileage car, and then the total mileage. So let's save that. Let's go ahead and run this file again, and there we go. So we get the average, the total, and the highest is the Tesla. So if we look at that, that is 50,000. The lowest is the Audi, which has 13,000. Okay, and we can run our test. So terminal, npm test, and there we go, it passes. So my hope with this video, with this challenge, is that those of you that were still a little on the edge with reduce, hopefully that makes it a little bit more clear on how that works. All right, so in this challenge, we're going to create a password validator. So we'll have a function called validate password that takes in a string and validates it based on the following criteria. So the password must be at least 8 characters long. It must contain at least 1 uppercase letter. It must contain at least 1 lowercase letter, and it must contain at least 1 digit. And it will return true if it's valid and false otherwise. So some examples, this would return true. It has an uppercase, lowercase, numbers, and it's 8 characters, at least 8 characters long. This would fail because there's no uppercase. This would fail because it's not long enough. This would fail because it has no digit. Okay, so constraints, the input password can contain any combination of letters and digits. The input password can contain both uppercase and lowercase. As far as hints, you can use the split function to convert the string into an array of characters, and then you can use the sum function to check if at least 1 character meets the condition. So that's the approach we're going to take, is using the sum array method, but there's so many different ways to do this, and if you want to do it a different way, that's absolutely fine. So let's jump into the JavaScript file here, and we'll pass in our password. Okay, and then we're gonna basically just check each thing separately. So let's say is length valid, and for now I'll just set it to just these to an empty string, because I'm going to have these separate variables. So this one will say has uppercase, and then let's say const has lowercase, and let's say const has digit. Okay, so we'll start with is length valid, which is going to be pretty simple. We're just going to say if the password dot length is greater than or equal to 8. Okay, now for the has uppercase, what we're going to do is set it to the password array, and we want to, the password string, but we want to split it into an array. So we're going to split, pass in an empty string here, so that way each character is its own element, array element. And then I'm going to tack onto that the sum method, and then that takes in a function. So we'll say for each character, we want to see if the character, let's say, is equal to character dot to uppercase, and we're going to say and the character is not equal to char dot to lowercase. Okay, so let me just save that and check this out. So we're splitting it into an array of characters, and we're checking to see if some, so basically if any of them are equal to the to uppercase and they're not equal to lowercase. So if one of them are uppercase, then this will return true. In fact, we can return has uppercase, and then let's go to the run file, and we'll run this, and we get true and false. So if we look at this first one here, it does have an uppercase. This one does not. So we get true for the first, false for the second. So that's working. Now, has lowercase is going to be pretty similar. So I'm actually going to just grab this. Okay, and then instead of let's say instead of saying char is equal to char2 uppercase, we're going to say char2 lowercase. And then over here, we're going to say if not equal to char2 uppercase. Okay, so that'll check for lowercase. Now for has digits, let's also take the password and split it into an array. And then we're going to use sum on that as well. And for this, let's pass in a function, and we'll say for each character. And we can say if not is nan. So if is, this stands for is not a number. So if it's not a number, and then that char, let's parse it as an integer and pass in char, and then the base will be 10 base because it's just regular number. And then that should tell us if it has a digit. So now what we can do is just say return is length valid and has uppercase and has lowercase and has digit. And if we wanted to add other conditions on it, we could easily do that as well. So this will only return true if all of these are true. If one of these are false, then it's going to return false. So let's save it, let's run this, and we should get true false again, because this is passing, this is not. If I change this uppercase A to a lowercase a, and I run, then we get false for that as well. So let's run the test. So I'm going to rename that to .test. And we get a pass test. Okay, so like I said, this is pretty scalable. If you wanted to add some other conditions, if you wanted to check for a certain special characters, you could do that as well. So that's it. Let's move on to the next one. All right, so now we're going to do a find missing letter challenge. And I put refactor here because we actually already did this challenge, but we used for loops. In this version, I want to use just high order array methods. So if we look at the examples, we pass in an array of letters. So consecutive letters, A, B, C, D, and then it goes to F. So E is missing, so that's what should be returned. Here we have O, Q, R, S, so P is missing. Here Y is missing, and they can be uppercase or lower, but you want to have them consistent for that array. And use only high order array methods, no for loops allowed. You can use map to get an array of Unicode numbers using char code at, and you can use find to find the missing character code. So that's basically the first solution I'm going to give you. You can also use filter as well as reduce. I'm going to show you another solution where we use filter, but you can also use reduce, and I do have that solution here if you want to look at it, but I'm going to only do the first two. Now, in the last section when we did this, let's just take a quick look at that. Where is it? So we did two solutions. The first one, we had the alphabet inside of a string. We indexed it, so we created a start index. We looped through the array, and we followed along in the alphabet, and we looked at which one was missing and returned that. This one is similar to what we're going to do now, where we look at the character code for each one, and then we basically compare and see if there's a space in between the character codes. If you don't remember the character codes, which are the Unicode numbers, for instance, A is 97, B is 98, C is 99, and so on. So they should be, one after another, but what we're doing is checking to see if the current code minus the start or the previous, if that's greater than 1, then you know that that letter is missing. And then you just change that code back to the letter. So that's essentially what we're going to do. All right, so yeah, let's get started. And if you want to pause the video and try it on your own, you can. So let's pass in an array. And what we're going to do is set a start variable here. And we want to get the first item in the array. And we're going to get the character code. So it's going to be char code at 0. Yes, and I'll just show you real quick. If we were to return start and then go to the run, we're passing in this right here, A, B, C, E. Obviously, D is missing. So if we run this, we're going to get the character code or the Unicode number for A, which is 97. All right, so now we have the start. So let's create a variable called missing char code, and we're going to set that to the array, and we're going to use map here and pass in our function. So for each character, what I want to do is return the character code. So we want to use char code at 0. And now that will give me an array of the character codes. Let's actually return that, and we'll see if I run this code, then we get an array of 97. So that represents A. 98 is B, 99 is C, and then 101 is E. So basically, we just have to look at this and find where the space is, and that's the correct letter that's missing, right? And that's what we did in the second solution in the last section. But now I want to do it without using for loops. So what I'm going to do is chain onto this a dot find. In fact, let's put this on another line, this dot map, and then we'll go on the next line and chain on dot find. And I'm going to pass in a function, and I'm just going to call this current. So basically, when you chain on like this, what I'm going to get passed into find is going to be whatever the result of map, because that came right before it. So I'll get that array of character codes. So now I'm going to basically loop through the character codes, and I'm going to check to see, just like we did in the other solution inside the for loop, we're going to say if current minus start is greater than 1, then we're going to return true, because we know that that is, that's where the missing letter is. And then after that if statement, we just need to set the start. Okay, so we basically want to traverse that. We're going to set that to current. Okay, so that'll change that, and then at the end we're going to return false. Now, as far as what we want to return from the function, let's go down here and return, and we're going to evaluate missing character code, and if it's truthy, then we need to return the letter, not the code. So on the string constructor, we have a method called from char code, and that will do the opposite of char code at. This will give you the code for the character, where this will give you the character for the code. So in here, we're going to pass in missing character code, but we do want to subtract 1 from that because it's going to be the one before it. Else, then this will be empty string. All right, so now if I go and I run that code, now I get D, because D is missing. If we were to put D in here and get rid of C, and I run this, now we get C. Okay, and if we run the test, I've already renamed the file. So if we run npm test, that passes. Now we're going to do something similar, except we're going to use filter. So let's comment that out. Let's say function find missing letter, pass in an array, and let's say const missing char code, and I'll set that to the array, and we're going to filter this time. So filter will take in a function, let's say for each character. Now we know that the first character doesn't matter. It's not going to be the first one, right? So we can check, let's actually pass in up here, because with these functions or these methods, you can also pass in the index. And we know the first index is 0, so let's say if the index is equal to 0, then we're just going to return false for that, because we know that it's not the first one. In fact, we probably should have up here, right before map, we could do dot slice and slice out the first ones. I'm sorry, slice one, and then comment that out too. So we could do that. I mean, it still works without it, but there's no reason to check that first one because we know that's not going to be the missing one. And that's what we're doing here, is just saying if the index is 0, then it's obviously that's not it, so we're going to return false there. So now what I want to do after that is check the previous character code. So let's say const prev char code, and we're going to set that to the array, the current index -1, because we're getting the previous, and then we want the char code at 0. So that'll get the previous one. Now we want the current one. So let's say const current char code. Oops, what am I doing? Current char code, set that to char and then char code at. Okay, so we get the previous and we get the current. So now from this filter, we're going to return the current char code if that minus the previous char code is greater than 1. So that will be either true or false. And remember, filter returns an array. So at the end of this missing char code, we just want to add on a bracket with 0 because we want the first item in that array. Then from the actual function, we're going to return, and let's say missing char code. We're going to evaluate that. If it's truthy, then we want to call string dot from char code, and we're going to pass in here missing char code dot char code at 0, and we want to get the one before that, so we want a -1, else then just an empty string. All right, so we're doing the same thing that we did here. We're just taking a different route by using filter. So let's try to run the file here, and you can see we get C, and if we run our test is still passing. All right, guys, so for the next, I'd say 10 challenges or so, we're going to be using something called recursion. And I know some of you know what that is, some of you don't, some of you have an idea. So a lot of people struggle with recursion, so I'm going to explain it and try to give you pretty simple examples to start off with and then break them down. And understanding at least the basic concept of recursion, I think, is really important, and it's something you'll probably be asked about in job interviews. So in programming terms, recursion is a function that calls itself until a base case or a base condition is true. And in most recursive functions, we break the problem down into smaller instances and then use that solution to solve the original problem. And I'll show you what I mean with an example in a few minutes. Now, when we call a function, it gets added to what we call a call stack. And when it comes to returning values from a recursive function, there's a concept called unwinding. And I'm going to go over those two things in the next lesson because I don't want to throw too much at you at once. Now, one example I like is the analogy of the Russian dolls. So if you don't know what Russian dolls are, it's a set of wooden dolls that decrease in size, and they're placed inside one another. And to get to the smallest doll, you have to open every other doll. And when you get to the smallest, you get a prize or whatever it might be. So that's actually a recursive process. You solve smaller versions of the same problem, right? So when you take that first large doll and you open it, you're going to do it again with a smaller doll and then a smaller doll until you hit a base case of the smallest doll that doesn't have any other doll in it and has a prize. So if you were to do that programmatically, you could use like a for loop if you knew how many dolls there were, but if you don't know the exact amount of iterations, as you often don't in programming, recursion can be a good option. Now, at first glance, recursion and iteration can be very similar. And well, they are very similar. They can be used to solve a lot of the same problems, but there are some differences between them. There's also some pros and cons. Now, as we've established, recursion is a function that calls itself until a base case is met, while iteration is basically just a block of code that's executed a specific amount of times until a certain condition is met. Now, when you use recursion, you're adding functions to the call stack, which can take up memory and affect performance, while iteration doesn't do this because it doesn't have functions getting added to the call stack. So that's a pro for iteration. However, recursion can really minimize your code and can be very elegant and also minimize complex problems. So that's a plus for recursion. I would say both of them have their strengths and weaknesses, and the choice really depends on the problem that you're facing and depends on you as the developer and also having the code readability and efficiency that you're aiming for. So when it comes to which one to use, again, it depends on a lot of different factors, but in general, I'd say use recursion when the problem can be broken down into smaller instances and you have a clear base case. Recursion is often used for problems that have kind of a natural recursive structure, like traversing trees or finding combinations, etc. And then use iteration when you just need to repeat a block of code a specific number of times. Iteration is generally simpler to implement and simpler to understand, but I think if you know recursion, then it's much easier to read, and it's usually a shorter amount of code. So I want to look at an example to kind of drill this down. So we're going to have a function called countdown that's going to take in a number. So let's pass in a num. And we just want to go from this number down to 0, and once it hits 0, we just want to log all done. Okay, so we're going to print out each number until we get to 0 and print all done. So like I said, with recursion, you're going to have a base case, and then usually you'll have a recursive case. So the base case in this case is if the num is less than or equal to 0. Okay, so that's the base case. That's the goal. That's when this is going to end. So when that happens, we're just going to do a console log of all done, exclamation, and we want to then return. And you don't want to forget that return because it'll just it'll just keep going and you'll get a Stack Overflow. So in the recursive case, we're going to console log the num, and we're going to decrease num by 1, and then we're going to call the function recursively, and we're going to pass in num. Okay, now when we go through this, each time this num is going to be smaller that's passed in, right? This num here, because we're decreasing it. So that's what I mean by saying we're going to have a smaller instance of the problem. So in this case, we're talking about that input. That input's going to be smaller. So let's go ahead and save this, and let's go to the run file, and you can see we're passing in 10. So if I run this code, we get 10, and it just prints out until it meets that base case, and then that base case is what stops it, and then it just does what we want, in this case, just console logging all done. Okay, now obviously, if we don't have that base case, and we run this, you'll see it'll just keep going until eventually we're going to have a Stack Overflow at some point. Let's scroll down here. There we go. So you're going to see this right here, maximum call stack size exceeded. All right, so that base case is pretty important. So that's probably the simplest example that I can show you for recursion. Now, like I said, there's a couple other things I want you to understand, and that's the call stack, or at least just how it relates to recursion, and then also something called unwinding. So we're going to look at those in the next video. All right, so now we know the basics of recursion. We know that it's when a function calls itself until a base case is true. Now, after it reaches that base case is when the function starts returning values as it unwinds the recursion. Okay, so as it unwinds, the functions are taken off the call stack. And a stack is a certain data structure that works last in, first out. So basically, the last thing that's pushed on top of the stack is going to be the first thing that's popped off of the stack. And we're going to learn all about stacks later. We're actually going to create our own implementation of a stack using a JavaScript class. But for now, I just want you to understand the very basics of it. And the values that are returned are going to be in the reverse order because of the way that they're put on the stack. Now, before we look at a diagram of how the stack works, let's start a simple example here, a function called sumUpTo. And basically what we want this to do is take in a number, which we'll call n. And the way that I want this to work, you guys don't have to type this out, but let's say we pass 3 in. So we're going to want to go through our function and do 1 plus 2 plus 3. If we put 5 in, then we go plus 4, plus 5, and so on. So that'll be the first time we call the function. Then we want to call 1 plus 2 because we're going to take away 1 from whatever n is, in this case 3. And then for the third time, it'll just be 1, and that's when we want to return 1 from the function. So when it's 1 is going to be our base case. So let's come up here and let's say if, okay, so this is our base case. We're going to say if n is equal to 1, then we want to return 1. Okay, now for the recursive case, we're going to return n, and we're going to add, and this is where we're going to call our function recursively, sumUpTo, and what we want to pass in here is n minus 1, because we want to decrement that. If we just put n, it's going to run forever because n is never going to change, therefore n is never going to be 1. All right, so let's just try this out. If we go to the run file here, you can see that 6 is being passed in. So I'm going to run the code, and we get 21. All right, if I pass in 5, we should get, I believe, 15. Okay, now I'm going to show you another slide here, and this is the visual representation of the stack. So remember, it's last in, first out. So when we first run the function, let's say we pass in 5, that first function call is going to get put on the stack with 5 in it. All right, then it's going to go to run 4, because remember, we're taking 1 away from n when we pass it in. So then at 4, and then 3, 2, 1, until we hit the top where it's 1. Now, after we hit that base case where 1's on the top, it starts to unwind, and the stack starts to take the functions off, and the values are starting to be returned. So what we're going to see returned first is going to be 1, and then the result of this, of 2, of 3. So it's going to be the opposite order. We start with 5, but when we unwind, 1 is going to come first. Now, to show you that in our logs, let's change the function up just a little bit. And I'm just going to paste it in because it's just adding some console logs. It still does the same thing. And if I run this, or not run that, if I run this, we can see the order at which things happen. So we're calling it with 5, right? So it starts there. Then it calls it with 4. Then with 3, then with 2. Now it doesn't return at this point. It's just calling them. And once it reaches the base case, then it starts to return and unwind. And it starts to come off the stack like I showed you in, where is it? In this picture right here. So at this point right here, or at this point rather, when it gets to 1, this is what the stack looks like. In fact, 1 is on the top, but then it starts to unwind. So 1 comes off, then 2, then 3, etc. And it's in the reverse order. So that's why when it returns, so right here, it's going to return 1 first, then it's going to return 3 because that would be, 1 plus 2. And then it would return 6, which would be 1 plus 2 plus 3, 10, 1 plus 2 plus 3 plus 4, 15, 1 plus 2 plus 3 plus 4 plus 5. Okay, so that's what I want to kind of get through to you is the process of how this works. It runs all this until it hits the base case, then it unwinds and returns the values, and the values are returned in the opposite order. And that's really important for our next challenge, because what I want you to do is a reverse string. And we did a reverse string back, I think in Basic Challenges 1, but we used iteration. And I'm going to ask you to do it recursively now, and this is important to understand how unwinding works and how these are returned, and if this actually helps you with the case of a reverse string. All right, so we're going to get into that next. All right, guys, so we know what recursion is. It's a function that will call itself until a base case is met, and once that base case is met is when it starts to unwind and return the values back. So I think a reverse string challenge is the perfect challenge to do at this point. And I'd like you guys, even if you're new to recursion and those were the first 2 videos you've ever watched, I think you might be able to figure it out. Because remember, when it unwinds, it returns the values in the opposite order. And that's what we want. We want to reverse the string. We want the values back in the opposite order. So let's look at some examples. You guys know how this works. We've already done a reverse string. We pass in hello, we should get hello backwards. All right, if we pass in an empty string, we should just get an empty string. So as a base case, you can check if the string is empty and return an empty string if so. You can use recursion to reverse the string by recursively calling the function with the substring starting from the second character and then concatenating the first character at the end. Okay, so you're basically building it up backwards. Remember how unwinding works and how function returns are added to the call stack in the reverse order of the function calls. So let's jump into reverse string recursion.js. And again, pause, try it out. If you don't get it, that's fine. So let's pass in string. And remember, for our base case, what we're going to do is check for an empty string. So let's say if str is equal to an empty string, then we're going to return an empty string. All right, so that's our base case. Now, before we actually run the function, I just want to show you what we get if we return the string and then dot substring, or sub str is the method. And let's pass in a 1. So if we do that and then we go to the run file and we pass in the string of hello, then what we get is ELLO. So what substring is doing is returning whatever's passed in starting at the 1 index, which is E. So it starts from here. We didn't put a second argument, so it'll just return the rest of the string. If I put 3, like 1 and 3, and then I run this, then it'll only give me ELL. But we're going to start it at 1, and then each time we run the function, what we're going to do is pass this in as an argument, and then that will come in as the string. So the first time, it'll have a 1, right? And it'll be ELLO will be the next time that it runs. And then the time, what this will do then is take off the E, then it will take off the L, then the other L, then the O. So it's going to just kind of strip it away. So let's start with that. So I'm going to just say reverse string and pass in the substring that starts at the 1 position. And since it's going to keep calling the function, it's going to keep shrinking. In fact, you know what we'll do is also console log str.substring1 now that we're calling the function again and passing this in. So you can see exactly what that gives us. So let's run the code, and you can see the first time it runs, we get ELLO. Second time we get this, LLO, then LO, and then just O. So all we need to do in addition to that is basically put the first character on the end. So here, after reverse string, not within the function, but after it, let's add on the first character. And we can get that with string char at 0. So now, let's get rid of that console log there. And now let's run this with hello passed in. And there we go. We get hello backwards. Now I could even shorten this up. This is pretty clean and short, but we could make it into an arrow function. Let's say const reverse string and set str. And I'll use an implicit return and just do my base case, which is if string is equal to an empty string, then it's going to return an empty string, else then we're going to call reverse string again with str.substr1, and then after that we're just going to add on the first character. So str.char at and then 0, and that should give me the same thing. There we go. So this is a pretty clean and concise way to reverse a string. Now in the preview here in the README file, if we look under solutions, I put a very long explanation here just because I really want you guys to get the hang of this. I know it's a tough thing to try to kind of wrap your head around. So let's just go over this together. So the reverse string function uses recursion to reverse a string. If the input string is empty, returns an empty string. Otherwise, it calls itself with the substring starting from the second character, and it concatenates the first character of the original string at the end. Okay, so for example, if the input is hello, the function first calls itself with hello. I guess it turns British, and then it concatenates the H at the end. Then it calls itself with LLO and concatenates the E at the end. And it just does that until the entire thing is reversed. Okay, and down here I said let's break it down a little more. When we call reverse string hello, it executes reverse string passing in ELLO and adding the H. Now reverse string, I guess this is kind of the same thing I just did, just numbered. But yeah, so finally the reverse string returns O. Now it starts unwinding the recursion and concatenating the characters to form the reverse string. Because remember, it goes through and does what it needs to until it hits the base case, and then it starts returning values and unwinding, and that's when we actually add the characters back and return the characters back. So the function concatenates the characters in reverse order as it unwinds the recursion, effectively reversing the original string. All right, so hopefully that makes sense. Let's go ahead and run the test real quick. So we're going to rename this to .test. Let's go to our terminal here. And all of our tests pass. All right, that's it. Let's move on to the Fibonacci sequence, which we're also going to be using recursion to solve. All right, guys, so we talked about basic recursion. We know that recursive function calls itself until it reaches a base case, and then after that, it returns values and unwinds. So we're going to move on to a challenge that's pretty popular. Well, I wouldn't say the challenge. I'd say this sequence called the Fibonacci sequence is a popular sequence that's used in different challenges and algorithms. You might be asked about it in an interview in some way or another. So basically what this is, the Fibonacci sequence, is a series of numbers that starts with 0 and 1, and then everything after that is going to be a sum of the previous two numbers. So if we look here, we have 1 is the sum of 1 and 0, 2 is the sum of 1 and 1, 3 is the sum of 2 and 1, 5 is the sum of 3 and 2, 8 is the sum of 5 and 3, and so on. And it just goes on and on. Now what we're going to do as a challenge is, let's see, this is just kind of what I just told you. The instructions are to write a function called Fibonacci that takes in a number and returns the number at that index of the Fibonacci sequence. So what we're going to pass into the function is essentially the index, and we want to get the number at that index. So if we pass in 4, we should get 3. I'm just going to pull this over here so we can see. So the reason we get 3 if we pass in 4 is because if we go by the index, 0 is going to be at the 0 index, 1, 2, 3,
4, so that's the 4 spot or index, and 3 is the value, is the number in there. So if we pass in 6, 0, 1, 2, 3, 4, 5, 6, then we should get 8. Okay, and we're going to use recursion to do this. So for constraints, the input number will always be a positive integer. And for the formula, let me just pull up that these slides again. So there's a specific formula that we can use in our recursive case to get this. And it's Fn equals F, so Fibonacci n equals Fibonacci n minus 1 plus Fibonacci n minus 2. Now, when I say n minus 1, I don't actually mean subtracting. In general, I mean minus 1 in the sequence. So let's say that we have 8, the number 8 as our Fn. So 8 minus 1 on the sequence would be 5. So it's just 1 less. Plus 8 minus 2 on the sequence, which would be 3. So 8 equals 5 plus 3. So this is what we're going to use in the recursive case. So as far as the base case, we know that the first two numbers in the sequence are 0 and 1. So we can say if the number or the index is less than 2, then we can return that number. So if it's less than 2, meaning 0 or 1, so those are the actual values, and those are also the index or the spots. So if it's less than 2, then we're just going to return either 0 or 1. If it's greater than 2, then we run our recursive case because we want to figure out which number is in which spot or which index. So let's jump into Fibonacci.js, and we're going to pass in a num, which is not the actual value, but the spot or the index. And for the base case, we're going to say if that num is less than 2. So basically what we're saying is if it's 0 or 1, then we're going to just return that number. So let's say return num. Now for the recursive case, we simply need to use that formula. So let's say return and then Fibonacci, which is the name of our function, and we can pass in num minus 1. And again, that's because of the formula that I just showed you. So it's going to be whatever the number is here, not the actual index. We're just using the index to find the number. But whatever that number is, minus 1 in the sequence, plus whatever that number is, minus 2 in the sequence. So let's add that to Fibonacci and then num minus 2. And that's it. That should do it. So let's save the file and let's go to the run, and you can see we're passing in 8. So this is, we want to find out what is in that 8 spot. So let's run the code and we get 21. So let's see if that's true. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now this is going to run a lot of times because every time we call Fibonacci, we're going to recursively call it here and here. So what we could do is log. Let's go, we'll just go at the very top here, and let's say console.log, and we'll just put in calculating and then Fibonacci, and then let's put in whatever the num is. So that way we can just see what's going on. So if we run it for, let's run it for something a little smaller. Let's do 4. Okay, so if we run that, you can see it starts off calculating Fibonacci 4, then it does 3, then 2, then 1, then 0. Then it's going to go back to 1. It's going to do 2, 1, 0, and the result that we get is 3. 3 is in the 4 index or the 4 position. All right, so, and if we look at the explanation, let's see, let's go down to the solution here. So we'll just go through this because this kind of really tells you what's going on. So we have our base case, and I know some of this is repetitive, but I'm just trying to drill it into you guys' head. So the base case, which is when the number or the index is less than 2, if that's true, return the number. If it's not, we run the recursive case, which will return the sum of the previous two numbers. This will continue until the number is less than 2, till the base case is met. Now let's look at it step by step. So if we pass in Fibonacci 5, the recursive call 1, the first recursive call is going to call Fibonacci 4, because that's 5 minus 1 in the sequence, plus Fibonacci 3, which is minus 2 in the sequence. Then our recursive call 2 is going to call Fibonacci 4, which calls Fibonacci 3, which is 1 less than 4 in the sequence, plus 2, which is going to be 2 less than 4 in the sequence. Recursive call 3 is going to call Fibonacci 3. Then we hit our base case. Fibonacci 2 returns 1, or Fibonacci 1 returns 1. And then we start the unwinding process. So as the recursive calls return, the function accumulates the results. So remember, it goes in reverse order because now we're coming off the stack, right? We're unwinding. So Fibonacci 1 returns 1, 2 returns 1, 3 returns Fibonacci 2 plus 1, 4 returns 3 plus 2, 5 returns 4 plus 3, and that's where we return 5, which is the fifth number in the Fibonacci sequence. Okay, and we can make it shorter with a one-liner if you wanted to. So you could say const Fibonacci equals, pass in our num arrow function, and then we want to say if the num is greater than 2, then we're going to return the num, else then we're going to say Fibonacci, and then take our num minus 1 and add Fibonacci and num minus 2. So that should do the same thing. So, whoops. So we can comment this out. And if we run our file here, we get 3 at the 4 index. And we can run our test. I already have the test file renamed. So that should pass, good. Now, you saw that even just passing in 4, the function runs quite a few times recursively. So if we put something longer in here, like let's say 40, I don't want to go too high, and we run this, you can see it took us about 2 seconds or so, but this is what we get in the 40 position. So, you know, it starts to increment very rapidly. If we put, like, let's say 43 and run, it's still running right now. I can stop it if I want by doing stop code. I didn't just stop it, it just came back now. So that took, what, 4 or 5 seconds. So the higher the number, obviously, you know, the more resources it uses and the longer it's going to take. But this is a common challenge or problem or question that you're going to get in job interviews. So just memorizing this, just how the formula works with recursion, is beneficial. So I would suggest doing that, especially if you're in the process of going to job interviews and you're going through whiteboard challenges and things like that. Okay, so now we're going to use recursion to get the factorial of a number. Now, if you don't know what factorial is, it's the product of an integer and all of the integers below it. And it's denoted as 5, or in this case, we want the factorial of 5, so it's 5 exclamation. So it's whatever the number you want to get the factorial of. So down here we have, for example, the factorial of 0 and 1 is going to be 1. Anything above that is going to be the integer, the product of the integer and everything below it. So for 2 factorial, we would get 2 times 1, which is 2. For 3 factorial, we would do 3 times 2 times 1, which is 6. 4 factorial would be 4 times 3 times 2 times 1, which is 24. And 5 factorial would be 5 times 4, 3, 2, 1, which would be 120. And you just keep going from there. Now, the whole concept of factorial and the calculation is extremely simple. You could do this in a for loop, no problem. But when you're using recursion, it's a little more complicated. And not even the code. The code is simple. What I think is complicated is just understanding how this works recursively and how it uses unwinding and uses the return values of intermediate calculations. That's what I think is tough about this. But factorials are a great way to kind of learn how recursion works. They're also common in interview questions and things like that. So this is good to know. So for the challenge, you can see this is just what I just explained to you. For the challenge, we want to write a function called factorial that takes in a number and returns the factorial of that number. And we want to use recursion. We don't want to use any for loops or anything like that. So for example, if we passed in 5, then we would get 120, which we get by what I just showed you. We pass in 10, and you can see it increments very, very quickly. So that would be the factorial of 10. Now, the factorial of 0 or 1 is always going to be 1. So we already have our base case, right? We want to check if the number is 0 or 1. Now, otherwise, if it's not 0 or 1, then you can use recursion to calculate the factorial by multiplying the current number by the factorial of the previous number until you hit the base case. Okay, so that's key right there. You want to multiply the current number by the factorial of the previous number. That's your recursion case. So let's jump into factorial.js. And after I show you the solution, I'm going to just, I want to drill into it a little more. So the solution is actually pretty simple. We're going to pass in a number, and then we know our base case already. We're going to check to see if that number is 0 or 1. So if the number is equal to 0, or if that number is equal to 1, then we want to return 1 because that's the factorial of 0 and 1. Now, for the recursive case, all we have to do is return, like I said, the number times the factorial of the number previous to that. So let's say factorial, and then we want to pass in here num, which is the current, and then minus 1, because we want the one previous to that. And that's it. That will work. So if I were to go to my run file, we got factorial 5 here. We run that, we get 120. Now, that's simple, right? The very simple function. Our recursive case is one line. Now, the reason this works, let's take a look at this right here. So this is the solution right here. So when we go through our first recursive case, we do factorial 5 because that's the number we passed in. So it does 5 times factorial 4. Then for the second recursive case, it does factorial 4, which is 4 times factorial 3. Then factorial 3, 3 times factorial 2. Factorial 2 equals 2 times factorial 1. Then we get to factorial 1, and that's our base case. Now it goes into the unwinding process and starts from the base case and then goes up, right? So it bubbles up. Factorial 2 is equal to 2 times 1 equals 2. Factorial 3 is going to be 3 times whatever the return value from the one previous to that, which in this case is 2, right? So 3 times 2 is 6. Then the next one, factorial 4, is going to be equal to 4 times whatever the return value from the one previous to that, which is 6. 4 times 6 equals 24. And then finally, factorial 5 is going to equal 5 times the return value from the one previous, which is 24. 5 times 24 is 120. So this is what I think is the hard part of this whole thing. Just getting the factorial is easy. You could write a simple for loop for that. But to use recursion to do it, you have to kind of understand this process. And again, the definition of recursion includes breaking it down into smaller pieces to solve the main problem. In this case, this is the main problem, factorial 5. That's what we want to figure out. And then it breaks it down into smaller instances until it hits the base case, and then it bubbles up, it unwinds, we get our intermediate return values up until we get the actual solution to this problem, which is 120. So now the last thing I want to do is just run our tests, make sure that works. So let's rename this to factorial.test and run npm test, and we get a pass. Okay, and we tested factorial 0, 5, and 10. All right, cool. So, and if you don't completely understand recursion yet, that's fine. You just follow along with the next few challenges and it'll start to become more clear. Okay, so for this challenge, we're going to create a function called power that takes in a base and an exponent and returns the result of raising the base to the power of that exponent. So if we look at our examples here, if we pass in 2 and 3, we want to get the result of 2 to the power of 3, which would be 2 times 2 times 2, which would be 8. Okay, 5 to the power of 2 would be 25, 3 to the power of 4 would be 81. So as far as constraints, the base and exponent will always be positive integers. And as far as the base case goes, remember that when you take any number raised to the power of 0, it's always going to be 1. So keep that in mind. That should give you a giant hint as to what your base case should be. And then think about how you can break down the problem into smaller parts using recursion. So how do you get from, power of 2, 2 to the power of 3 down to the power of 0, which will be 1, which is your base case? How do you get from here to your base case? So if you want to try it on your own, you can. I'm going to jump into power.js, and we're going to pass in here the base and the exponent. And remember, any number to the power of 0 is going to be 1, so that's going to be our base case. Let's say if the exponent is equal to 0, then we want to return 1. Now, what we want to return for the recursive case is going to be, basically we're going to break it into smaller parts. So what we'll do is we'll take the base and we'll multiply it by power. So we're going to call our function recursively and pass in the same base, right? But we're going to subtract the exponent by 1. So let's say exponent minus 1 until it gets to 0, until it gets to the base case. So let's see what happens if we go to our run file. So power run, and I'm going to do 2, 5 here. So I'm saying 2 to the power of 5, and we're going to run this, and we get 32, which is correct. Now, just to kind of illustrate what happened there, if we go to solutions and we go to the explanation. So the base case of the recursion is when the exponent is 0. In this case, we return 1 because any number raised to the power of 0 is 1. For any other exponent, we're breaking the problem into smaller parts. So to raise the base to the power of the exponent, we can start by multiplying the base by the result of the function called with the same base, but the exponent decremented by 1. This recursive step forms the essence of the algorithm as it continually reduces the problem until it reaches the base case. So if we look at what we just did, power, we pass in 2 for the base, 5 for the exponent. This is exactly what happens. So the base is 2, the exponent is 5. The exponent is not equal to 0, so the base case is skipped. Then we go down to return 2 times the power of 2, or 2 to the power of 4, right? Because we decremented from the exponent, so that's going to be 4. So now the exponent is 4. Then we're going to call, because it's still not the base case, so it's going to call power 2, 3, right? And these are getting added on to the stack as they get called. So exponent is now 3. Then we go to 2 times power 2, 2, exponent 2, return 2 times power 2 to 1, exponent 1, return 2 power 2 to 0, and this is where we hit our base case. So now the exponent is 0, so we return our 1. All right, so we started at 2, 5, and we broke it into smaller parts until we hit our base case. Now we start unwinding with the return values. So, and we start at the base and it bubbles up. Remember, it goes the opposite way. So return 1 times 2 equals 2. What we're doing here is multiplying the base, which is 2, with the returned value from each recursive call, starting from the deepest recursion level, which is the base case. All right, so 1 times 2 equals 2. So this is the return. Now we're going to multiply the return value with the base, which is going to be 4. Then we're going to multiply that return value by the base, which is 8. That return value by the base, 16. That return value by the base, 32. And that's how we get our answer. Okay, so I'm trying to take you through every single little step to make it more clear on how recursion works. And if you're confused, don't feel like you're stupid or anything like that. Recursion is a really tough thing to learn, and it's a really, really tough thing to teach. To try to show you what's going on is really tough compared to a lot of other topics. All right, so let's run our test and make sure that everything is good. So we have power, let's rename that to .test. And then we'll go ahead and run npm test. And that passes. All right, let's move on to the next one. Okay, so this challenge is actually easier than the previous few that we've done. And the reason for that is I want those of you that are kind of struggling with this, that you've been following along, but you haven't been able to get any of the recursion challenges on your own, or maybe not even come close. I want you to be able to do this. So I set it up in an easy way where the hints pretty much tell you what to do. And still, don't get discouraged if you can't do it. So the challenge is to sum up the values in an array. And obviously, if you were in a practical programming situation with JavaScript, you could simply use reduce. But this is a challenge. You want to use recursion to sum up the array. And there's more than one way to do this with recursion. But basically, we want to pass in, so if we pass in an array with 1 through 5, it should return 15, which is obviously the sum of all those numbers. And it can include negative numbers as well. Now, for the hints, these are pretty big hints. So the base case is going to be if the array is empty, then return 0, right? The recursive case is going to be where you sum the first element in the array and the sum of the rest of the array. Okay, so think about that. And I want you to pause it and try it out. Now, if you can't get it, that's fine. I'm going to do it, and then I'm going to go through it. And the solution, I pretty much, laid it out step by step as to what happens. So let's go to the JS file and array sum. We're going to pass in an array, and then the base case is if the length is 0. So let's say if the array dot length is equal to 0, then we want to return 0. So that's our base case. Now what I want to return from this is going to be the first element in the array that's passed in plus the sum of the rest of the array. So this is where we can call our function recursively. So we can say plus array sum, but we don't want to pass in just array. We don't want the first one. Okay, we don't want the first item being passed in. So we're going to use .slice here, and we're going to say we want from the index 1 and then the rest of it. Okay, we don't want the first item. And that's it. So if I save it and then I go to my run file, which we're passing in 1 through 5, run that, we get 15. And if we test it out, let's rename this to .test. And if we run npm test, okay, that works. Now let's go to the solution here and the explanation. So the array sum function uses the recursive approach. The base case is if there's nothing in the array, return 0. And then in the recursive case, the function adds the first element of the array, which is array 0, to the sum of the rest of the array. So we cut off the first item in the array here, and that recursion continues until the array becomes empty and the base case is reached. So this is a breakdown of what happens. So basically, when we pass in 1, 2, 3, 4, 5, it returns 1, which is the first item in the array, plus the array sum of the rest of the items. So 2 plus 3 plus 4 plus 5. Okay, then it calls it again with 2, 3, 4, 5, and then the first item in this array is going to be 2 plus the rest of the array, which is 3, 4, 5. Gets passed in again as 3, 4, 5, returns 3, array sum, and then 4, 5 are the only two that's left, and then 4, 5 returns 4 plus array sum 5, and then array sum 5 returns 5 plus array sum, and there's nothing there. And then we hit the base case, right, because there's nothing left in the array. At this point, the recursive calls start unwinding, and the values are then added up. So then we have 5 plus 0 equals 5. And the reason we're getting this 5 is because array sum 5, there's nothing else to add to, so it's just 5. Then the next one is going to be 4 plus 5 equals 9, because remember, it's going to be the first value plus the rest of the array. So 4 plus the rest of the array is 9. Here we have 3 plus 9 equals 12, because 3 is the first item, and then we're adding that to the rest of the array. 4 plus 5 is 9, so 3 plus 9 is 12. Here we have 2 plus 12 equals 14, so that would be 2 plus 14, 12, 3 plus 4 plus 5 would be 14, and then finally we have 1 plus 14 equals 15, so 1 plus all of these added up together is 14, so that would be 15, and that's what we get for our final result. Okay, so I think it's important to map out exactly what happens through recursion and through the unwinding process where you're getting your return values back. All right, so hopefully that helps you out in understanding all of this. So let's move on to the next one. So in this challenge, we're going to create a function called number range, and basically we want to pass in a start num and an end num, and we want to return an array of numbers from that start num to that end num. So if we come down here to the examples, if we pass in 1 as the start and 5 as the end, then it should return an array with 1, 2, 3, 4, 5. If we pass in a 3 and a 10, then it should be an array from 3 to 10. If we just pass in, for instance, 7 to 7, just one number, then it should return that one number in an array. So that should be our base case, is to test to see if the start num is the end num. And then you can construct the array by first calling number range on a smaller range and then adding it to the end num array. So let's jump into, number range JS, and we're going to pass in here a start num and an end num. And like I said, for the base case, what we'll do is check to see if the start num is equal to the end num. So basically we want to work our way to that. And if that's true, then we're just going to return whatever the start num is inside of an array. Now for the recursive case, let's create a variable called numbers, and we're going to set that to the number range function. So we're going to call this function recursively, and we'll pass in our start num, but we want to pass in one less than the end num. Okay, so every time this function is called, it will be one less for that end num. So the first time it's called, let's say, let's go to the run file here, and you can see we're passing in 1 and 5. So what would happen is it would then call, you don't have to type this, but it would then call number range 1 and 4. Then it would go through again and call number range 1, 3, and so on. Now, that will shrink it down until ultimately it gets to number range 1, 1. And that's our base case. That's when it will stop. And then when it starts to unwind, that's when the return values will get added. And this will go first. It will add, the array will look like this, 1. And then it will go to 1, 2. Then it will go to 1, 2, 3. 1, 2, 3, 4. And finally 1, 2, 3, 4, 5. And that's what we want. Okay, so the only thing we have to do here is add the nnum onto the array. So we'll just push that on. So we're going to add nnum, and then we just return numbers. All right, so it's going to start off by shrinking the range, and then when it unwinds, it's going to return, all those return values will get added to the array because we're pushing them on here. Okay, so let's save that. Let's go to the run file and let's run the code, and there we go. We get 1, 2, 3, 4, 5. And I have all that explained in the solution here. So if you want to take a look here, it's just the basic explanation here, but then we have the steps that I just kind of went through. It's called start num1 is not equal to end num5. We move to the else block, or I should say the recursive block, because there is no else. You could put an else. And then we make a recursive call to numRange1,4, which will call numRange1,3, and so on until it meets the base case. The base case is reached when it's start num1. Then, when the unwinding begins, the result of numRange1,2 will be the array 1 and 2, and then it will return the result of number range 1,3, which will be 1, 2, 3, all the way up to 1, 5, which will be 1, 2, 3, 4, 5. So me writing these steps out, I really hope helps you guys understand how this works, that the function gets called recursively until it meets its base case, and then it unwinds and it uses those return values to give us our result. So the last thing to do here is to do our test. So let's rename this to .test. And let's come over here and run npm run test. And it passes. All right, guys, so this challenge is going to be a little bit different in the way that we set up our function, because in the past all of our recursive functions had a clear base case at the beginning and then a recursive case. This is going to be a little different. So what we're doing is pretty simple. We're flattening an array. So basically, if we pass in something like this where we have an array and that has subarrays inside of it, then it should flatten it and just return the items in a single array at the same level. All right, so constraints: the input array can contain nested arrays of any depth, and it can contain any number of nested arrays. And if the current element is an array, you can recursively call the flatten array function on that element to flatten it further. So the way we use our recursive function is going to be a little different. We're actually going to use it within a loop. So there are cases where you'll use iteration and then you'll use a recursive function inside of the loop. So let's jump into our JavaScript file, and we're going to pass in an array. That's the array we want to flatten. And then we're going to just create a variable here called result that's going to be the flattened array. And we're just going to set it to an empty array first. Then we're going to loop through. We're going to use a for of loop to loop through the array that's passed in. So let's call each item of the array that's passed in. And then we're going to check to see if the item is an array. Because remember, let's open up the run here. What we're passing in is an array like this. And it could be just a single item like 1, 2, 3, or it could be an array. So we want to test for that. And we can do that by using array dot and then is array. Okay, so this method will pass in the single item, which could be just a number, or it might be an array. So we want to test for that. I don't know why I forgot the if. Whoops. So we want to say if that is an array, then we want to take our result, which we defined up above, and we're going to concatenate using the concat method our flatten array function. And we just want to pass the item in there. Okay, so you can see the way we're using our recursive function is different than we have been in past challenges. Now else, if it's not an array, then we just want to push it on to the result. So say result.push and pass in our item. And then all we have to do is after the for loop, we're going to return the result array, which should be the flattened array. So we'll save that, and you can see that the structure of this is very different than the other challenges. In terms of the base case, it's a little weird because the base case is implicitly handled within the loop structure. As the loop iterates through each element of the input array, the recursion eventually reaches the point where there's no more elements left to process. All right, so when the input array is empty, the loop won't execute, and the function will directly return the empty result array. So let's try this out by going to the run file here. Let's run our code, and we get an array with no subarrays, just 1 through 10. Okay, and we can run our test file, which has a few different tests. Change that. And that passes. Okay, so I just wanted to kind of show you a different way of a different type of challenge where we used recursion in a different way. Okay, so this challenge is called permutations. So we're going to write a function called permutations that takes in a string as a parameter and returns an array of all possible permutations of the characters in the string. So basically all the combinations. So for instance, if we pass in ABC, then we should get an array with ABC, ACB, BAC, BCA, CAB, CBA. So all the different combinations of that string. So constraints, the input string will only contain lowercase letters. The input string will not contain any duplicate characters. So hints, think about how you can break down the problem of generating permutations using recursion. That's pretty obvious. You can use a for loop to iterate over the characters in the string and another for loop to iterate over the sub-permutations. The base case will be when the string is empty, and you can get the permutations by calling the permutations function recursively. Okay, so there's kind of a lot to this one. So I'll just try to explain it as I go along. So if we jump into the function here, it's going to get passed in a string, such as ABC. Actually, let's see what's in the run file. Yeah, we're passing in ABC in the run file. So like we did with the flatten array challenge, we're going to create a result, which is going to be an array. And we can create our base case, which is going to be if the string is empty. So, or the string length is 0. So let's say str.length, if that is equal to 0, then we want to take the result array and we want to push onto it an empty string. And then we want to return the result. All right, so that'll be our base case. Now we're going to loop through each character in the string. So let's say for, and I'm just going to do a regular for loop here. So let I equals 0. And then let's say as long as I is less than the string that's passed in, length, increment. Now, the way we're going to do this is we're going to get the first character of the string, right? So if we pass in ABC, the first time we call our function, it's going to take A. And then what we want to do is process the sub-permutations of the rest of the string. So in this case, it would be BC and CB. And then we'll add A to those sub-permutations. Then we'll go through again, and we'll do the same with B. We'll take B, and then we'll do the sub-permutations of A and C, which would be AC and CA. Then we'll add B to it. All right, so we'll end up, and then we'll do the same with C. So we'll end up with something like this. So we process A, add the sub-permutations on, process B, add those on, and then C. So that's basically how this is going to work. So let's get the first character. Let's say const first char, and we can get that by using an index. So the index of I, because we're in the loop. And then we also want to get the rest of the string. So let's say const rest of string, and we can get that with string dot slice So we'll get 0 to I, and then we're going to add string dot slice, and then I plus 1. So that'll give us the rest of the string. So the first time we go through, it'll get A as the first character, and then BC will be in the rest of string. Now we want to get the sub permutations, and this is where we can use recursion. So we're going to say const sub permutations and set that to our permutations function. And what we want to pass in is the rest of string, because remember, we're going to first process, we're going to take the first character, first time will be A, and then we're going to do the permutations on the rest of it, which in this case would be B and C. Okay, and there's two permutations with B and C. It's BC and CB. All right, now what we want to do is loop through, within this loop, we're going to loop through the sub permutations. So let's say for, and of course we want to use a different variable here. Let's use J and say equals 0, and then we want to say as long as J is less than, not I, J is less than the length of the sub permutations. So if it's less than the length, and then we want to increment J, and then within the inner loop, we're going to push the first character and the permutation to the result. So let's say result dot push, and we want to take the first char, and then we want to concatenate sub permutations, and then whatever J is at the time. And that's it. Now outside of the outer for loop, we're just going to return the result, and that should have all of the permutations. So let's save that. Let's try the run file. We'll run that, and there we go. So again, it goes through, it loops through the array, which is ABC. It takes the first character, which the first time around will be A, and puts it in a variable, and then processes the rest of the string. It passes the rest of the string back into permutations, and it gets those permutations. Then it moves to the next character, B, and processes the permutations of A and C. And then it adds B to the beginning. That's why we get BAC and then BCA. Then it moves to C, and it gets the permutations of A and B. And then it adds it to C, CAB, and then CBA. So I know this is definitely confusing. This is probably the most difficult one of the functions that we've created, but hopefully you can kind of grasp what's going on here and see another way that recursion can be used. So now let's just run the test. And the test is just using ABC and dog, D-O-G. But, so that should pass no problem. And there we go. All right, so this will be the last video in the recursion section, but we will be using recursion later on in other sections as well. All right, so let's move on now to talking about complexity. All right, guys, so we've done quite a few challenges so far, and I want to take a little break from that and talk about some computer science topics like time complexity, space complexity, runtime, big O notation. This is stuff that you may be asked about in technical interviews, and it's stuff that I think every programmer should know at least the basics of, and it ties into everything we're doing in this course. Now, don't get overwhelmed if you don't understand some of this right away. That's okay. It is a lot to take in. Now, when we talk about runtime pertains to how long it takes for a function to run. We can measure this in seconds, milliseconds, or any other unit of time. When we talk about time complexity, we're talking about how the runtime scales as the input grows. So when we analyze the time complexity of a function, we're essentially trying to understand how the function's runtime will change and increase as the input size increases. And this provides us with insight into how efficient the function or the algorithm is. So if we pass in one number as the input, what's the increase in runtime if we pass in 100 numbers or 1,000 or 1,000,000 numbers. That's what time complexity is. And we measure in time complexity, which is more abstract, over straight runtime, because runtime can vary largely based on a lot of factors like hardware, system load, how the function was written, etc. Now, time complexity is often expressed in terms of big O notation, and we're going to get into that in the next video. In this video, I just want to talk about the four main types of time complexity. There are others as well, but these are the four most common that you're going to run into. So what I want to do is right now just give you a very, very brief overview of each type, and then we're going to have separate videos on each type where I can give you some examples and talk about it a little more. Now, the chart on the right shows how the runtime increases as the input data size increases. All right, and the first time complexity that we're going to look at is constant. So constant time is when the runtime is always the same, no matter how big the input is. So if the input is, let's say, one number or 1,000,000 numbers, the runtime will be around the same. It doesn't matter. If we look at the chart, you can see that the green line, the constant line, is flat. So the runtime is constant. It doesn't matter how big the input is. Now, this is the most efficient type of time complexity. However, achieving constant time complexity is not usually possible just due to the nature of computation, and it's typically associated with very simple operations or data structures that can be accessed directly in a single step. So the next time complexity is linear, and this is when the runtime scales linearly as the input grows. So if the input is one number, the runtime will be one step. If the input is 1,000,000 numbers, the runtime will be 1,000,000 steps. That's why the orange line is at a 45-degree angle in the chart. As the input grows, the runtime grows at the same rate. And I would say that linear is the most common type of complexity that we'll see. It probably accounts for about 95% or more of the challenges that we've done in this course. And as far as efficiency, it's fairly efficient as it's a one-to-one growth. It's more efficient than quadratic time complexity, which is what we're going to talk about next. So quadratic time is when the runtime scales quadratically as the input grows, and quadratic is a fancy adjective used to describe squaring or raising to the power of 2. So if the input size is 1, the runtime will be 1 step. If the input size is 10, the runtime will be 100 steps. And if the input size is 100, then the runtime will be 10,000 steps, and so on. If we look at the chart, you can see that it's not very efficient. The quadratic line is a curve that goes almost straight up. So it grows at a much faster rate compared to linear growth. So this isn't very efficient. And if possible, you want to avoid quadratic time complexity, but obviously it depends on what you're doing. It might not be possible. So next we have logarithmic time complexity, which scales logarithmically as the input grows. And as the input size increases, the time taken by the algorithm increases, but not as fast as linear or quadratic. You can see that the blue line here, it does increase, but at a very slow rate, and at some point it almost looks like it's just a straight line, like it's constant. Now, mathematically, a logarithm is the inverse function or the opposite of an exponent. So if we have 2 to the power of 3, the logarithm is 3. If we have 2 to the power of 4, the logarithm is 4, and so on. All right, so those are the four main types of time complexity that we're going to talk about, and I'm going to go into each one in more detail. But before we do that, I want to talk about big O notation, and that's what we're going to look at in the next video. Okay, so we talked about time complexity in the last lesson, and time complexity represents how the runtime of a function changes as the input grows. Now, big O notation is a way to describe the time complexity of a function or of an algorithm. More specifically, it's a way to describe the upper bound or worst case scenario of how the runtime or space requirements of an algorithm grow in relation to the size of its input. And big O uses mathematical expressions to represent the relationship between the input size, often denoted as n, and the algorithm's performance. The O in big O notation stands for order of, and it indicates the rate at which the algorithm's performance grows relative to the input size, which we talked about in the last lesson. Now, I'm not going to go deep into the math here. I just want you to be able to recognize the different types of time complexities and how to describe them using big O notation. Now, these are the four complexities that we talked about in the last video: constant, linear, quadratic, and logarithmic. So as far as constant time goes, this is how we denote constant in big O. It's this O, and then in parentheses we have 1. So when you see this, it's pronounced as O of 1. So that represents constant time. For linear time, we have this ON, which is pronounced O of N. And you can see over here in the chart, we have ON for linear, and for constant, O1 or O of 1. You can also say big O of 1. There's a lot of ways to say it. For a quadratic, this represents quadratic time in big O. So this is pronounced O of N squared. And over here you can see for a quadratic, O of N squared, it might also look like this. And then logarithmic is going to be this O and then log N. This is pronounced O of log N. All right, and then there's others as well. There's exponential time complexity. There's also factorial time complexity. There's others as well, but they're not that common, and I only have so much time in this course and so much that I want to go over. So we're going to focus on these four. So just know that when you see O of 1, that means it's constant. O of N means it's linear. O of N squared is quadratic, and O of log N is logarithmic. Okay, now just about every operation in your code has some kind of time complexity. It's not just entire functions or algorithms. Time complexity refers to how the execution time of an operation scales as the size of the data that it operates on increases. And this concept doesn't only apply to complete functions with input parameters, but also to individual actions that you can perform on data structures such as arrays. So what I want to do is go over the different operations of an array and their time complexities represented in big O notation. So first we have accessing elements by index. So if you have an array and you want to access a specific index, that's going to be O of 1 or constant time. And the reason for that is because arrays use memory blocks that allow direct access to elements. So no matter how big that array is, it'll always take the same amount of time to access an element by its index. And that the input in this case, it doesn't have to be just a function argument. In this case, the input is the actual index. So next we have insertion and deletion at the end of an array. So if you add or remove elements at the end of an array, it's usually a constant time operation, which is O of 1, because there's no need to shift or reorganize other elements. You don't need to touch anything else. So in this case, the input is the array size and the specific element being inserted or deleted. Now, when it comes to insertion and deletion at the beginning of an array, it's a little different because it requires the shifting of existing elements to make space for the new element. So that's linear. So that's actually going to be O of N. Same thing with insertion or deletion in the middle. You're going to have to shift things around and make room. So that's also linear, and that's going to be O of N. Now, when you search for an element, you're going to have to go through the array one by one. So that's linear as well. That's going to be O of N. Now, there is something called a binary search that you can do on sorted arrays, which actually is O of log N and has a logarithmic time complexity. And this is very efficient. We'll talk about binary search later, but you basically split the sorted array in half and eliminate the half that doesn't include the element you're looking for. Then you split it in half again and eliminate, and you keep doing that until you find the element, and that's very efficient. But again, the array has to be sorted for that, and we'll get into sorting later. We'll get into binary search, binary trees, all that stuff. But what I really want you to understand from this video is just how to express each time complexity in big O notation. Okay, so we looked at the different types of time complexities. Now what I want to do is basically have a video for each of the 4 ones that we discussed and give you an example and talk about it a little more to get you more familiar with these different complexities. So the first one we're going to look at is constant time, and in big O notation this is O of 1. Okay, and constant time means that the time required to complete a function is going to be the same regardless of the size of the input data set. So if we have a function, no matter the size of the input, it's going to have the same runtime. So I'll give you a very simple example. Let's say function access element. You can, follow along with me if you want. And we're going to pass in an array, and we're simply going to get the element at a specific index that we pass in. So all we're going to do is return the element that's at that index. So very, very simple. Now the reason that this is constant is because it doesn't matter if we put an array with just 1 or 2 items, or if we put an array with 1,000 items. It's not doing any operations, like it's not iterating through it or shifting things around. All it's doing is simply returning an element at the index that we provided. So it's going to be the same regardless of how big that array is. Now just to kind of prove this to you, let's create an array. I'm going to call it array 1, and we'll set that to just 5 items, okay, 5 numbers. And then I want to log the time that this takes to run. So one way to do that is to use console.time, if you don't know about that, and that's in Node.js or if you're in the browser in the front end. And we want to pass in a string here. I'm going to just say access element 1. And then we want to end that timer. So right here, I'm going to say console.time end. And we're going to pass in the same string, access element 1. And then in between that is where I want to run my function, but I'm going to put it in a console log. So let's say access element. We want to pass in array 1, and I'm going to get the element at the 1 index. So when I run this, and I'm going to use the code runner extension, it's going to give me the element, which is 2, that's at the 1 index, and you can see it took 5 milliseconds. That's actually kind of long, and this is going to change every time you run it, but it'll be around the same. I mean, now it's 2 milliseconds, so it's a couple milliseconds difference. And there's so much that goes into this, like that affects this, from your computer to what you have in it, to your operating system, to what other programs are running. There's so many factors, so you're never going to get the same exact thing that I get. But it should stay around the same regardless of how big this array is. So to prove that, I'm going to create another array, let's say array 2. And what I want to do is create an array that has 1,000 items in it, or let's do 10,000 items in it. So we can do that by saying array.from, which will create an array from an iterable item, and we're going to pass in here an object and say length 10,000, and then we pass in a callback function. And we're going to pass in 2 things here, a placeholder, which we're just going to use an underscore, and then index. And then all I'm going to do is increment that index by 1. So it should give us 1,000 numbers in an array. And just to show you that, let's do console log array 2. And if I run this, you can see it starts at 1, and down here it goes to 100, but it says 9,900 more items. So this is a pretty large array. So now what I want to do is basically this same thing. Let's paste that in here. Let's say array element 2, and let's pass in array 2, and we'll get the index at 1. Or let's get the index at, we'll say 100. Okay, so now let's run the code, and we get access element 1, 2 milliseconds, access element 2, 0.65 milliseconds. So it actually took a shorter amount of time for the 1,000 elements. And it might be the other way around if we run it again. Well, actually, it seems like the second one is just much shorter. But this shows you that even though we have 1,000 numbers or elements in array 2, it doesn't take any longer. In fact, it's taking a shorter amount of time than the one with just 5 items in it. So that's an example of O of 1 or constant time. All right, in the last video, we looked at an example of constant time where we passed in an array, one with 5 items and one with, 10,000. And it took not only the same amount of time, not the same amount of time, but the one with 10,000 items actually took a shorter amount of time. So that just shows that the size of the input doesn't matter. Now, there's not too many times that you're going to have that type of complexity because it's only going to happen if it's a very, very simple operation like what we just did, just accessing an index. So looking at the challenges that we've done and the functions that we've written, I would say at least 95% of them have been linear, and that's what we're going to look at now. So linear time means that the time required to complete a function is directly proportional to the size of the input data set. Okay, so let's go ahead and create a function here, and we're going to call it SumArray. I think we even did this as a challenge. And we're going to pass in an array. And let's create a variable here. We'll say let sum, and we're going to set that to 0 to start with. And then we're going to loop through. Let's say let I equals 0. And then we're going to say as long as I is less than the array dot length. And then we want to increment I. I'm going to increment I, and then all I'm going to do is take that sum variable and we're going to add onto it, let's say plus equals array I, so whatever is in the current index in that iteration. And then outside the for loop, we're just going to return sum. So this is an example of linear time. So the bigger the input, in this case, this array, the longer this is going to take because the more iterations, the more operations it's going to be doing on the input. So obviously that's going to take longer. So hopefully you can kind of see the difference already before we even test this, the difference between this and this. Right here, we're not really doing anything except accessing an element by the index. Here, we're processing through the array that's passed in, the input. Now let's do the same thing that we did with the constant. So I'm going to create an array, we'll call it array 1, and we'll just have 5 items in it. And then let's do a console.time. Let's call this SumArray1. Okay, and then we'll have the time end. And between that is where we want to call our function. So let's do a console log, and we'll say SumArray, and we're going to pass in array1. All right, so if we run this, we get 15, and you can see the time it took was 3.35 milliseconds. Now I'm going to let's copy these 3 lines, and let's say SumArray2, pass in array2, which we're going to create right now. So array 2, and we're going to create an array. So say array from, pass in an object with a length, and I'm going to set that length to 1,000,000. So 1, 2, 3, 4, 5, 6. So set that to 1,000,000, and then we have our function that's going to take in a placeholder and index, and we're just going to add 1 to index. All right, so that's going to be an array with 1,000,000 items that we're passing in to SumArray. So let's try this out. We'll run. And you can see we get SumArray1 2.343 milliseconds. SumArray2 is 8.986 milliseconds, which is still pretty fast. But you can see there's definitely a difference there. If I run it again, now we get 4. Okay, so that went a little faster. Now let's add another 0 here. So we're going to make it 10 million. So we're increasing that quite a bit. So we'll run our code, and now look, now we get 20 milliseconds. What about if we do 100 million? We'll run that, and now it's still computing, still going. There we go. So that took 176 milliseconds. So this is a good example of linear time. The bigger the input, the longer it's going to take. So this is linear, or O of n. And O of n is like I said, probably 95, even more than that, 98% of what we've done already are O of n. Okay, so now we're going to look at an example that has the complexity of quadratic time, or O of n squared, where n represents the size of the input. And quadratic time means that the time required to complete the function is proportional to the square of the input data set. So this is less efficient than linear time. And the example that I'm going to give you uses a nested loop. So a lot of times when you see nested loops, it may have this complexity. So let's say sum array. I'm going to take in an array, and then we're going to create a variable called sum, set that to 0, and let's create another variable called sum2 and set that to 0. Then we'll loop through the array, so this will be our outer loop. Say let I array length. Okay, so that's our outer loop, and in here we're going to, just like we did in the last video, we'll set the sum to the current element. Then after that, I'm going to open up another loop, and let's say let j equals 0 as long as j is less than array dot length, and then we want to increment j. And then in the inner loop, we'll take sum2, and let's say actually up here we want to make sure we do plus equals, otherwise it'll just replace it. So this one will be array and pass in j as the index. And then what we'll do is go outside of the outer loop, and we're going to return sum plus sum2. All right, so this function exhibits quadratic time complexity, or O of n squared, due to the presence of the nested loop. So basically the outer loop iterates over each element of the input array, and then the inner loop iterates over the array again for each outer loop iteration. As a result, for every element encountered in the outer loop, the inner loop iterates over the entire array. So this leads to a significant increase in the number of operations performed as the input size grows. So for an array of, let's say, length n, the number of total operations becomes roughly proportional to n times n, so n squared, resulting in a quadratic relationship between the input size and the runtime. So to kind of test this out, let's do the same thing that we did. Actually, I'll just copy from here. We'll just grab that, and we're going to go under this one, and we can still say sum array because that's what it's doing. So we'll pass in array 1, which is just 5 items. We're going to sum the array, and then here we're creating, let's do 1 million. So 3 zeros, 1, 2, 3 more. That's sum array 2. All right, so let's try this out. We're going to save, and let's run the code, and it's still going. I might even have to stop it and lessen the length of the array. But this is good. This shows you exactly what I want you to understand, is that the bigger the input, the longer it's going to take, and this is less efficient than linear time. We passed in the same input. I think when we did 1 million with linear time, it was like 8 milliseconds. So yeah, I'm going to have to stop the code, and let's just take off a couple zeros. So we'll do 10,000, and let's run that. All right, so 10,000 I passed in the second time. So it went from 2 milliseconds, almost 2.5 milliseconds, to 165 milliseconds for 10,000 items. Okay, so that's quadratic time. In the next video, we're going to look at logarithmic time, which is even more efficient than linear. Okay, so now we're going to look at logarithmic time, which is O of log n. So logarithmic time means that the time required to complete a function is proportional to the logarithm of the input data set. So this is the most efficient. Well, I mean, constant is the most efficient, but there's not much you can do with constant. So the example that I'm going to give you here is actually going to be a recursive solution. So we're going to create a function called find power, and it's going to take in a base and an exponent. And I think we did this as a challenge, but I don't think we used, did we? Yeah, we did use recursion, but I believe it was an O of n solution, not an O of log n. So this one is O of log n. Now we're using recursion, so we're going to have a base case. And remember from the last power example we did, anything to the power of 0 is 1. So that's going to be our base case. If the exponent is equal to 0, then we want to return 1. Okay, now the function that we're going to write exploits the property that any number raised to an even exponent can be split into 2 halves. And the result is the square of the number raised to half the exponent. So what I'm going to do is check to see if the exponent is even first. So let's say if exponent modulus 2 is equal to 0, then it's even. So if that's the case, let's create a variable called half power, and then we're going to recursively call find power. And what we want to pass in is the same base, but the exponent we want to divide by 2. Okay, then we want to return half power times half power. So that's if it's even, else. So if it's odd, then we're going to create a variable called half power. And this time we're going to, again, call the function recursively with the same base, except the exponent. Let's open up another set of parentheses here. We want to take the exponent minus 1 and then divide that by 2 if it's odd. And then what we can do is return the base times half power times half power. All right, so this is obviously a more complicated solution than just a straightforward multiplication-based approach, but this achieves a much more efficient computation and should be much faster and work much better with really large numbers. So let's come down to the bottom here, and we're going to do a console.time. Let's call this find power 1, and then we're going to time end, and then let's call the function find power, and we'll pass in 2 as the base and 100 as the exponent. All right, and then let's take this, copy it, and then find power 2, and now we'll do 1 million as the exponent. And then let's run the code. So we get find power 1, 0.75 milliseconds, and then 0.009 milliseconds. So you can see that it's actually faster when we pass in larger numbers. 1, 2, 3. Let's do a billion. I think that's a billion. Run, and there we go, pretty much the same result, just about. So you can see how efficient this solution is. And I know this still might be confusing, but at least you have an idea now of what time complexity is, the different types, and you have some simple examples to go on. Throughout the rest of the course, I'll be mentioning time complexity in certain parts with certain functions that we write to kind of drill it in your head a little more. All right, so in the next video, I want to talk about space complexity. All right, so we've been talking about time complexity, which refers to how the runtime changes, how it increases when our input increases. So now we're going to talk about space complexity, which is similar, but instead of referring to the runtime, it refers to the amount of memory or storage space that a function or an algorithm consumes based on the size of its input. Now, there's a lot of similarities between time and space complexity. We use the same big O notation to describe space complexity, and we do have constant, linear, quadratic, and logarithmic, as well as some others that we didn't really talk about, like exponential and factorial. We have all those in space complexity as well as time complexity. Now, in many cases, when we look at a function, the space complexity will be the same as the time complexity. For instance, the time will be O of n and the space will be O of n. This is because the amount of memory used by a function is often directly related to the number of operations that it performs. However, that's not always the case. Sometimes a function will take up more memory than runtime and vice versa. So sometimes they're different. And I'm going to show you some simple examples in a minute. But before we do that, let's take a look at some space complexity rules. So variables and data structures take up space. When you declare variables or you use data structures like arrays and objects in your code, they occupy memory space based on their size and data type. So the space complexity increases with the number and size of variables and data structures in your program. Number two, function calls take up space. So whenever you call a function, the program needs to allocate memory for the function call stack. And that includes function arguments, local variables, return addresses, and other bookkeeping information. And each function call adds to the space complexity. And if you have nested function calls or recursive functions, it can lead to a significant increase in space usage. Number three, the space complexity of a function is the sum of the space complexities of all the variables, all the data structures, and all the function calls inside of your function. This means that to calculate the space complexity of a function, you need to consider all the variables, data structures that are used within your function and their space requirements. Additionally, if the function makes any recursive or nested function calls, you need to account for the space used by those functions as well. All right, so now we're going to just take a quick look at some examples, some simple functions, and it says the space and time complexity for each function, but I really want to focus on the space because we've already gone over the time complexity. So this first function add takes in num1 and num2 and just adds them together and returns it. So this has a space complexity of constant, or O of 1. And that's because the function doesn't create any additional data structures or variables that depend on the input size. So it simply returns the addition, so the amount of memory used by the function doesn't change depending on the input here. It's always going to be constant, and it's O of 1 for both time and space. Now the second function here, create array, takes in a number. It initializes an empty array and then adds on to it through this loop. So this one is actually linear. It has a time complexity of O of n, which is linear, and a space complexity of O of n. And the reason for that is because the function creates an array and pushes elements onto it using the for loop. So as the input num increases, the size of the array also increases proportionally. Therefore, the space complexity of the function grows linearly with the input. All right, this next one here, create matrix, has both a time and space complexity of O of n squared. It's quadratic. So this is because the function creates a two-dimensional array and fills it with values using these nested for loops. And as the input num increases, the size of the matrix also increases proportionally. Therefore, the space complexity of the function grows quadratically with the input. And then this one here, this is the same function we did in the last video, find power. this has a time and space complexity of O of log n. So this is logarithmic, and that's because the function uses recursion to calculate the power of a number, and as the input exponent, as this increases, the number of recursive calls increases logarithmically. So the space complexity for this is O of log n. And then this one down here, find sum, this is one where the time and space complexity are actually different. So the time complexity is linear, it's O of n, and that's because the function uses a loop to iterate through each element of the array and perform a constant time operation, adding the element to the sum. The number of iterations is directly proportional to the size of the array, the size of the input. Now the space complexity is O of 1, which is constant, and that's because the function only uses a single variable called sum to store the result, and the space used by the variable doesn't depend on the size of the input array. So it remains constant regardless of the input size. All right, so what I want to do next is get into a challenge where I'm going to give you a quadratic solution, which is not very efficient, using nested loops. And then we're going to talk about something called the sliding window technique, which will allow us to make our code more efficient and reduce the time complexity. So we're going to have the same challenge, but use a linear solution in the video after that. All right, guys, so in this challenge, we're going to do a maximum subarray sum. And we're going to specifically use an O of n squared solution, or a quadratic solution, which is not very efficient. And the reason I'm doing this is because later on, a couple videos from now, we're going to refactor this into an O of n, or a linear solution, which is our complexity, which is more efficient. And we're going to use something called the sliding window technique. But for now, we're going to stick with a quadratic solution using nested loops. So it says write a function called max subarray sum that takes an array of integers and a positive integer k as input. The function should find the maximum sum of any subarray, meaning any consecutive numbers, of the length of k. And it should use an O of n squared solution by using nested loops. We'll revisit this and use the sliding window technique to make it more efficient. We'll do that in a later video. So for example, if we were to have this array here, so we'll pass that into the function, and then as a second argument, we'll pass the k number in, which can be from 1 to whatever the length of the array, in this case 3. So we're going to look at subarrays of 3 numbers, right? So it could be that, it could be that, it could be that. So the highest sum, whichever have the highest sum, and what we want to output is the highest sum, okay? So if we were to pass in this array in 3, the highest sum would be 24, which I believe is 11, 7, and 6, I believe, yeah. And then here, we could use negative numbers as well, pass in a k number of 4, and it would look at the sum of 4 numbers. Okay, and they have to be consecutive. Remember, it's a subarray that we're looking at. It's not just any 4 or 3 numbers. So constraints, the input integer k will be between 1 and the length of the array. Hence, you can use 2 nested loops, or I should say a nested loop, to iterate through all possible subarrays of length k and calculate their sums. So let's go into the, where is it, the JavaScript file. And we're going to pass in the array, and then whatever k is, which will be a number between 1 and the length of the array. So let's initialize max sum. We'll set that to 0. Ultimately, that's going to be what we return. Now we want to do our outer loop. Now, we want the outer loop to go up to the array length minus k. If we look at the run file here, we're going to be passing this array in and then a subarray of 3. So it's going to look at, arrays or subarrays of 3. So we don't want to go past where we can't have 3 anymore. So on the outer loop, we're going to say for let I equals 0, but then we want to set as long as I is less than or equal to the array length minus whatever k is, and then increment. Now within here, we're going to create a current sum variable, and we're going to set that to 0. And then we need an inner loop or a nested loop to iterate through the subarray with the length of k starting from the index I. So let's say 4, and for this one we're going to use j as a variable, and we want to set j equal to whatever I is. And then we want to say as long as j is less than I plus k, and then increment j. And then what I'm going to do here is just console log so you can see exactly what we get when we do array j. So what are we actually getting in this nested loop? So in the run file, let's run it, and you'll see we get 2, 5, 3, 5, 3, 1. We get a lot of numbers, more than you see in the array, because what it's going to be doing is adding by 3. So it'll do 2, 5, 3. That's why you see the first 3, 2, 5, 3. Now the next 3 is 5, 3, 1, because this is going to move over 1 and then do 5, 3, 1. After that, you see 3, 1, 11. So from here, it's going to move over to the next one, 3, 1, 11. Then it's going to go 1, 11, 7. So 1, 11, 7. Then it's going to go 11, 7, 6. 11, 7, 6. Then it's going to go 7, 6, 4, 7, 6, 4. So it's going to hit all the 3s. And then what we'll do is take that. So I'm just going to get rid of the console log around it, and we're going to add that to the current sum for that iteration. So we have the current sum. I'm sorry, we need plus equals. So it's just going to keep taking those and adding to the current sum. Now let's go outside of the for loop and let's see what we get for each current sum. So now we'll run this, and now you see the sum of the groups of 3 that I just showed you. So 2, 5, 3 is 10, 5, 3, 1 is 9, 3, 1, 11 is 15, and so on. If we look, the maximum here is 24. So we know that, but how do we get that from our code? So what we can do is then set the max sum. Right now before we go through any iterations is going to be 0. And we're going to set that to, and then we can use math.max and then pass in the max sum, and then also pass in current sum. So that will look at all these through every iteration, and whatever the max is going to get put into this, which in this case should be 24. So then all we have to do is go outside of both loops and then return the max sum. So let's go ahead and run this, and we get 24. And let's run our test. Okay, and the test has negative numbers in it too. And let's see, that failed. Receive 0. Oh, you know what? I think we need to... So max sum, I believe for negative numbers, we have to set this to negative infinity. Let me see if that works. Yeah, that works. And I know that seems a little weird setting this to negative infinity, but basically by setting it to that as the initial value, we guarantee that the first valid subarray sum that we encounter will be greater than this number. Everything's going to be greater than this, even if all of the numbers in the array are negative. So that ensures that the algorithm behaves correctly regardless of the values in the array, if that makes sense. All right, now in the next video, I want to talk about something called the sliding window technique, because this function here has a complexity of quadratic, of O of n squared, which is not that efficient. What I want to do is create a solution that does the same thing that's linear, that's O of n. So we're going to do that using the sliding window technique, but I want to talk a little bit about how that technique works in the next video before we attempt it. All right, guys, so we're touching on a lot of different topics and concepts in computer science in this course, and this is just another one to kind of put in your toolbox. So this is called the sliding window technique, and it's a powerful algorithmic approach that's used to solve various array or string related problems efficiently, and it involves maintaining a window that slides through an array or a string, allowing you to track and process a subset of elements without the need for nested loops. And you can just see right off the bat, if you look at this image, how this can help us in the last problem we just did. So we have a sliding window around a certain number of elements, and this is that k number. So here I have 3. So basically we start at the 3, and then we can slide over 1, and we have the next 3. Slide over 1, have the next 3, and so on. So you can already probably see how we can solve our problem of finding the maximum sum using this technique. So in the last video, we did a subarray sum algorithm, and we used nested loops. It had a time and space complexity of O of n squared, which is not very efficient. So in the next video, we're going to refactor that solution and make it linear, or O of n, by using this technique. So I just want to kind of go over this a little and talk about how it works. So basically, we first initialize our variables. A lot of times you'll set up 2 pointers, usually named like left and right, to define the boundaries of the sliding window. Additionally, you might need variables to store the current state, like sums or frequencies. For our example, we'll need a current sum and a max sum. Number 2, the initial window, you start by positioning it at the beginning of the array or string, because this can work for strings as well, and you calculate the initial state or value based on the elements within the window. So you can see the first 3 here would be in the window. Since we're getting the sum of the first k elements, then we're going to start with whatever k is. This image I used 3, but it could be anything. So number 3, we slide the window, so we'll move it, or move the right pointer to the right, expanding the window by 1 element, and then you'll update the state or value based on the newly added element. In our case, we'll calculate the new sum with the new element. Number 4, adjust the window. So depending on specific conditions or constraints, you might need to shrink or adjust the window by moving the left pointer to the right, thus excluding an element from the window, again updating the state accordingly. That doesn't really pertain to what we're doing. And then number 5, repeat. So continue sliding and adjusting the window until the right pointer reaches the end of the array or string. During this process, you can keep track of the desired information, whether that's a max or minimum value, a frequency, a substring, whatever it might be. All right, now the advantages of this is optimized time complexity. So sliding window reduces the time complexity by avoiding redundant calculations like we did in our nested loop solution. And it's particularly beneficial for situations where brute force solutions would require nested loops. Space efficiency, the technique doesn't require storing all individual subarrays or substrings, so it reduces memory usage. And then simplicity. Once understood, the sliding window problem can become easier to solve compared to some other types of techniques. So this is something you can use in the future with other problems. All right, so I just wanted to kind of go over the gist of it before we jump into it, but now we're going to solve the max subarray challenge using the sliding window technique. Okay, so we looked at the sliding window technique, and it might not be completely clear to you guys, but we're going to try and use that to create a more efficient solution for this maximum subarray sum. All right, so this is going to work the same way. We're going to pass in an array and a k value, and we're going to get the highest sum of the subarrays. All right, so constraints, the input integer k will be between 1 and the length of the array. Hence, you can use the sliding window technique to efficiently track the sum of subarrays of length k as you iterate through the array. So just keep this image in your mind, right? And this is the actual numbers in the run file. So we just want to sum the first three. That'll be the very first thing we do, and then slide it over, sum the next three, slide it over, sum the next three, and so on. And then when it comes time to compare the current sum to the maximum sum, it'll be the same way we did it in the other solution where we use math.max. So if you do want to pause the video and try it, that's okay, but I don't really expect most of you guys to get it, especially if you've never done this before. So let's pass in array and k, and we're going to initialize the current sum to 0, and we're going to initialize the max sum to 0. And the first thing I want to do is calculate the sum of the first three elements. So right away we'll put something in that max sum. So let's say 4, and we'll say let I equals 0, and we're going to say as long as I is less than k, and then we're going to increment by 3. So whatever k is, and in the run file we're passing in 3, but it could be anything. So we're going to say as long as the I is less than that. So that'll be the first 3 or first 4, whatever k is. And then we're going to take the max sum and we're going to add to it, so plus equal whatever is in that for that value, for that number in the array. All right, so that'll get the sum of the first 3. And we can check that out. We can do we can just return max sum for now and open up the run file and run, and it should be 10 because 2 plus 5 plus 3 is 10. All right, now the next thing we're going to do is set the current sum to the max sum. So I'm going to say current sum is going to be set equal to the max sum. Then we want to basically slide the window and calculate the max sum for each 3 or each whatever k is. So let's do another for loop here. This is not a nested for loop, mind you. It's after this for loop. So in here we're going to say let I equals k. All right, so that's where we're going to start, and then we're going to say as long as I is less than the array dot length, and then we're going to increment. And then in this loop, we're going to basically update the current sum by subtracting the element that left the window and adding the new element. So again, if we look at this image, we're going to subtract the one that left, and which in this case would be 2, and then add the one that's coming in, which would be 1. So the way we can do that is by taking the current sum, setting that equal to the current sum, and then we want to subtract array, and for the index we're going to do I minus k, and then add the one that's coming in, which would be array I. Okay, so again, this is subtracting the element that left the window and adding the new element. And we could do a console log here of current sum. So if we run that, you can see 9, 15. So it would be 9, and then this would be 15, and then this would be 19, and that's what we're seeing here. All right, now we want to update the max sum. So within this for loop still, we're going to set the max sum equal to whatever the max of those numbers, which is going to be 24 in our case. But we can do it the same way we did in the other one. We said math.max and pass in the max sum as well as the current sum. And then outside of the for loop, we're just going to return the max sum. Okay, so I think this is a cleaner solution. It's just cleaner looking and it's more efficient. So let's try it out. Let's go to the run, and we get 24. And if we run our tests, let's go to the terminal, and we actually have to rename the test file. Okay, and then we'll go ahead and run our tests, and it passes. All right, cool. So hopefully this whole example of this max subarray sum helps you kind of understand that we can have a solution for a problem or multiple solutions, and they can be different complexities. Okay, so this is more efficient than using the nested loops. And the big reason why is because of redundancy. So if we look at the array that we are passing in with the nested solution, the O of n squared, when I equals 0, we would calculate 2, 5, and 3, right? When I equals 1, we would do 5, 3, and 1. However, 5 and 3 was already calculated in 2, 5, and 3. And then when we move to 3, 1, 11, 3 and 1 was just in 5, 3, and 1. So there's a lot of recalculation going on, where with the sliding window approach, it addresses those issues by updating the sum as the window slides. So basically it subtracts the element that leaves the window and adds the element that enters the window. This way, the sliding window approach reduces redundant calculations and it improves efficiency. All right, guys, so now we're going to get into data structures, and the first types of data structures that I want to look at are hash tables, as well as some of the built-in structures that are similar to hash tables in JavaScript. So a hash table or a hash map is a data structure that implements an associative array abstract data type, and it's a structure that can map keys to values. And a hash table uses something called a hash function to compute an index, also called a hash code, and it computes it into an array of what we call buckets or slots, and that's where the desired value can be found along with its index. So here we have our keys on the left, which are just names of people, and we've stored the values on the right, which in this case is their phone numbers, and in the middle we have a hash function. So the hash function is a function that takes in a key and returns the index. The index is used to determine where the key value pair should be stored in the hash table. So the hash function should always return the same index for the same key. Now, there is something called hash collisions that can occur when you use hash tables, and a collision occurs when two keys are mapped to the same index. A good hash function will evenly distribute the keys across the hash table, and this will minimize collisions and it will improve the time complexity of the hash table, which I'll talk about in a minute. Now, in JavaScript, we have some built-in structures that use hash tables. Even an object is an example of a hash table because the data is represented in key value pairs. We also have maps and sets as data structures, and we've dealt with these a little bit back in the challenges in the beginning, but maps and sets use a hash table. In this section, I want to do some challenges that use maps and sets, but after that, we're going to implement our own hash table from scratch. So basically, we're going to create a hash table class that has methods to access the key value pairs, to add them, to remove them, etc. Now, we talked about complexity in the last section. So when it comes to hash tables, they're a great data structure for fast lookups. And the average time complexity for lookups, insertions, and deletions is O of 1, which is constant. So very fast, but collisions can slow down the time complexity to O of n, or linear. The space complexity of a hash table is O of n because we have to store all the keys and values in the hash table, and the size of the hash table is proportional to the number of keys and values. Okay, so that's time and space complexity when it comes to a hash table. Now, some of the common methods you'll see on a hash table are set, which will take in a key and a value, and that will just add a key value pair to the hash table. We have get, which will return the value associated with whatever key you pass in. Remove, which will remove a key value pair based on the key you pass in. Has will check to see if a key exists, so it'll return true or false. Keys will return an array of just the keys in the table, and values will return all the values in the table. All right, so like I said, we'll be implementing our own hash table class, but before we do that, I will just want to look at map and set and do a couple challenges with those before we create a custom hash table. Okay, so we're going to get into some challenges that use the map data structure in JavaScript, but I just want to quickly go over map for those of you that aren't that familiar with it. I know a lot of you are, so you can skip this video if you want, because I'm just going to go over the basics, all the methods, how to create a map, etc. So let's go ahead and create a new map. I'm going to call it name map. And the way we create one is we just say new map. And I can go ahead and console log name map. And if I run that, you see we have a map. There's just nothing in it. Now to add key value pairs to it, you can either you can use the set method, which I'm going to show you in a minute, or you can, or I should say, and you can add values initially in here. So we're going to put in a set of brackets, and then each key value pair is going to be wrapped in brackets. So for this one, let's say we want the key to be 1 and the value to be a string of a name. So say John. And then we'll add a couple others here. Let's say Jack. That key will be the number 2. That key will be the number 3. And we'll say Jill. All right, so now if I go ahead and log the names or log the map, we should see the key value pairs. Now, one big difference between a map and an object in JavaScript is with maps, you can use any data type as the key. It can be a number, a string, a Boolean, a function. So I'm just going to give you some examples of that. Let's create another map. We'll call it map2. And we're going to say that's going to be a new map. And let's add, for the first one, we'll do a string as the key. So we'll say a string of name. And then the value will be John. Okay, we've already looked at numbers, but again, we can use a number. So we'll say 1. We'll set the value to just a string that says number 1. Now we can also use a Boolean. So let's use true. So now the Boolean is actually the key, and we'll just say really true. And then we can also do null. So for the value, we'll just have a string of null, but for the key, we'll use null. And then we can also use a function. Let's say my function for the string, and then what I'll do is up here above where we created the map, I'll say const my function, and we'll just set that to an empty function, and we can use that as the key. So right here we can say my function, and then we can also use an object. So if we wanted to create, let's say my object, set that to an empty object, and we'll copy that down, and we can use my object. Okay, so that's all perfectly valid. If I were to console log map2 and we run that, you can see all the different types of keys. Now to get values, let's say get values, we can use the get method. So let's actually do a console log of, let's get from the name map dot and get the key of 1. So it's going to look in the name map here, it's going to look for the key that's 1, and it's going to give us John back. So if I run this, you can see we get John. If we want to get from map 2 one of the other types of keys, let's say from map 2 we want to get the function, whatever is in, let's say my function. If I do that, you see we get the string of my function. So we use that as a key. If we want to get the object, we could say my obj, and that shows us the string of my object. Now to set values, let's say set values, we can use the set method. So we can simply say name map dot set, and this is going to take in two things, the key and the value. So let's say for 4 we want to set Mike, and then we'll do for 5, we'll set Sarah. And then let's go ahead and console log the name map. And I'm actually going to just comment these out. And if we run that, let's see, Mike, we need to put quotes around these. So if I run that now, you can see that Mike and Sarah have been added to the map in the key of 4 and 5. So that's setting values. If you want to check values, we can use the has method. Let's say check values. So I'm gonna do a console log here, and on name map I'm gonna say dot has, and then we can pass in the key that we want to look for. So we'll do one with 1, and then we'll do one with 10, which we know there isn't a 10. So if I go ahead and run that, then we're going to see true for 1 and false for 10. So obviously you can put that in an if statement. Now deleting values or removing values, let's say remove values, we can use the delete method. So let's say name map dot delete, and let's say we're going to delete 1, and then I'm going to move, let's see, I'll just copy this has 1. And now if I go ahead and run that, you'll see the very last one is false because we're checking for 1. It's true here, so that's true. 10 is false. Then we delete 1, and then we check for 1 again, and it's false. Now, if you want to get the size of a map, you can use the size method. So let's say get size, and we're just going to do a console log of name map dot size. I'm sorry, size is a property, not a method. So no parentheses. And then we run that, and you can see we get 4. And we have 4 because, remember, we deleted 1. So next I want to look at just iterating. So iterating over a map. And there's a lot of ways to do this. I'll show you how we can do it with a for of. So let's say for, and we can say let, and we want to get the key and the value. So in brackets, we can say key value of, and then the name of the map, which is name map. And then I'm going to do a console log of the key and the value. Okay, so if we run that, we should see all of the keys and the values. So 2, remember we removed 1, so that's not going to show. We can also use the for each high order array method. So let's say name dot, name map dot, and then we'll say for each, and we'll say for each name, we want to console.log, and actually if we want to get the, let's do that. Let's use key and value. So first would be the value, which I could use name, but I'm going to use value, and then key for the index. And then we should be able to log key value. So we should see it twice, one for the for of and one for the for each. Okay, so we see it twice here. All right, now we can also use the keys method to loop through just the keys. So let's do, actually I'll say get keys, and then we'll do a console log of the name map dot keys. If I do that and I run, go to the bottom here, we'll see that it's what we call a map iterator, and it loops through and it gives us all the keys. And we can do the same for the values. So let's say console log name map dot values, and if we run that, then you'll see at the bottom here we have a map iterator with all of the values. Now the last thing I want to show you is just how to clear the entire map. So we do that with the clear method. Let's say name map dot clear, and then let's console log the name map dot size, which should then be 0. Run that. At the bottom we see 0. Okay, so those are the methods and properties that you can use on a map and how you create a map. So now we're just going to do a couple small challenges using maps. Okay, so in this challenge, we're going to be using JavaScript maps. So write a function called word frequency counter. It's going to take in a string as input and returns a map that represents the frequency of each word in the string. We did a similar challenge to this back in the count occurrences challenge. So this function should count the occurrences of each word, ignoring case and excluding punctuation. So for example, if we were to pass in the string of the quick brown fox jumps over the lazy dog, then we should get an output of a map that has each word. You can see the is in there 2 times, quick is in there once. I think everything else is once. If we pass in this, just some lorem ipsum, those would all be 1. Pretty bad examples. I should have put some better examples, but you get the point. So the input string will only contain letters, spaces, and punctuation marks. You can use the toLowercase method to convert the input string to lowercase, so you can ignore the case when counting the word frequency. Regular expressions can be helpful for splitting the string into words and removing punctuation marks, although you don't have to. You can use a map to store the word frequencies, where the word is the key and the count is the value. Loop through each word, update the count in the map, and return the final map. All right, so let's jump into it. We're going to go into the JavaScript file here. And from here, we know we're going to paste in a string. And the first thing I want to do is convert the string to lowercase and split it into an array of words. So let's call this, let's say, const words. And we're going to take the string and toLowercase it. And then we're going to split it into an array of words. Now you might put a space in here. However, there could be punctuation, so we want to account for that. So what I'm going to do is, instead of putting a space, I'm going to put a regular expression. So let's put our double // and then we're going to do \uppercase W, which is going to match any non-word character. So punctuation, spaces, anything like that. And we want to get all the occurrences of it, so we're going to use the plus quantifier. So that should get us our words. In fact, we can console log words, and then let's go into the run file. And now, if we run that, you can see our array of words. Now, there is an empty string in there, so we do want to account for that later on. So the next thing we're going to do is create the map for the word frequency. So let's say const word frequency, and we'll set that to a new map. And then we're going to loop through each word in the array. So I'm going to use a for of. So let's say const word of words. And then here I'm going to check to see if the word is an empty string. So let's say if the word is equal to an empty string, then we can actually just continue. So we can do that. And then if the word is already in the map, we just want to increment its frequency. If it's not, then we just want to set the frequency to 1. So let's check. Let's say if word frequency dot has, okay, remember we're using the has method, and then word is going to be the key. And then we'll take the word frequency and we're going to then set. Now this is in the case where it's already there, so we want to increment it. So what we're going to set it to, let's say set word, so pass in the key, and the value we're going to want is word frequency dot get word, which will be the number, right? Because the number of occurrences is the value. So we want to take that and we want to add 1 to it. Else, so if it's not there, then we're simply going to set it. So we'll say word frequency dot set, and we want to set word to, we're just going to set it to 1 because it's the first occurrence. And that's it. Now outside of the loop, we're just going to return the word frequency. So now let's run this file, and we get a map, and you can see the word the is there twice. If you want to type something else in here, you can, but let's go ahead and run the test. So I'm going to rename this to .test. And then let's run that. Okay, so it looks like something failed. Oh, the file name is wrong. So I'll fix this for you guys, but this is wrong. This should be word dash frequency. What is it? Yeah, word dash frequency counter. All right, let's try that again. Okay, so now it passes, and I'll change that for you guys. But that's it. Let's look at another challenge where we use maps. All right, guys, so this is a fairly easy challenge, so I'd like you to try it on your own, even if you haven't really been doing that as we've been going. So this is called phone number directory, and basically we're going to have a function called phone number directory that takes in an array that's going to look like this. So it's an array of strings that are formatted with the name, colon, and then phone number. And what we want to do is return a map with the name as the key and the phone number as the value. All right, so this is pretty easy. So constraints, the array elements that are passed in should look like this, the name, phone number. Hints, you can loop through the input array and then split the method to separate the name and the phone number in each element of the array before adding to the map. So let's jump into the JavaScript here. It's getting passed in an array, which I'm going to call phone numbers. And then we're going to create our map. I'm going to call it directory. So we'll set that equal to a new map. And then we're going to loop through the array that's passed in. I'm going to use a for of. So we'll say const, we'll call it entry of phone numbers. Okay, now we want to split each entry on the colon. So, and we can destructure with this. So we'll set some brackets to entry dot split, and we're going to split on the colon value character, and then we'll say we want this to be name, and then the second one will be phone number. Then we just want to add it to the map. So let's say directory. We're going to use the set method. For the key, we're going to use the name. For the value, we're going to use the phone number. Then after the for loop, we're just going to return our directory. And that's it. So let's go to the run file, and you can see we have our phone numbers array. It's being passed in, and then we're logging for .get, or for the key, we're logging Joe. So it should show the value, which is that phone number. So let's run this file. And there we go, we get the number. If we put in here John and we run that, then we get John's number. If we want to log the entire thing, we could just log result, and you can see our map. Okay, so hopefully you guys got it. In the next one, we're going to work with anagrams again. All right, guys, so in this challenge, we're going to be working with anagrams again. If you don't remember from the past challenge, anagrams are words or phrases formed by rearranging the letters of another word or phrase. For example, cinema is an anagram of Iceman. They have the same characters and the same amount of characters. So if we look at an example here, what we're going to do is pass in an array of strings, and we're going to output an array of arrays of anagrams. So in this case, we passed in cat, act, dog, god, and tack. So cat, act, and tack are all anagrams of each other, so those are going to be put into one array. And then dog and god are anagrams, so those will be put into another array. This is another example. Listen, silent, and enlist are all anagrams, so those will go into a single array. Hello and world are not anagrams of anything, so those will just be in their own array. Okay, so as far as constraints, the input array will contain only lowercase alphabetical characters. Hence, you can use a map to store the anagrams where the key is the sorted characters of each word, and the value is an array of words that have the same sorted characters. So basically, we're going to use a map to keep track of them, but that's not what we want to return. We want to return an array. So you can use array.from to convert a map to an array. And you can sort a string by splitting it into an array of characters and calling .sort, and then you can join it back into a string. And that's quite a few hints there. But if you guys want, pause the video, try it yourself. So let's jump into our JavaScript file here. We're going to pass in our array of words. And first thing I'm going to do is create the map. So I'm going to call it anagram groups. And we'll set that to a new map. And then we're going to loop through the words array that's passed in. So let's say const word of words. And then I want to get for each word, I want to sort the characters alphabetically. So we can do that by, let's first just create a variable called sorted characters or sorted chars. And then we're going to take the specific word, because we're looping through all the words, we're going to split it into an array of characters with split. And then we're going to sort it with sort. And then we're going to use join to join it back to a string. Okay, so if I were to now console log sorted chars, and then we go to our run file, we're passing in this array. So what it should give me is each of these words sorted. So if I go ahead and run this, you'll see we get act. So it's looking at the first one, cat, and it's sorting it alphabetically, which would be act. Act is already sorted. Dog would be DGO. So we have DGO twice for that, and then act again. So they're all sorted. Now, what we're going to do is first check to see if those sorted characters are already in the map. And if they are, we're going to add the word to the array. And if they're not, we're going to create the array. So let's check. Remember, we can check if something is in a map by using has. So we'll say anagram, anagram groups, and then we're going to use .has, and if it has the sorted chars, then we're going to take our anagram groups map and we're going to get the sorted chars, and we're going to push that on. We want to add that to the array, so we're going to push on word, okay, to that array. Else, then we want to create the array with the word. So in that case, we'll say anagram groups dot set, and pass in here our sorted characters, and then we want to create an array with that word. Whoops, that should be a comma. Okay, now we want to return an array. So after the for loop here, instead of just returning the map, which is not what we want, we're going to return array.from, which will take in an array-like object and make it an array. So what we can do is pass in our anagram groups map and then use .values, which remember is a map iterator, okay, because this will take in an iterable object, and this gives us an iterator of the values. So now let's save that and let's run the file here, and we get back an array with another array that has all the anagrams for cat and then the anagrams for dog or god. So now let's test. Terminal npm test, and should pass. There we go. So no failures. Good. So let's move on to the next challenge. Okay, so now we're going to get into sets, which is another built-in data structure. The sets were added, I believe, in the ES 2015 update for JavaScript. And they're a collection of unique values. So a set can contain any data type. You can loop through a set in an insertion order. Insertion order is the order in which the values were added to the set. A set is similar to an array, but it's not indexed and it doesn't contain duplicate values. So even if you add duplicate values, it's not going to have, it's just still going to only have one of that value. So let's just go over the basics here. And again, if you already know enough about sets, you can skip this video. But to create a set, let's call this name set. We'll do kind of the same thing we did with the map. So we can say new set. Now again, we can, just like with map, we can just create an empty set and then we can add using the add method, or you can also add initial items here. So we're going to put some brackets and then let's say John, Jane, and Joe. Okay, so if we console log the name set, we run this file, you'll see we have a set with 3 strings in it. Now, if I were to add in here, let's say John again, and then I run the code, you'll see I still have 3 items. It doesn't have John twice. So sets always have to be unique, which makes them useful for certain cases. So let's see, we can add names, we can add items here. Now to add them, once you've already created the set, you can use the add method. So let's come down here and let's say add to set. So we'll do name set dot add, and we'll add Jack. Let's copy that down. We'll add Jill, and then I'm going to run the code again, and you can see that Jack and Jill have been added to the set. So next thing, we can check for values. So let's say check for values. So we can do that with the has method, just like with maps. So for instance, we can console log nameset.has, and let's say Jack, and then we'll do another has for Brad. So if I run this, you'll see we get true for Jack and false for Brad. We can also use the size method. So let's console log nameset.size, which is a property. I always get that messed up. There's no parentheses. So if we run that, you'll see the size is 5. And we can also get the values. So we'll console log nameset.values. That is a method. And I'm just going to get rid of this last console log. All right, so if I run that, you'll see we get what's called the set iterator. Just like when we use values on a map, we get a map iterator, and it just shows all the values. We don't have a keys method because there are no keys. They're just single values. So a good way to look at it is like a map is similar to an object in JavaScript, and a set is similar to an array. Now we can iterate through the set. So for instance, we could use a for loop, a for of loop. Let's say const name of name set, and then let's console log name. So if I run that, it's just going to print out all the names. Now if you want to convert a set to an array, let's say convert to array, let's say const name array, and all we have to do is we can create an array, and then we can spread across the name set. And then we'll do a console log of the name array. And now down here you see we have an array of those strings. And then lastly, we can clear the set. So we'll say name set dot clear, and then I'll console log the name set dot size, and we should get 0. All right, so those are the main methods when it comes to sets. So what we're going to do now is get into a couple challenges where we can utilize sets. So in this challenge, we're going to look for the symmetric differences between arrays. So we're going to have a function called symmetric difference that takes in 2 arrays and returns an array containing the symmetric difference of the 2 arrays. The symmetric difference is a new array containing only the elements that are present in one of the arrays, but not both, with no duplicates. So if we look at the examples here, we're passing in an array with 1, 2, 3, and an array with 3, 4, 5. So in that case, we should return an array with 1, 2, 4, and 5 because 3 is in both, so we don't want to return that. Right here, we have one bunch of two twos, 3, 4, 2, 3, 3, 4, 5. So from here, we would return 1 and 5 in the array because those are the only two that are not in both. So here, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. These are obviously all the same. So, or they're in both arrays, so it would be an empty array. 1, 2, 3, 4, 5, 6. This would be all of the characters because there are none that are in both. Okay, so you can use two sets to keep track of the elements in both arrays and then find the elements that are present only in one of the sets. So I'm sure that a lot of you guys could do this on your own. So if you want to try it, go ahead and pause the video. So let's jump into the JavaScript file. We're going to pass in array 1 and array 2. And then I'm going to create two sets. So we'll call this one set 1. Let's say new set. And we can just pass an array into it. So it'll just create a set with that array. And if there's, this is important, if there's any duplicate values, then it's not going to show in the set. So let's say set 2, or I should say it's not going to get added to the set. So we'll say array 2. And just to show you that, let's do a return of set 1. And I'm going to go to the run file. And you can see we're passing in two arrays. Now I only want to deal with one because that's what I'm returning, just to show you that if I do this, put in a bunch of 3s, and run my code, we need to run the run file. So the set only has 1, 2, 3, even though I passed in an array with, 4 3s. So it's going to get rid of those extra 3. So that's important to know. Now we're going to return an array, so let's create a result array. And then we're going to do a for loop where we loop through array 1. So let's say const, we'll call it num, so each one we'll call num in array 1. And then what we want to do is check to see if the num is not in set 2, because remember we're matching array 1 to array 2. So we're going to check for it. We're going to check set 2, which has the unique values of array 2. So we'll say if not set dot has num, then we want to add it to the result array. So we'll say result dot push, and we want to pass in num. So that takes care of that. Now we want another for loop where we loop through array 2, and we want to compare the values to set 1. I'm sorry, this should be set 2. Okay, because we're comparing array 1 to set 2. So here we're comparing array 2 to set 1. And if it's not there, if that num is not there, then we're going to push it onto the array because we know it's unique, because sets have to be unique. And then after the for loop, we're going to return the result. So let's go ahead and run this. And we get 1 and 4. So if we look here, 2 and 3 are in both of these arrays. So 1 and 4 are, those are the differences. Okay. So let's run our test. And our test pass. All right, so in the next video, we're going to do another challenge involving sets. All right, so this challenge is called toSum, and we're going to write a function called toSum that takes an array of integers and a target integer and returns an array of indices for, or of the two numbers that add up to that target. So basically, if we pass in an array such as this as the first argument, and then we pass in 9, it has to find the two numbers in the array that will add up to 9. So in this case, it would be 2 and 7. So it would return the indices, which are 0 and 1. Okay, because they're in the 0 and 1 position. So for 6, 2 plus 4 is 6. So it would be index 1 and 2 would be in the array. For this one, obviously there's only 2 here, and those add up to 6. So that would also be 0, 1. So constraint, each input integer is unique, and you can use a set to keep track of the numbers that you've seen so far while iterating through the array. So let's try it out. So we're going to pass in an array, we'll call it nums, and then we have a target. So we're going to create our set first. Let's call it num set, say new set. And then we're going to iterate through the input array. So we'll go ahead and use a for loop here. Let's say let I equals 0 as long as I is less than nums dot length and increment. And then we're going to get a complement. So to get the complement, we're going to take the target and we're going to take away the current number in the iteration. So what this does, nums I represents the current number being iterated in the array. Target is the desired sum that we're trying to achieve with the two numbers, and that the target take away whatever the number is gives us the complement that we're looking for. So now what we want to do is check the set and see if it has the complement. Before we do that, though, let me just do a console log here of complement, just in case that's still a little confusing. So I'm going to go into the run file. We're passing this array in with 17. So if I run this, we're going to get, for the first one here, 15, because that's what we need to get to 17 from this number. Second one, we have 10. So for 7, we need 10 to get to that number. That's the complement. 6 for 11, and then 2 for 15. All right, so now what we'll do is at the bottom here, get rid of that, but at the bottom we're going to add the current number to the set. So let's say num set, and then add the current number, which we can get with nums I. So that will add it. Now here, we're going to check to see if the complement is in the set. So let's say if the numSet.has the complement, then we're going to return, and let's say nums, we're going to use index of, because remember we're getting the index of the complement, and then I, whatever I is. So down here, if there's no solution, like if there's not two numbers that equal that, then we just want to return an empty array. So let's go after the loop and just return an empty array, which means there's no two numbers that add to it. So let's try this out. We'll go ahead and run, and we get 0 and 3. So we have 17, and we're getting 0, which is 2, and 3, which is 0, 1, 2, 3, which is 15. So 15 plus 2 is 17. All right, so hopefully that makes sense. We're getting the complement for whatever the current number is for the target. We're checking to see if the target is in the set. We're adding it to the set here, and then here we're returning the index in the array. All right, so this is the first element in the array, which is the index of the complement, and then the current number, of course. Let's actually run the test. Okay, let's run that. And the test pass. All right, so that one was pretty easy, I would say. I had some trouble finding and thinking of challenges that have to do with sets, because they were all pretty similar. All the ones that I was researching had to do with like the one we just did, the difference between two arrays or the intersection of two arrays, things like that. Stuff we've pretty much already done. But the next one is the last one that is going to have sets in it, and it's called longest consecutive. It's a little tougher than the last two, so let's get into that. So in this challenge, we're going to write a function called longest consecutive sequence, and it's going to take an array of integers as input and return the length of the longest consecutive sequence of integers in that array. A consecutive sequence is a sequence of consecutive integers, meaning each integer in the sequence is exactly one more than the previous. So if we look at an example here, if we pass this array in, we're going to get the output of 4 because there's 4 consecutive numbers. It doesn't have to start at the beginning. It doesn't have to end. It's just anywhere in this array. And they don't have to be one after another in the array. They just have to be in sequence in terms of counting. So here we have 1, 2, 3, 4. Those are all consecutive. So the output is 4 because there's four numbers. This one, the output is 10 because we have 0, 1, 2, all the way up to 9. So it's 0 through 9. All right, so as far as constraints, the input array will contain only integers. The input array may contain duplicate integers, and we're using a set. And remember, sets will disregard any duplicate values, so we shouldn't have an issue with that. You can use a set to efficiently find consecutive sequences in the array. So let's jump into our JavaScript, and we're going to pass in nums, which will be an array of numbers. And then I'm going to create the set here called numSet. So new set, and we're going to pass in nums. So we're just going to take that array and add that directly to the set. Then we're going to create a variable here called longest sequence. And we're going to initialize that to 0. Then we're going to loop through the set. So let's say for const num of numSet. And then we want to check to see if not in the numSet, so numSet has, is there a whatever the current num is in the iteration minus 1. Now, the reason for this is because when we're looking for a sequence, the difference between consecutive numbers is always 1. So if you find a number num in the array where num minus 1 is not present, it means that there's no smaller number that can come before num to form a consecutive sequence. So in other words, num can potentially be the starting point of a consecutive sequence. So that's what we're looking for here. Now, if that's true, then we're going to create a variable called current num, and we're going to set it to whatever that num is. We're also going to have a current sequence, and we're going to set that equal to 1. Okay, so we're basically just starting the sequence at 1 because what we want to return is the longest sequence. Now, still within this if, we're going to have a while loop. And what we want to check here is if numSet dot has, and now we want to look for the next consecutive number. So we're going to take the current num, and we're going to say if it has that current num plus 1. So if that's the case, then we just want to increment both the current num and the current sequence. Okay, because that means we're traveling along the sequence. We found the next one. Now, outside of the while loop, let's take the longest sequence variable, and we want to set it to the max of the longest sequence because there might be more than one sequence. So let's say math.max, and we want to pass in here the longest sequence and the current sequence because remember we're still in that for loop. Okay, now after the for loop, so down here, we're going to just return whatever the longest sequence is. So I hope that makes sense. We're looking for basically looking for the start of the sequence here, and we're checking to see if there's another number. So if it finds 1, right, it'll start it there, and then it'll look for the next one, and it finds 2. So then it will look for the next one, it finds 3, looks for the next one, finds 4, and that's the end because there's no 5. So hopefully that makes sense. I just had wicked bad deja vu. That was weird. Anyway, so let's try this out. We're going to go into our run. And it looks like we get an error here. What did I do? Assignment to constant variable. Oh, I put a const. All right, so this should actually be let. All right, let's save that, and let's try to run this again. And we get 4, which is correct. If I add in here 5, and we run this, we get 5. So let's try testing. And that passes. Okay, so that's going to be it as far as sets go. So what I want to do in the next video, since we've talked about maps and sets, which are technically hash tables, now we're going to create our own custom hash table class. And not only that, we're going to do some challenges with that custom class. All right, guys, so now we're going to get into what I think is the fun stuff. And it's going to be a little more difficult than the challenges because now we're implementing a custom data structure with a class. So if you want to try it yourself, you can. I do have a document that basically shows you everything we're going to do and explains it. And of course, I'll explain it as we move on. But we're going to create a custom hash table class that's going to work similar to how maps work. It'll have a set method, a get method. We'll be able to remove. We'll be able to get the values. So it's going to be more code. We're going to be writing more code in this video than we have probably in any other video. And then from here on out, we're going to be creating custom data structures like stacks, queues, trees, and the course will get a little bit more difficult basically from here on out. So let's jump into custom hash table JS, and you can see I already have a class called hash table. And I am assuming that you know object-oriented programming and that you at least know how to create a class, how to instantiate an object from a class, things like that. You know what a constructor is. I'm not going to go over all that stuff again. If you don't know that stuff, I would suggest watching Modern JavaScript from the beginning first, or at least just a basic tutorial on YouTube or something. So we're going to